Good morning. Welcome back to the third and final day of the Humans to Mars Summit. I'm Matt Kaplan of Planetary Radio at the Planetary Society, but here for the people producing the Humans to Mars Summit, which is an annual event here in Washington, D.C. That's Explore Mars. And it is Explore Mars that is ready once again today to bring us a really tremendous lineup of guests. We are coming to you from the National Academy of Sciences, almost across the street from the Lincoln Memorial here in D.C., and right out front as well, if you've never been to the National Academy, well, we talked a little bit yesterday with a representative of the National Academies about this is a place that you might want to consider visiting when you come to D.C., but you don't even have to come inside the building if you don't have time. You can visit with Albert Einstein. There's a beautiful sculpture of Albert right out in front, and one of the things I love about coming to D.C. is regularly seeing school kids climbing all over the guy who changed the way we view our universe. That's kind of what we're about here as well, at least changing the way we view our solar system and the red planet and the moon. We started this week with that news from NASA and the administration of a supplemental budget to put us on the road, they hope, to reaching the moon, putting boots back on the moon for the first time since 1972 with the new Artemis program by 2024. And a good deal of discussion that has been taking place, if not on stage today, certainly in the networking sessions during our breaks, has been all about that topic. We are going to be coming to you with the webcast regularly during the breaks today, going into and out of lunch. And then we will close, and I'm on my own at the moment because my colleague Sonia Gavankar is actually the moderator of our first panel today about space medicine, but she will join me during the upcoming breaks, and then she will join me for that last panel, and we will talk about what a number of people, a big panel, what each of them has picked up as a takeaway from this summit, the 2019 summit, and also how we keep the momentum going, the momentum toward the moon, and then, of course, the momentum toward Mars, which is, as you might expect, what Explore Mars is very much all about. We also want to thank all of the sponsors who've made the 2019 Humans to Mars Summit possible, and we'll be acknowledging them during the webcast and probably meeting some more of their representatives today. And during the breaks, we'll be bringing up some of the great people that might be on stage at times during the day and might not, but hopefully you'll find them all interesting. We do thank all of you for joining us around the world for the webcast. We're going to be here right up until 5 p.m. today, I believe. 5 p.m. Eastern Time, and I hope you'll stay with us for as long as you can. All of this video will be available on demand at h2m.exploremars.org in the coming days. Like I said, we have a lot to look forward to, and we can get underway now by going to the podium where the CEO of Explore Mars is standing. Good morning, Chris Carberry.
Good morning, Matt. Thank you, and welcome everybody to the third day of Humans to Mars Summit. I hope you've enjoyed the last couple days. It's been very successful. I hope for those of you who were at our reception last night, I hope you enjoyed yourself. I know a number of you had gone to the AIAA Gala. I hope that was a spectacular event as well. So thank you for coming to this third day. I should note, I'd mentioned yesterday that on day one of H2M, we had 13,000 online viewers. Well, yesterday we had 14,000 online viewers. So, we've had a lot of great viewing online. So thank you to everybody who's watching, on their laptops and iPads and iPhones. We're glad you're viewing. I want to start off by thanking our sponsors once again, our gold sponsor, Aerojet Rocketdyne, our silver sponsor, Lockheed Martin, bronze sponsors, Boeing and Northrop Grumman. We'd like to thank the Musk Foundation for enabling the Afghan Girls Robotics team to come to this event. That very much appreciated. Our media sponsor, Space News, our webcast sponsor, the National Institute of Aerospace, our supporter sponsor, ULA, our STEM education sponsor, Dollar General, our friend sponsors, Paragon, BWXT, Boldly Go Institute, and Two Planet Species. I particularly wanted to say thank you to Two Planet Species because I forgot their name the last 2 days because their name wasn't on the logo. So I apologize for that, but we very much appreciate your support. And also want to thank our two beverage sponsors from yesterday's events, Ardbeg, who did the Scotch tasting last night at our reception, and Olsen Wine, who provided the wine for our lunch yesterday. So I also remind people that we still have copies of Leonard David's books, his new one, Moon Rush, and one that he came out with several years ago, the forward by Ron Howard, his Mars book, which accompanied the Mars National Geographic series. So we still have a few of them, not many left. We've been going through them pretty quickly, but we still have them, and I believe Leonard will be around to sign books again today. So if you haven't picked them up, please do. For those of you who are planning to help us distribute the Humans to Mars report on Capitol Hill tomorrow, we will be meeting with people who are helping during the break time in the Great Hall. So if you want to help or if you want to hear more about this, please come outside during the first break, and would like to talk to you and talk about how we're going to distribute this to every member of Congress tomorrow. And well, without further ado, I believe I'm going to bring out Janet Ivey, president of Explore Mars, to start the show. So Janet,
all right,
the floor is yours.
I hope everyone had a good night. Chris and I are pretty thrilled as we are looking at the numbers, and thanks to everybody who's watching online. We know that many people had multiple schedules, so next year we're going to hope that everybody can also join us in person if possible. But one thing that I want to mainly say is simply thank you. This afternoon, you may go, where did she go? I will turn the floor back over to the team, and I will be working with Girl Scouts just down the street. So if you want to say hi or bye and everything, please find me probably lunch or a little bit after. Otherwise, you'll go, did she go to Mars already? No, just down the street to work with Girl Scouts. Doug Cook, an attendee, has a fantastic thing that he would like to offer to everyone. We're going to put it in a follow-up email to you, but he's written both a book called Aquila Mission as well as Arcadia Mars, where the team and the crew spend 13 months on Mars. It's a great thing. He's offering a free ebook to all participants, so you can request it in iBook or Kindle format. You can email him at Doug@Aquila, AQUILA mission.space, but Wade's going to send you an email also about that. Now, coming up, this is a fantastic panel, and I cannot wait to get to it. Sonia Gavankar is a communicator who uses dynamic storytelling techniques as a spokesperson, television and podcast host, filmmaker, and social multimedia content creator. Her voice is divine. Just wait till you hear her voice as she moderates the panel. And she's been seen on ABC, PBS, and many others. She's launched something called herexchange.com, which brings a new perspective to insightful conversations and professional development tools that could be written word, podcasts, and live workshops. You guys are in for an incredible treat. Let's bring Sonia and her panel onto the stage. Let's give them a big round of applause. Come on.
Thank you. That is quite the build-up, especially early in the morning, to say that I have a great voice. I would like to give credit to the whiskey tasting last night. Any dulcet tones you hear this morning. We do have an incredible panel to kick off this morning for you and for our live stream. I want to introduce you to everybody. Starting here to my left is Ruth Hammersbach. She is DLR Head of Divisions of Gravitational Biology, Vice Director of the Institute of Aerospace Medicine. Thank you for being here, Ruth. Julie Robinson, NASA JSC Chief Scientist, ISS. Dan Buckland, Duke University, Assistant Professor of Emergency Medicine and Mechanical Engineering. I should call you Dr. Dan, I feel. You earned it. Lisa Pratt, NASA, Planetary Protection Officer. And Sarah Lynn Mark, NASA White House and HHS former Senior Medical Policy Advisor, iGiant President and Founder. An incredible panel. Lots of experience and varied experience, so we have a lot to cover. We're going to ask each of you to present briefly on your topic of expertise. Then we will open it up for questions here and with our audience here in our grand theater. So we'll start with Ruth.
Okay, Sonia, thank you for the introduction. Can I have the first slide, please? It's the second one. Sorry. Okay. So it's the first summit, Mars Summit, I participate, and I really enjoy it. There are great panels and experts, and there's a lot of time for very fruitful networking. And I want to bring in another aspect, life science, because if you want to bring men, women to Moon and to Mars, that they stay there, live there, work there, and we want to bring them back healthy to Earth, we need a lot of knowledge from life science. And we, at the German Aerospace Center in Germany, the Institute of Aerospace Medicine, we are working on these topics for many years. So we have a lot of experience, and our vision is also to keep astronauts healthy and improve human performance. And I want to stress on 4 points which are very essential, which we have to study and manage to bring men, women to space. The first aspect is radiation. And here we have done a lot of studies, and we are currently doing exposing microorganisms or material to the harsh environment of space. And there we can check the survival. You see on the left this biopen facility with microorganisms, and on the same time we measure radiation, what they experience. And what you see on the right, it's now a matryoshka, it's a phantom of the human body, and there we measure the impact of radiation on the human body. And you see on the right there is the matryoshka with a shielding, with a vest, and the other one has none. So this female matryoshka is going to fly on Orion. And I think it fits very well what we heard from Jim Bridenstine to bring a woman on Moon. So we have a female matryoshka. And the other aspect where we are also have experts in the institute is astro and microbiology. And you see this ugly picture on the right, it's from the ISS, and you see there's a lot of biofilm, fungi, bacteria, and they form biofilm. And so far we do not know we at least know a little bit how bacteria and fungi will behave in space. And they form these layers. You have them also in hospitals as a problem. So in space, they are one point for the human health, but also for techniques which have to be overcome. And also, that's the point for planetary protection, but we have also an expert here for this field. So the third point I want to stress is waste management. You can't bring all the food to space, so we have to think about how we can use waste. And you see here a filter system. It's a CROP, which we have developed in the DLR. It's a combined regenerative organic food production. And you see this filter unit, it's a biological system, and we put in urine. It's a typical waste, what we humans produce. And there's a consortium of microorganisms and which degrades the urine, the waste, into water and nitrate. And the nitrate, again, is used as a fertilizer for plants. So we can then produce from waste resources for feeding. And on the right, you see the Eucropis mission. It's a compact satellite which has launched on the 3rd of December. And it's built up also by the German Aerospace Center. And in this compact satellite, the name is Euglena and Cropis, so it's the filter we developed. Euglena is a small algae which produces oxygen. And so we test here, it's a pilot test to see how such a regenerative system can work in space, but not in space because this satellite is rotating. And at the moment, it produces moon acceleration, and later on it will spin down, and then it will spin up to Mars acceleration. So we have a proof of concept how such a filter system can work. Currently we have the experiment from NASA, from Lynn Rothschild, on board with bacteria, synthetic biology. And we have RAMES, it's a radiation monitoring system. So for the first time, we have a very continuous measurement of radiation in an interplanetary area. So what will experience men, women, when they are traveling between the planets. So we can measure this radiation. So, and the fourth point is human health and performance. we know and we need the testbed ISS to study the impact on the human body. And here we have, for example, the Sarcolab experiment running, looking for muscle degeneration, because this is also a problem in space, that muscle bone decrease. And we have the CardioVector experiment currently running, looking for cardiovascular deconditioning, which is also a point how the heart works. There are different conditions. They must not have so much strength like on Earth with gravity. And we develop countermeasures like artificial gravity. You see here on the right the human centrifuge, which we have in Cologne, and we expose humans there to test whether artificial gravity might be a good countermeasure. Coming to the end, I think it's not only necessary to do these experiments in space, we have to use our facilities and possibilities on ground in analogs, doing partial or simulated microgravity experiments. And here we have the ENVI Hub. It's our research facility in Germany, in Cologne. Here we can investigate humans under very controlled environmental conditions. We can change light, atmospheric conditions. And currently we are doing a bed rest study. And you see here Jim Bridenstine, he visited us some time ago. And if you look at the bed, you see it's not in a horizontal position. It's 6 degrees head down tilt, and the head is lying head down tilt. What happens? It's not microgravity, but the body experiences, like in space, a fluid shift. And the result is an increase in intracranial pressure, and what we see, obviously, a change in the visual system. So, and this is also a problem for astronauts, for the eyes, changes in the retina. So currently we are doing this study together with NASA and ESA, the EXBRISA study, artificial gravity in combination with bed rest. So half of the test systems are exposed daily on a centrifuge for training. The others stay completely all the time, 60 days in bed. We have now half time, and it's running very well. They are in very good mood and condition. So I think we should also use all facilities on ground. This ENVI Hub is next to the European Astronaut Center, and in between the ESC, the ESA are currently building a lunar facility, so where we can do a lot of studies on the topics I mentioned, also human interface interaction. So I think that's the topic, forward the moon on the way to Mars and back to Earth. That's very important to bring them really healthy back to Earth. And well, as Jim Bridenstine told, we should work together, and we offer our collaboration.
Thank you so much, Ruth. Facebook keeps telling me about, this sleep laying down study, and 60 days in bed sounds like a dream job. So if you need to fill a bed, please give me a call. Julie, please tell us what you have brought us.
Well, thank you so much for inviting me to speak with you today. I have just finished a year away from my day job as chief scientist for the space station, and spent that year as associate director of NASA's Human Research Program. So that's given me the opportunity to really understand in depth the breadth of our research and to represent that program today. Of course, our Human Research Program is a risk-based applied research program. And as we look at the risks for all the different design reference missions that could be done in exploration, the most significant set of risks are for a human mission to Mars. And those include both the biological, the physiological, and the psychological challenges that could come during and after that mission. We like to look at exploration missions in a cohesive way, and we think of there being 5 basic hazards of human spaceflight. The first of these is space radiation from galactic cosmic rays as well as solar particle events, which have to be managed quite differently. The next is isolation and confinement from being in relatively small volumes with a small number of people. The next is the distance from Earth itself, meaning you can't necessarily come home. You cannot get resupply. If you discover you left something back home that you need, you don't have any opportunity to get it. And autonomy is required because of the communications delay on a mission like a mission to Mars. The fourth one is altered gravity. And in fact, there's been a huge amount of research on the International Space Station over the last 20 years, really focused on the effects of altered gravity, both being in a microgravity environment, which is a model for a Mars transit, as well as the gravity transitions during launches where you leave Earth's gravitational field, and then after landings when you return to a gravitational field. But as lunar missions develop, we also have the opportunity at looking at 1/6 gravity and trying to understand and predict what 3/5 gravity would be like. So, and then next is the hostile closed environment of space. So in these canisters, we come with a whole ecosystem. It's not just the human organism. It's also the microbes that are commensal with our bodies that we need to be healthy, as well as perhaps some microbes that are not as friendly to us that could cause illness or disease. And so looking at that hostile closed environment, also the CO2, recycling in our life support systems, all of the oxygen, scrubbing out carbon dioxide, all of those aspects of the hostile closed environment can affect human health. One thing that's quite interesting is early in the human research program, we kind of categorized our responses to these in swim lanes, if you will. For example, the physiologists were mostly interested in altered gravity. We had a separate group of people that were mostly working on radiation. But as we start understanding and being able to predict and modify some of these hazardous effects on human health, we also wind up with the human becoming a much more integrated system, and these 5 hazards being a focus of really what are the synergies. For example, what are the synergies between space radiation and the brain, and how do those affect behavioral performance as well as physiology? So when we look across these different hazards of human spaceflight, and if you look at it from a perspective from Mars, looking back at that little tiny dot that is Earth, in altered gravity fields lead to things like balance disorders, fluid shifts and visual alterations, cardiovascular deconditioning, and muscle atrophy and bone loss. However, not all of these are equally high risk today as they were 15 or 20 years ago, because we've made substantial progress on the International Space Station. In radiation effects, we think about both acute in-flight effects, long-term cancer risk, and central nervous system and cardiovascular effects. We look at vehicle design, the environmental system, the food and nutrition system, the isolation and confinement effects on behavior and sleep, and communications and autonomous medical care. As we start looking at lunar surface research operations, definitely depending on the mission design and duration, we can use lunar surface operations as a way of testing some of our approaches to Mars surface operations in the future, including autonomous egress and post-landing operations and long-term habitation and exploration on a planetary surface. And we have a major effort going on, which I had the opportunity to talk about yesterday, working with ISS and some of the Mars planning teams to look at what new things could we do on ISS that are more innovative and help to be more operationally relevant to Mars mission landings, including what we might do with crew members that are deconditioned, landing from the International Space Station in our future commercial crew landings. We've done substantial work with our Russian colleagues on the deconditioning and that effect on performance of crew members that land in Kazakhstan on the Soyuz. So just to summarize then, NASA's Human Research Program, we juggle the things that we worked on based on the largest risks. Some of those risks are related to radiation acute effects and behavioral impacts as well as cardiovascular impacts. Some of the things you may have heard were the biggest risks to Mars are not rated as high anymore as they used to be because of the substantial progress we've made. Other things that people didn't even know about 15 years ago, like impacts of microgravity on vision, are still being investigated. And as we work together, we work to close these risks just like we would any of the other engineering systems, and to be ready so that the crew can safely transit to Mars when the agency is ready to go. Thank you.
Thank you so much, Julie. Dan, no slides, but great presentation.
All right, that's some confidence. All right. So, as I said, I don't have any slides. I use my hands a lot, but they don't actually mean anything. It's more for me than you guys. But as introduced, so I work as both a emergency room doctor at Duke University Hospital, and I have a lab in the mechanical engineering department at Duke where we do medical device development. Me and my students work on finding problems that I find in the emergency room and say, how can we fix this with technology? And then the application to explore Mars, and the Mars is, I approach problems slightly differently because I work both in clinical in the emergency room and in mechanical engineering. And when we eventually do get to Mars or want to explore it in a sustainable way, it seems to me it'd be a tremendous waste of potential of the American educational system or the international thing if the best botanist or the best geologist who can do the work, who has to be at Mars, but unfortunately can't go because they happen to be diabetic, which is the current model of space medicine is you take the healthiest people you can, so you limit the amount of medical problems you have. But that limits the kind of people who can go and do the kind of experiments and studies that you want to have happen on the surface. So I look at it from what kind of technology can be brought to bear to expand the base of the health problems that can be brought to out to Mars or to any exploration environment. And so NASA has looked at this in a while, and the way this works in a logistic capacity is we get people like Julie who will develop the risks and requirements for what needs to go out there. And then in the university and the industry world, we say, okay, thank you for developing a problem and the requirements for it. And then me and my students will look at those problems and say, okay, how do we address this in a clinical and a engineering capacity? And something that's happened and been noticed at NASA in the last 20, 30 years is NASA's a great place, and the space agencies are a great place where engineers, clinicians, and life scientists all have to work together to solve these problems. But in the last couple of years, also noticed that this idea of you get a bunch of smart people in a room and great things happen is true, but a lot of people will leave that room thinking other things, thinking separately what happened in that room. Because when you have the experts in clinical science and in engineering and in life science, they use, the phrase I like to use is, everyone is speaking different languages, but unfortunately they're sharing a vocabulary. And so people say words like, we're gonna test this, or we're gonna explore this. And to an engineer, a test is it's a multi-day process that gives you an envelope and confidence intervals and process. Whereas as a doctor, I'm saying, I'm gonna test your blood pressure. That just gives me a number and it takes a minute. And so you have different experiences and expectations of what these processes go, and that leads to project failures. And so what in the last, about a year or two ago, the chief health and medical officer of NASA, the former one, wrote a book with a bunch of NASA experts and that I helped write, that is available because it's a NASA document about how engineers, life scientists, and clinicians can all work together, and failures that NASA's had that recognizes and when these different expertises with the best intentions just are not able to get the concepts together. And so that's the kind of space I work in, is how do these different specialties work most efficiently together to solve the problems to get humans out beyond the Earth.
Thank you, Dan. Lisa?
Thank you. I'm speaking of vocabulary and changing vocabularies. I'm gonna have a little shift here from the other members of the panel. My role is yes, to worry about the humans, but first to worry about the impact on life in general. And that means both terrestrial life, which we are starting to know on Earth, but we certainly don't know everything about it, and the life that we might encounter in another planetary environment. So there are two things in planetary protection that we worry about, and they're listed at the top here, and that's to avoid transfer of terrestrial life to a habitable world. There are three worlds we worry about right now: Mars, Europa, and Enceladus. And then, even more importantly, to prevent release of an extraterrestrial life or life form or even just biological agent on Earth during sample return. So we spend a great deal of effort, and we have a large number of people involved in verifying the biological cleanliness of spacecraft that we are launching to those three places. And it doesn't matter if it's landed or orbiting. We're concerned, of course, with orbiting spacecraft having an unintended crash on the surface and an unintentional contamination. That we usually work probabilistically. For anything that is going down to land or rove or actively explore, then we actually have a metric for determining biological cleanliness, and we do that by counting hardy spores, which is a technique that was developed at the time of Viking, and it continues to be sort of the gold standard for cleanliness measurements. But we also put a lot of effort into funding research that will get us ready for the next steps, the steps that involve humans. So our technology development priorities right now, and that means the things the tools we wish we had already. One is the ability to genomically or metabolomically characterize the terrestrial organisms that are hitchhiking on our spacecraft. We don't know who's there. We have a general metric, and that's the standard spore assay, but we don't know much about the ecology of organisms that can survive in a clean room assembly facility and get on a spacecraft and launch, and we don't know how the biocidal effects of transport in space reduces that community, or maybe selects for certain organisms. We need a tool that's better than the NASA spore assay, which is time-consuming and very dependent on the humans that do it. We need innovative chemical and spectral tools to detect bioburden on our spacecraft. And finally, we are now starting to work very closely with the healthcare industry and the federal health agencies on sterilization for use on a putative extraterrestrial organism. I just want to take this moment to remind you that we've had a revolution in our understanding of life on Earth that is by no means completed. We're right in the middle of discovering the diversity of life on Earth, and this image is a particularly nice one. I don't know if you can see the little red dots that are out here on the feather tips of a great many of these branches that indicate individual lineages of life on Earth. There's a lot of red dots, and those are organisms that we only know from their environmental genomes. We've not cultured them or grown them or imaged them, and that's a shocker, because you can see there's an entire region here of organisms that we didn't previously know existed. So it's concerning that we're still trying to understand life on Earth at the same time that we're preparing for a potential first encounter with life on another planet. So we ask ourselves all the time, is there life present on the surface or the subsurface of Mars? And this is a marvelous figure from Clifford. He's shown this a number of times, and it sort of expresses the uncertainty of what might be below the surface of Mars and where we might encounter vapor caves or saline groundwater that could certainly be habitable in the way we understand life on Earth. And of course, with the recent discovery of perchlorates and other abundant salts on Mars that have an enormous freezing point depression, we realized that we could have liquid brines at much colder temperatures than we would naturally encounter them on Earth. And that means we have to worry in slightly different ways about both that forward contamination with a terrestrial organism or bringing back a sample that could plausibly contain something living or active from Mars. So we're getting ready for the biggest challenge we've faced so far, and that's sample return from Mars. And we absolutely, the number one objective is to prevent biological contamination of Earth. This is a very complex architecture. It's an integrated campaign involving elements from NASA and ESA, in which the rocket that we will launch carrying the Mars 2020 spacecraft next year will be the drilling, collecting, caching rover, and then later we'll send a small fetch rover to go pick up the sample tubes, and we'll transfer those samples to an ascent rocket, and we'll launch the sample container into orbit, and then there'll be a waiting spacecraft that will pick up the sample and return it hopefully to Earth for study here in our most advanced laboratories. That means we have to have in place safe handling protocols and procedures for a sample from Mars, because frankly, although we have not detected life on Mars, we have lines of evidence that indicate we need to be very prudent and be prepared for the possibility of contact with an active form of life from the subsurface, or, for me, even more interesting, the possibility of a dormant form of surface life that could be transferred around the planet or transfer into the ascent rocket from dust. So we think about three basic principles in terms of safe handling: break the chain of contact with Martian dust, have extremely robust containment of the samples as we bring them back to Earth and land them, and finally be prepared for sterilization of an organism that we don't even know what that organism might be, but we assume that it shares some of the biochemical properties of life on Earth. How soon could this happen? Sooner than you might imagine. The timeline right now to bring samples back is the early 2030s. So we only have about 10 years to get ready, and in fact, we only have about 3 or 4 years to mature our understanding of how we will do safe handling. The great thing about a sample return from Mars for human missions is that we will demonstrate ascent of a rocket from Mars. And as somebody said a few minutes ago, if we're sending astronauts, most of them are going to want to come home, and that's going to be a tricky thing. We'll be developing sterilization modalities jointly, again, with industry and health agencies for what we believe to be a plausible form of an extraterrestrial organism. And then we will have, if this is successful, the remarkable thing about sample return is the inside of the sample container, which is about this big, there will be 20 or 30 hermetically sealed titanium tubes that will contain unsterilized sample material from Mars that we can use for advanced biological study. And we'd really like to know before we send humans if we think there is anything biologically active in the dust that moves around, very aggressively moves around the surface of the planet. And finally, of course, we'd like to be able to chemically and physically characterize the Martian dust, which will have an intimate contact with our astronauts, regardless of how carefully we try to control and filter air. So with that, I'll turn the clicker over.
Sarah-Lynn, close us out.
Great. Thank you so much for the opportunity to be here today. I think it's quite appropriate that we're actually at the National Academies when we talk about sex and gender-based healthcare, because it's at this site that there was the genesis of this whole realm of science and medicine. In 2001, allergies in Washington, D.C.
It's fun that we're talking about what spores are out there on Mars, but we're all
living here on
deeply
this planet.
affected here in Washington by what's
living
here in the
on this
swamp.
planet. We could study D.C. for that. In many ways. In 2001, the Institute of Medicine released a real seminal report entitled Does Sex Matter? And of course, the answer was yes. They also defined sex as the biological construct, really looking at it at the DNA chromosomal level. They defined gender as more the psychosocial construct. After that report, NASA decided it was time to actually do a review, to data mine what we had to look at sex and gender from every aspect that we had available. And you may wonder why this is important. Well, in a way, space is the most extraordinary platform to study sex and gender-based differences. When the body goes into space, as we've heard from some of my colleagues, and you've heard over the last few days, the body adapts very quickly and very dramatically. So very small differences can be detected, and those small differences may actually have profound and dramatic impact. We've had 2 surveys of our data, 2 reviews. One was in 2002, and a second review was conducted in 2014. That was conducted shortly after the IOM, or the National Academies of Science, as it was called now, developed another study looking at NASA's research portfolio. And we felt it was time, it had been a decade, to really assess what we had learned and where we need to go. What you have here is a diagram of our male and female astronauts. And as you can see, and it may be hard from some in the back to see, but every system in the body undergoes very dramatic changes. In 2014, a report was published in the Journal of Women's Health. It's available, anyone can download it, where we had convened 50 scientists from across the nation. We divided them into 6 work groups, studying every aspect of the body. So we evaluated the cardiovascular system, the neurosensory system, the immunological system, the reproductive system, behavioral health, as well as looking at musculoskeletal. The report was published, and it really generated a great deal of interest, certainly not only from our fellow scientists, but also from the media, because some of the headlines were, does sex matter? Who's the stronger sex? And we wanted to be clear that this was not a battle of the sexes. It's not a question of who is better, who is stronger, who is faster. It's that there are differences, and through these differences, we can develop better countermeasures and better preventive measures to keep our astronauts healthy in space and when they return to Earth. You heard this morning about some key changes that happen in the body and some key findings, and I just want to highlight a few of them since I think I have about 2 minutes left. One of which is the visual impairment intracranial pressure syndrome, which is what our report called it. Now it's called SANS, Space Adaptation Neurosensory Syndrome. And what we have seen is that both male and female astronauts have changes on their scans, revealing that there are changes in the eye structure. Interestingly, it's our male astronauts that are the more symptomatic. And we're trying to discern the reasons for this because this is a significant issue. You're going into space, or you land on a planet or the lunar surface, you need to be able to see what you're doing. We think this may have some relationship to the younger age of our female astronauts who are flying, as well as the hormonal milieu. We know that estrogen is a vasodilatory type of agent, so that there may be greater compliance, and our female astronauts may not be as symptomatic. In regard to radiation exposure, this is an interesting area. Currently, our female astronauts have rates of exposure that may prevent them from even going to Mars if we don't develop better countermeasures, better, safer habitats to prevent the issues that we discussed, such as cancer as well as other issues. Behavioral health is a very important one, and it's often negated and neglected when we talk about healthcare, but we know it's so critical. Traditionally, women have had the friend and befriend aspect when they're dealing with stress, whereas some of our male colleagues have more of the fight or flight. And I think in a mission to Mars or the moon, there really isn't anywhere where you can flee to, and you certainly don't want to fight. It's often been discussed that single-sex or single-gender crews tend to get along better. It's easier, and that may be true up front. There may be some more challenges getting crews who are mixed gender to get to know each other, to work effectively. But just as we see with our life here on Earth, diversity really has significant value, and it really impacts our performance, greater work performance and greater outcomes. So there will not be a single-sex, single-gender crew going to the moon or to Mars. We need to really examine this, and we've done significant strides. We've conducted significant research in how we improve team effectiveness. One of the issues that is often brought out, and we talked a little bit about this, is how do men and women interact differently to technologies? Well, we know every single element of technology, men and women have a different response. It's really important to see the world through a sex-gender lens, and that is what my nonprofit does, which is entitled iGiant. It's an acronym for the Impact of Gender and Sex on Innovation and Novel Technologies, and we're an accelerator for gendered innovation. And we look at health, IT, transportation, and retail to see how men and women interact so that we can develop better design elements so that we can improve work performance and be able to live safely and well. And I think just in conclusion, as we talk about going to the moon in the 2020s and to Mars, I like to believe that the next boots on these surfaces will be worn by a woman, and we will be sure they will fit her.
You are part of this conversation. We do have 2 microphones in the aisles. If you want to start queuing up there, we can take your questions. Julie, I actually want to start with you. You talked about the 5 hazards of human flight. As you started to do those swim lanes, as you called it, do you separate them kind of into bio and behavior? Can you make it that simple, or does it really need to be separated out so you can find the differences and the nuances between them?
Well, the interesting challenge for us is those 5 hazards of human spaceflight are one independent set, and then you've got the traditional scientific disciplines that study human health as a different set. And in fact, they intersect in complex ways, in kind of multidimensional ways. So for example, radiation does not just affect physiology, it does not just affect psychosocial aspects. It really has to be thought of comprehensively. It also affects the microbiome, so it also affects the environmental aspect. So one of the things that we do to help in approaching that better is to use systems approaches, both systems biology as well as systems engineering, actually together, to better understand what are the needs of the human system, how do we input new information as we gain it, and into a medical model so that we have a good model of medical care, and then we can update it as new medical technologies become part of the menu of things that we can select. And that's, I think, really important because 20 years ago when the Human Research Program, or 15 years ago when the Human Research Program was set up, it was really thought, okay, well, the physiologists will work on these risks and the behavioral medicine people work on these risks. And that's really not how you can do it today, as we know a lot more.
Dan, as you look at an emergency room or a hospital, and we think about all of us being future space travelers, are we healthy enough to do that? We want to send the best and the brightest and the most fit in those early days, but what do we as humanity need to be working on? I am basically a giant bag of goo, essentially. I don't work out, I'm really sedentary. So if I want to go to space, what do I need to be doing now to really build up my muscle tone, my bone structure to be considered?
So one thing I've learned working in an emergency room is humans can do a lot of stuff, and they will be fine most of the time. I'm there for when they're not. And so it kind of comes down to what risk is everyone willing to take to do these things. As I said, I work in an emergency room, and we've all seen the internet. People are willing to do a lot of things that is probably not the best for them to do the things that they want to get done. And so my concern as a clinician is not really the first couple missions, because the amount of pressure, like it'll get done, it'll get accomplished. It's more the sustainable, which happened with like our original lunar plans in the U.S. is how do we keep people there to do stuff? And then it doesn't matter how healthy you are. If you're working in an industrial environment or an operations environment for an extended amount of time, you will get sick, you will get hurt, you will do these things. And so the best thing to be prepared as anybody who wants to go do this stuff is just to know your body and what you're capable of doing. And so you're able to say, this is not something I'm able to do, so you don't put yourself in a situation to get hurt that requires other resources to do it. So I think people who are deconditioned, who are big bags of goo, you have less to decondition if you're out flying in space. And so you're going to be operating more at your normal capacity, as opposed to if we're sending high-performance athletes, and I don't mean that personally. If we're sending these high-performance athletes who are suddenly now in the bed rest equivalent, they have further to lose in muscle mass stuff, which is why they spend 2 to 3 hours a day working out to maintain their homeostasis. That's a lot of time as a mission planner to take out of the day for do it. And so if you have people who are willing to be less fit while they do these things, then you have other problems about what they're going to break or what they're going to get hurt of. But I think just recognizing what you're able to do and what that impacts the overall mission is kind of the key to that.
Sarah-Lynn, you want to add?
Yeah, a couple things. Well, and this is where I think the private sector, the commercial space sector, is going to play an important role, because everybody, we've democratized space. Everybody potentially will have a chance to go and explore. And I think we're going to learn a great deal versus sending our super athletes or specimens that are so well trained. And I think people who look like us will be able to see how well they can manage and how well they adapt and how well they do when they return. We're also entering an exciting world of what I call astroomics. It's precision medicine in space. We certainly have it on Earth with the All of Us study, the Precision Medicine Initiative that's been launched by the NIH. And when we're able to go into space and we're able to actually tailor our countermeasures looking at the individual, I think we're going to have extraordinary success as well. So we're at that beginning phase. We've had the one-year mission from Scott Kelly. We have 2 extended missions for 2 of our female astronauts to come, and we'll learn hopefully a great deal from that. And I think that gives us important messages for all of us that we can go into space, we can tailor our countermeasures, we can do well, and we can successfully come back to Earth.
Wonderful. Yes.
Can I just throw
Sure,
one
please.
little wrench into that, particularly for the
Please do.
emergency room guy, and that's it. What if people get sick, and you have to figure out if it's a Mars-related illness or if it's just an illness related to exposure to this unusual and confined environment? I mean, because we don't talk much about the possibility of quarantine But
think Julie may
quarantine
actually
on
have a-
Mars could be a very difficult sentence.
Julie sounds like Julie has an answer maybe for
Yeah,
you.
so one of the really neat collaborations that's been going on the International Space Station is a collaboration between folks that are planetary scientists and folks that are microbiologists, and we've been testing genomic methods of quantifying and measuring the bacteria that are living inside the International Space Station. Those sequence-based techniques give you the ability to see all the organisms that are there, not just what you can culture, which is the old-fashioned way of checking the cleanliness of your spaceflight, right? Was to swab things down and see what grows on a blood agar plate. Well, that's not as informative as knowing sequence-wise what was really there. And those become multi-purpose tools. So that kind of a sequencing technology, and some of these are this big now, and they only take very little time to run. And so you can use that technology, you can use it to evaluate the cleanliness, what's in your spacecraft, you can use it to determine if a crew member has say a urinary tract infection, you could use it to determine what kind of organism that is. And you can use it as your planetary protection tool to be confident that, that you know what kind of organisms you're dealing with in that environment. And the fact that those planetary scientists and microbiologists are already collaborating at Johnson Space Center, I think is just a great partnership.
Which works well if it's very Earth-like life, but if it turns out it's something that can replicate, but it's not entirely Earth-like, then do we have the tools? Are we ready?
Right, and that's one of the questions that they're working on. For example, Astrobiology had a paper published earlier this year where they identified some molecules that could have been part of DNA biochemically,
XNAs.
but are not, the XNAs. And one of those sequencing technologies should be modifiable and be able to detect those. Other sequencing technologies out there are not. So that's why I think that's just a really great synergy area as we look forward to going to Mars.
Ruth, I want to have you weigh in on that, and then I want to go to the questions.
Yes, okay. Because I would like to add to Sarah-Lynn to transition back to Earth medicine, because what is an astronaut? It's a healthy man, woman we send to space, and in a very short time period, she will experience things which we experience during aging, so muscle, bone loss, immobilization. So bringing back these experience, understanding the mechanisms, what the impact of gravity, what we need for training. We have all kinds of diseases on Earth where we can use it. Looking at bed rest, the changes in the eye, the visual system. It might be that if you put the bed up the head, so a change in pressure, it would also help in the medical things on Earth. So I think transition back to Earth is also a very important thing which we have to bring in our study to explain why we are doing this kind of space study.
Our first question over here. Go ahead, sir.
Yes, good morning. My question is probably for Julie, and for the problem of the isolation and confinement environment that the astronauts would feel to and from Mars. Have you considered maybe opening up the internet so that they can communicate with the internet, not just to Houston, but not just to DC, but to all parts of the world, so that a citizen of the world, for instance, could have some kind of conversation with an astronaut in transit, especially for the first mission? And that would not only engage the astronauts and give them some mental activity as much as they want, probably, but it would also engage the citizens of the Earth in terms of being able to actually talk to astronauts on the way to Mars. The downside of that is that by the time we have a Mars mission, the population of the Earth will probably be around 9 billion people, so there's a little traffic congestion there, perhaps. But,
Well, so there are two aspects of that question that I want to unpack. So the first is the perception that crew members on Mars missions can't communicate, or crew members on our missions today, for example, can't communicate. And the fact is that they do. So we have satellite phones. They can call their families every day if they want to, and sometimes they do when their families are in crisis. I get phone calls from crew members on orbit with a quick question. So our crew members on ISS today, and they do have access to the internet. Now we do some things for IT security purposes, so we don't just have it open band everywhere. It's not just another node like any other node. We protect it. But those things are available, and they will be available for a Mars mission as well. The difference is the comm delay. so that as you get further and further away from Earth, you have to switch to store and forward communications. That's not necessarily bad. And as an example, I have a teenager, a 17-year-old, and I use store and forward communications with her, and I bet many of you do as well. It's called texting. And that is the primary way I know that how she's doing. It's how I help solve problems. It's how she checks on things. And so that works really well. That works well for humans. So some of those things, those tools will be really used very much the same way as we use them today. I think the other thing that we have the ability to do is to use the developments in AI and in information technology to have our systems more autonomous. So the big change is that you're not going to say, hello, Houston, we have a problem, and let the people on the ground solve the problem for you. You need to have all the tools to solve that problem for yourself on orbit, because you don't want to wait 20 minutes for them to go, hey, I didn't hear that. Did that break up? And so it's a change in the way we do our operations. It's not necessarily as different sometimes as we think.
Okay,
Another
thank you.
question right here.
I have another.
We're going to move actually on because
yes,
well,
but
we'll
I'll
come
talk
back
to
to
you
you if we
later
have time.
about another
If we have
question.
time, because we have a lot
Quick
of questions.
question for
I wanna make sure
Dr.
I
Dan.
answer.
You mentioned a book available online. Could you provide the exact title and author list?
It's a very long title, but it's the Rosetta. The easiest way to find it is the Rosetta Stone Project, and it's on the NASA Technical Report server. And so I would do a Google search for
Your name and Rosetta Stone.
Yeah,
There you
Rosetta
go.
Stone, and Richard Williams is the lead author of it.
Excellent. Thank you. Yes.
Hi. So my question pertains to what I assume is a very involved and significant recovery period that astronauts coming off the ISS experience. And my assumption is that that includes checking out, making sure they're okay, and also studying any changes that have happened in that individual's body or psyche, etc. When astronauts land on Mars, they will have been in space for approximately 8 or 9 months, and they will have to go through a similar recovery period that we hope is quick enough that they can utilize their time on the surface as much as possible, and that will have to be remote and autonomous in some way. So I was wondering if you could talk to the duration and complexity of the current ISS recovery period and how you foresee that changing on Mars.
What can we learn from past experience that can take us forward?
Yeah, so what we've learned from ISS, and this is one reason that we have a series of missions coming up where we're going to have very structured different lengths of mission. So you've heard about Scott Kelly's one-year mission. We have a couple of crew members who will have extended missions in the near term. But over the longer term, we have a structured set of studies where we'll have 10 one-year missions, plus 6-month missions, plus 6 to 8 week missions in a pattern so that we are able to well characterize the effective mission duration on this immediate post-flight transition period. We also will be doing a set of studies that build on what we're doing in Kazakhstan today, where we look at the performance of the crew for the first 10 hours after their landing and evaluate what kinds of mission activities they could do and which kinds of mission activities does it take a little bit of time. But the good news is that you've got to focus on some of those near-term gravity transitions and their effects on the crew. But the human body is extraordinarily resilient, and these crew members start recovering their capacity quite quickly. So by the time we do our post-flight baseline data collection on ISS crew members, usually about 7 days out from their landing, many of the disruptions are starting to return to normal, and they're certainly able to do normal kinds of activities. You or I would interact with them and not really perceive that they'd been on a space mission anymore. So sometimes people will focus on the problem. The problem is an interesting problem, but the risk can be managed through countermeasures, through training approaches, and through the supportive approaches that we have in our technologies in our landing systems as well.
Ruth?
Yeah, I think a lot can be done in the countermeasures, and we at the NB Hub, we have the direct return of the ESA astronauts, and it was fantastic seeing Alexander Gerst after the mission. He really ran around as nothing happened. So I think that they have a very high motivation for training, and even it's not enough. We see still a muscle and bone degradation, but I think therefore we need the testbed ISS to continue on the research and to guarantee that they stay fit.
Sir. You're up, Orange
Okay.
Jacket.
Hi. My wife's a medical doctor. She practices at a facility in Northern California where Dr. Mark used to practice some years ago. She comes to these conferences sometimes and complains there's not enough about space medicine. I'm glad you're here. Okay, the question is this. We put these 6 alpha top 0.5% people, perhaps from different countries, different cultures, different religions, in a tin can for all this time. And we send them to Mars, and all these psychologists are pulling out their hair saying, how can we predict who's going to go nuts during that 18 months and commit murder, you know, regardless of all the psychological screening.
That's a leap there, okay.
All right. In the late 70s, I was at the Prudhoe Bay, you know, the Alaska pipeline, and the predecessor of British Petroleum did something incredibly innovative when they set the base up there. There were 60% male employees and 40% women. All right, the good news is the men started dressing nicer, their hygiene improved, very little bad language and machista behavior. The bad news was sex happens between people, and sometimes you would have a situation, for example, where 2 men would be interested in 1 woman, okay? And let's go one step further.
Can I ask you what your question is?
It did happen. Later on, I gave my son a book called Sex in Space.
Yeah, I was going to say, you're writing a great book that I look forward to reading. But
okay, no, it's already out. Okay, all right. And then Dennis Tito, when he was going to do a Mars orbital mission, he came up with something original. He was going to pick a domestic partnership or a married couple, whatever, somebody who had been together many years and was compatible and could most likely survive together in that tin can all that time. The big question is, how do we pick those people to make sure that there's not some disastrous blow up during the mission because of whatever, you know?
I think that, you know, when I look at shows like The Bachelor and The Bachelorette, you know, that's a different way of choosing people for an outcome. So when Ruth, when you're doing research on isolation and team building, you're using that same technique of casting, but in a very different way for teamwork. That's what you're looking for. So tell us how you choose people and anybody else who wants to weigh in on the selection process.
Well, it's a very hard selection process because we have to be sure, even in the 6 weeks bed rest, that they really stay in bed and not after 1 day said, wow. Because so it is a very hard selection, psychological and medical things, and to be quite sure that we have chosen the right ones.
Right. Anybody else want to weigh in? Sarah Lynn?
So what you were referring to regarding Dennis Tito's program, it was called Inspiration Mars, and we had actually had work groups developed to address some of those issues that you were bringing up. I think crew composition is extraordinarily important. It's not only who is there, but it's the size, it's the multicultural component of it. So there will be a great deal of effort that will go into it. I'm a geriatrician as well, and I've often suggested maybe we just need to send older individuals. There's level of maturity, the latency issues for cancer is a little different, and then we could get ARP to sponsor or co-host that. And I say it in a jocular sense, but I also want to ensure that it's not just young people, that we really look at it from a multi-generational component, and that we bring part of Earth with us, and that involves the generations. So I think this is an avenue for a lot of discussion and hopefully input from our private sector as well.
We're running out of time. I'm going to go to Lisa last, and I know there are questions. At the networking break, we will all, I believe, still be here, so we will be out in the grand hallway for you to continue asking questions, as well as using social media. I think our last question goes to Artemis.
Okay. I want to know whether women are better or worse based on the fact that my immune system as a female is far more aggressive if something attacks me. I've learned that if I have a flu vaccine, and I'm one of these persons that's always vaccinated up to the hilt in anything that you can get, because I do travel a lot and I don't want to attract polio or something. Anyway, I know that I can only do half a dose because otherwise my body might overreact and I might develop an autoimmune disease. So back to my questions. Are women, because of this immune reaction, better suited to travel in space or less suited?
Artemis, you're bringing up something that's very important, especially to our health on Earth, and I just want to take a minute to highlight what you just said. Women have very robust immune systems. That's why 70% of autoimmune diseases are more common in women. Women tend to also be more resistant to infection, but once they are infected, they mount very robust responses, and then the issue gets really complicated when you're pregnant because of all the immune issues with that. We so far we've seen certainly immune system changes. As we mentioned, there's like accelerated aging in space, and what you would see in the older population, you tend to see in space as well. In regard to those sex differences, we haven't really seen any true sex difference at this point. We do have from Scott Kelly, he was vaccinated in space, he mounted a very good response. So hopefully as we have these extended missions with our female astronauts, we will see this as well. And then hopefully that issue will be taken off the table. But we were concerned because, again, the immune system is so critical to overall health. And again, you are right, we have to look at dosages for vaccines on Earth, and we have to be aware of these issues for our own terrestrial health. So there are major lessons to be learned.
Julie.
Yeah, I just wanted to add, as we move on Earth-based medicine to a period of personalized medicine, some of these gender-based kind of assumptions are going to be breaking down. So soon we'll know what kind of immune response different individuals are doing, and we'll be able to personalize our medicine to those particular individuals' needs. That's especially true also when people sometimes talk about spaceflight as aging, accelerated aging, and it's not. It's its own thing. It's the removal of a gravity vector and then the restoration of a gravity vector on healthy people. They react and respond quite quickly. We know how to exercise so we don't lose bone. In fact, NASA doesn't consider that a red risk for Mars anymore. It's because we know what to do to keep people from losing bone and muscle and to be able to be healthy and be able to carry out some rigorous EVAs when they get to the surface. So I think it's important to recognize that the human diversity is such a key part of the way that we design our missions. It's going to be a part of the way that we care for the crew as well. And it helps us, we'll be able to tune the ways that we respond and protect human health so that we're able to successfully complete those missions.
Thank you so much to our panel, Ruth Hammersbach, Julie Robinson, Dan Buckland, Lisa Pratt, and Sarah Lynn Mark for this incredible conversation. Again, we'll all be out during the break in the main hall to answer the remainder of your questions. And thank you for your fantastic questions.
Truly, my favorite thing is always planetary protection. You guys, I got to get Jim out. You guys come on. Again, give them another big round of applause. These people are awesome, brilliant, and they're going to figure out a way to keep us clean and healthy in both mind and spirit as we go to Mars. So we're going to do a little housekeeping. I think my friend Amadeus is going to come and spot check the stage as I get ready to introduce our next guest and everything. What I truly love about what Explore Mars and the Human to Mars Summit does is that we just have some fantastic friends and colleagues who come and share such, mind-blowing, groundbreaking work. So it just every year just gets better and better. But please welcome to the stage, his name is Jim Mazur. He is the Senior Vice President of Rocketdyne. And I said, how can I introduce you? And he says, I just basically say what my job description is, technically all things space. And I was like, you got it. So this is Jim Mazur, who's the Senior Vice President of Rocketdyne, all things space. But I did read on his LinkedIn profile that he demonstrates the ability to improve performance in complex operating environments, which I'm going to think means he gets along or has to work, and that's how he works out things with Joe Cassidy. So without further ado, with those complex environments over there, please welcome to the stage Jim Mazur. Come on out,
Thanks, Janet. Thank you. Thank you. It's great to be here. I understand you guys have had a good week, and it's really fun to come here and talk about the big picture because lots of times I spend time talking cash flow with our CFO, or we have solar electric propulsion we're doing on the DART mission, and it's going to be on the power and propulsion element for Gateway. And I was in a conversation last week about whether the metallization for the brazing process on a cathode was right. So I think it's really good to step back and talk about the big picture and what we're talking about going to the moon, to Mars. So I think that's really exciting. And it's also a lot of fun to really think about why we're in this business and what we're doing. I'll give you a quick background. I started in the 80s when Reagan was president, and I got put to work with McDonnell Douglas working on Star Wars satellites, and they were the precursor to missile defense, but we designed, built, and launched 3 satellites in 6 years. So I got hooked on kind of rapid prototype development and going fast. And then I worked Delta 1, 2, 3, and the architecture for Delta 4. Became chief engineer at Delta 3, and then I moved to chief engineer of a company called Sea Launch, which was an international joint venture, Russian, Ukrainian, Norwegian Americans launching communication satellites from a converted oil drilling platform off the equator. And then I became president of that company, and then in 2006, I became president and chief operating officer of SpaceX. And then I got offered a job later in 2006 to go run Rocketdyne and become part of human space flight. So moving from expendable commercial rockets into human space flight was challenging, exciting for me, but I really wanted to be part of that environment. And that's why we're here today, because it's ultimately about the human space flight. And then we got bought by Aerojet Rocketdyne. And after 30 years in the space business, what was going on was, in that time frame, Constellation had been canceled. We said, why are we going back to the moon? We don't need to go there anymore. And let's go lasso an asteroid and bring it back and figure out what to do with it. And I remember I was at NASA headquarters in a meeting with a lot of industry. And I raised my hand, and I was like in that movie Big, you know, I go, I don't get it. And they're like, what do you mean? I'm like, how does all this help us get to Mars? And they're like, well, we just told you. And I'm like, I don't get it. So I decided I was going to go be a jet engine guy, because I thought, you know, maybe there's a more rational part of the aerospace business. I ended up running the F-135 engine program, but I didn't like it. I was commuting from California to Hartford, and I found I wasn't passionate about it. So I had the opportunity to come back and get into the space business with Aerojet Rocketdyne. I'm happy to be back, and I'm really thrilled to be here with you guys today. One of the things I think about, though, when I tell that story, when I think about going to the moon and to Mars, I want to talk about some of the elements that will be required. And the first thing, at least the lessons I think we've learned, is what I'm calling constancy of purpose. And I think about when we first went to the moon, we had a showing, we sponsored a showing at the National Air and Space Museum on Apollo 11, and it was great seeing that. And I was on a panel afterwards, and we were talking about how inspirational it was. And for me, I was 8 years old when we landed on the moon, and it was inspirational. But when we did all that, I think we all had a view that we were going to continue to move on. We'd have a constancy of purpose, right? We went to the moon. The next thing we decided to do was do low Earth orbit with the space station. But I always thought there'd be low Earth orbit with space station, and part of the model would be low Earth orbit with space station. We'd go to the moon, establish sustainability in low Earth orbit in the moon, and then use that to move on to Mars. And I'm sure in the 70s, you know, when I was still in grade school, that we all thought we'd be on Mars by now. And I think we'd be a lot further along if we had some constancy of purpose, and also if we had reliable budgets. And I don't think it has to be a lot, but it just has to be dependable and not shifting around. So I think in order to ensure the vision, if we really want to get to Mars, going forward, we have to have constancy of purpose and not have starts and stops. And I'll talk a little bit more about that as we go forward. And then when I think about LEO, ISS, the moon, and Mars, then I also think about, okay, what's the roadmap over time? You have constancy of purpose. Okay, you get that, which means you want to keep going. But what are you going to do? How are you going to get there? Who's going to do what? What are you going to do in what order? And what are the roles and responsibilities wrapped around that? And how's it going to get paid for? And what's your operational model? And so my position is when you look at the complexity of this, and I think you guys have all been talking about it, you know, you have academia, international, commercial, industrial, governmental, and I think out of all of that, NASA leadership is critical to getting us to a near-term sustainable presence on the moon that feeds forward to Mars. And I think that overall model then that I had in my head, and I think a lot of us had, is that NASA working internationally and working with academia and industry would establish the low Earth presence and ideally find a way to transition it to commercial operation. And that's still what we're trying to do today. I wouldn't say it's entirely there. We certainly have what we call commercial cargo going there, and we're working hard on commercial crew. It hasn't been as easy to get to low Earth orbit as we thought it would be, but we're moving in that direction. And I know there's a model of ideally let low Earth orbit and a sustainable presence there ultimately be sustained by commercial activity. And then the next step is to basically have sustainable activity on the moon. And as you do that, we're going to partner with commercial to get there, cargo, maybe with crew. I think the ascent module is going to be a lot more complicated, just like crew to station is. But you do that and see if you can establish the infrastructure for commercial use and commercial business on there. And then NASA focuses on the next thing, what's going to Mars, either a moon of Mars or Mars itself. So every way NASA is pushing the bounds of the frontier, and as the infrastructure and capability is made available, commercial can come in and utilize. To me, I think that's a really good model, and I think it can work well. And the other thing is that ties with the international partners, the academic partners, and the industrial partners. So a lot of what I like to talk about is some people say, well, maybe NASA should go away and it should be all commercial. I think the answer is it's not NASA or commercial or NASA or international, it's and. I think it all plays together really well. But I think, when Kennedy said we were going to go to the moon, he said, we choose to do these things not because they're easy, but because they're hard, because that will serve to organize and energize the best of our energies and skills. And I think that's exactly what it does. And I think when we're looking to do the hard stuff, I think it's their job to push the boundaries of the frontier. There was a group that gets together regularly, but on the 6th Community Achievability and Sustainability of Human Exploration in Mars Workshop, AM6, in 2018, they concluded that a successful Moon to Mars human spacecraft flight program requires a single integrating authority with budget control to emphasize the synergistic results of technology operations, science, and trade studies, and that lunar and Martian priorities should not be assessed independently. And so that's where I think if you're looking for an integrating organization, I think that's why NASA exists, to do the hard stuff, to integrate, and to pave the way for the rest of the world. And then they can create the roadmap. The roadmap is done in a vacuum, right? We're all providing inputs, and we all have kind of our biased inputs too. I know from a rocket propulsion standpoint, launch propulsion and in-space propulsion, we have a lot of ideas and inputs. We're doing architectural trades, and we're going in and arguing for what we think the best case is. So is everybody else. We all know that. People are announcing architectures they have. People are announcing the technology they're developing. It's good because people are investing in technology. We have competing ideas, but at some point it's got to be integrated together into an architecture and a roadmap. And there can be parallel technology developments, but as that all works together, we want to constantly move forward and develop the technology we need to go in the direction we're going. And one of the things I also think about is I definitely think of the people providing inputs. I don't really believe that Congress or OMB or any single individual should be defining how we go to moon and feed forward to Mars. I think it has to be integrated together. I think their ideas are great, but it's not any one approach, and it's an and approach. But the other thing I want to think about is the strong attention to the timeline and the budget. So I think when we talk about 2024, we want to talk about, in my mind, that's so soon, who's on the critical path. And you don't have a lot of time for technology development. So we really want to get there by 2024. My experience in the commercial world and the real world is to do technology on the side, and we call it technology insertion, spiraled evolution, whatever you want to call it, but you go get the job done with the technology you have and can depend on between now and 2024. If you put significant technology development on the critical path, history has shown, at least, it's very difficult to get it ready in time to go because typically you have challenges and learnings. We should be developing that technology, but try and keep technology or any part of the architecture off the critical path so we can get there by 2024. I think that's absolutely essential. And then also the budget. You know, NASA's budget is they just went in with an amendment, so say it's hovered between 18 and $20 billion for a long time. Now we're talking with an amendment, it might be up to maybe 22, 23 billion, 20. In my mind, that's way different than the defense budget, by the way. Defense budget for the United States is on the order of $750 billion. So if you ask the average American what the NASA budget was versus the defense budget, they'd probably say about the same, or, you know, and it's clearly not. But the thing is that's the reality. You know, maybe we need a little bit more, but we can still, if we have constancy of purpose, we understand the budget we're going to get year after year, we can lay out the plans and achieve that. And that's where the partnering with everybody else to get all the resources pooled together provides an advantage. The other thing, I think the other point I want to make is that you have constancy of purpose, you have a roadmap, you have roles and responsibilities, and you have aggressive goals. And that's what I think's really important. That's what was so, what I would say, inspirational about Apollo 11. There was the Apollo program in general, there was constancy of purpose and there were aggressive goals. And aggressive goals can be very invigorating, very exciting, very aspirational, and very inspirational to bring people who want to come into this industry and actually see something meaningful happen in their lifetimes, and actually, ideally, within your first 10 years in the industry. I saw the first satellite I worked on launched probably 2 years after I started. The third satellite I worked on launched 6 years after I started. So just, to me, that was very rewarding, and getting, you know, kind of that, not having to wait decades or a lifetime to see something you're working on pay off. I think that ties back to aggressive goals and aggressive timelines, and it also drives innovation. So when you're challenged with that, that's when you get the creative thinking, and that's when you can be innovative. And I absolutely believe 2024 will drive innovation and will drive excitement and will attract more people to the industry. And then I think the next aggressive goal, I don't know what you guys have talked about this week, but I think 2033 is what I've been reading is what might be the earliest opportunity to put humans on Mars. And I think most people are saying, and there's a report out saying that can't happen. I think that's an aggressive goal, and if we really wanted to, we could make it happen. So I'm very much a believer in aggressive goals, but I also am a believer in realistic goals. So there's got to be some level of reality, and just because someone tweets it doesn't make it true. So it's got to be achievable at some level. And I say that seriously because I remember as the industry was getting shaken up, you know, I'd be talking to different reporters and columnists, and I'd say, I understand what's being said, but the physics don't support that and the timeline doesn't support it. It's just not reality. And they said basically, Jim, nobody finds your reality exciting. And so I've had a lot of thinking about that, and I don't know the answer to that, but it's got to be aspirational, it's got to be aggressive, but to me it's got to be achievable. Otherwise, you know, strategy without execution is hallucination. So the next element I think is really important is risk, and we're not talking about all that much, but I think we got to get aligned around as we go to the moon and we feed forward to Mars and we integrate together and we try and enable and help commercial leverage infrastructure and be part of all this activity. What level of risk can we accept? Right? When I was a jet engine guy, when a fighter went down and a fighter pilot died, it was considered a bad day. When an astronaut dies, it's a national crisis. And so are we going to continue on that path? Are we going to be willing to accept risks? Will we accept risks until something bad happens? We got to get aligned around that because that feeds directly into the roadmaps we have, the timeline, how aggressive we can be, and our willingness to take risks because you only learn in advance by taking risks and having failures. Now, failures, in my mind, doesn't mean people die. Failures, ideally, people survive and you learn from it, but you can make mistakes. But I think we got to get aligned around what level of risk is acceptable if we're going to operate in a model that integrates all of these different constituencies together. And then finally, you know, the technology to back the roadmap for sustainable feed forward. I'm sure you guys have been talking about it all week. You know, Gateway is going to be, right now it's going to start off as sort of they call it slimmed down Gateway. It's going to be a small space station in near rectilinear halo orbit. It took me forever to learn that when I came back. with solar electric propulsion. We're building the solar electric propulsion for that now. But it's pretty high power. Nothing that high power has been built. So we've been working hard on developing it, and we got to produce our flight propulsion for SEP, which should get awarded for PPE, which should get awarded ideally this month, is what we're hearing. Landers and ascent vehicles. So in 2024, we've been kind of looking at, if you want to land and you want to use existing technology, we know how to do it with storable propulsion. We actually know how to do it with hydrogen too, but it's not clear to me that we've got the cryo storage capabilities for hydrogen and that we've developed all of that to be reliably done by 2024. I think that would have to be looked hard at. We have an RL-10 engine that's flown over 500 times, and we've throttled that down to 10%. We did it in the early 2000s to demonstrate it for lander technology. I think hydrogen might be the ultimate technology for payload capability, but in the near term, our studies show that storable would be, if you're going to put it on critical path, that we understand that technology in terms of long duration and getting to the moon much better, but those trades will be done. And that's what it gets back to, and other people talk about methane, and then you get into what's our in situ resource utilization? Are we going to take water from the moon and turn it into LOX and hydrogen? What kind of power will that take to do it on the moon? Surface power, how are we going to do all that? Cryo transfer, we want reusability, right? So the idea behind a sustainable presence is to have reusability. Part of reusability then is to take the vehicles we've put on the gateway, or take vehicles we're landing on the moon and fill them back up and keep reusing them over and over again. And we need to develop the capability of that. We need to develop propellant transfer capabilities. All of those have to fit in. And then you talk about especially as you're going to Mars, what are you going to use for surface power? And likely solar is probably going to be challenging there. It'll have to be supplemented by some sort of nuclear power. We've been working on nuclear surface power for a long time. How much autonomy do you need? When you think about it, I got to look this up. I can't keep it in my head, but low Earth orbit is 200 miles for International Space Station. The moon is 238,000 miles, and Mars is 140 million miles. So part of the idea is, as you get further and further away, we want to learn how to operate at a distance of 140 million miles away while we're 238,000 miles away, in my opinion, because that's where you can practice these things. You're only a few days away from Earth. From a communication standpoint, it's much faster. Round trip comms just from Mars to Earth and back, if you're asking a question and it has to be answered, is probably on the order of 30 minutes going both ways. So how much autonomy do you need on Mars to sustain? And when you're getting to Mars, how are you going to get there? I think everyone's generally thinking cargo first and then human second. Cargo, you can use electric propulsion to take cargo out there because you can take more time and you want to take as much mass as possible, probably 20,000 kilogram loads at a time. Probably need 4 of them before you even send humans there. Send all that in advance, and then humans, the last panel I heard them talking about that, for all those considerations, radiation, isolation, microbes, all those things, you want to go as fast as possible. And the fastest way we know how right now is with nuclear thermal propulsion. We flew nuclear thermal propulsion rocket engine in the 60s, haven't flown one since. But we think it's time to talk about that if you really want to minimize the time to getting to Mars. And so when you sum all that up, it's really easy, right? Makes a lot of sense. But to me, that's what makes it exciting. And the thing I summarize with Apollo 11 is, as much as I love our history and I find it exciting, I'm more excited and more inspired and have higher aspirations for how we can leverage our history to doing what we're talking about here, going to the moon and feeding forward to Mars. And I definitely want to see both those happen in my lifetime. I don't think it's too late. So that's what I have. Thank you very much.
We are at break time. I'm sure you have questions for Jim. It's like stick around, have a snack, and here's my best John F. Kennedy. We chose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. But it's not hard to have a snack. Go have a snack, but if you're going to help us pass out Human to Mars reports, please meet us in the lobby. We want to make sure we equip you as you join us on Capitol Hill tomorrow. Go and enjoy.
Thank you, Janet, for channeling JFK for us. This is the first break on the third day of the Humans to Mars Summit, coming to you from the National Academies of Science in Washington, D.C. If you've just joined us, well, first of all, you've missed a great discussion about space medicine, human factors in space, from a large and very expert panel. And it was led, actually, by my webcast co-host, Sonia Gavankar. We have much more ahead of us today. Coming up in only about 20 minutes at the close of this break will be a panel based on or related to the work of the newly reconstituted National Space Council, which, as you probably know, is headed by Vice President Pence. And then we're going to turn beyond the borders of the U.S. for a panel about international collaboration, which is an essential part of virtually every mission that takes place nowadays. A mission of exploration, and certainly will involve our work exploring the moon, putting humans back on the moon, and reaching Mars. And we also want to thank, you want to come on in? Hey, great panel, by the way.
Thank you so much. I'm just running off from the early morning panel. People are really engaged this morning and heading out into the first break.
I heard you say that you were going to be joining everybody out there outside. Great panel indeed. I also want to thank, there is one group, the National Institute of Aerospace, which is why the two of us get to stand here. They are the sponsors of this webcast.
Oh, well, thank you to them, because without their support, you at home wouldn't be able to watching in record numbers this year. And you can also tune in after the fact to relive it all again and take notes if you need to.
So we have a few more minutes in this break to fill those, and we are going to get back to some of those Project Mars videos, because we're going to try and show all of the ones that we have before we're done.
Excellent. And I know that Lisa's right here from the 9 a.m. panel. She's coming right off the stage to take us even further into the conversation about going to Mars and being humans there.
You bet. So Lisa Pratt, come on right in here, step into Sonia's spot. Lisa Pratt, you are the Planetary Protection Officer for NASA. There's only one other person with a job title as cool as yours. That's Lindley Johnson, the Planetary Defense Officer, one of your NASA.
Goodness, that's not part of my responsibility. I usually have to, the very first thing I have to tell people is I'm not the one watching the near-Earth objects and worrying about a collision.
But we did hear on this panel, you largely talked about the part of your role that has to do with protecting our own planet, Earth. I'm going to go on to protecting Mars, but first, just to mention a little bit of this, I mean, not surprisingly, you're listed on the NASA website as an astrobiologist, but what is a biogeochemist?
Well, a biogeochemist is somebody that does research right at the disciplinary boundary between the traditional disciplines of biology, chemistry, and geology. So that is a field that really has only sort of emerged in the past, say, 10 to 15 years, with the recognition that many of the most challenging unknowns, many of the knowledge gaps, reside between the traditional disciplines.
One of the slides that you presented with the panel a few moments ago, Sonia's panel, I think was a great illustration of this, because it showed us sort of a cross-section of the Martian surface, what we think may lay below the surface, and how close to that surface might be the liquid water that we know life needs to survive.
That is a really important point. We don't know where the liquid water boundary is on Mars, in part because Mars has extreme orbital obliquity. So Earth has a tiny little wobble of a few degrees, and yet that drives glacial, interglacial climate change. Mars goes from its present very modest obliquity, very similar to Earth's, to single-digit obliquity, and then can roll over all the way to 60 or 65 degrees. And when it's in extreme obliquity, and we think that might be about every 100,000 years. The planet is fundamentally different, and so it is a planet that is seasonally warmer than the present day. The water migrates from its current polar ice caps into low latitude areas, and we think that's when there would be an opportunity, if there was a Martian organism that had evolved in this extreme obliquity variation, that it could get through the cold, dried spells like the present day and be ready to reemerge under better conditions. So it's a really important aspect.
We know now, thanks to our flotilla, the armada of spacecraft above and on the surface, that Mars was, billions of years ago, a place that could have supported life. We still don't know if it's actually there, but we have to assume that it may be, or that it did exist in the past.
I think so. I think that's why I use the word prudent. We have a responsibility to life on Earth to be cautious about first contact. First contact only happens one time. It's like first date. You don't get a redo. And I think we need to think very carefully through. We may have already carried problematic terrestrial organisms to Mars because we can't fly a sterile spacecraft. So with that in mind, we need to be very, very thoughtful about how we bring samples back to Earth from Mars until we have a very high degree of confidence that there isn't anything biologically active. If there turns out to be life on Mars, then we need to decide, does it in any way present a hazard for life on Earth? Or is it that we're actually closely related because life originated on one planet or the other and inoculated the other location?
Which is a concept that we talk about on my radio show periodically, that maybe we're all Martians if you go back far enough.
From my perspective, I can't think of anything more wonderful than to meet the Martians and find out that they're relatives. I think that would just be, I just think that would be glorious.
You also made the point during your presentation that we still have a lot to learn about life on Earth. And so it sounds maybe even a little presumptuous for us to think about how we're going to find and maybe protect life on Mars.
I completely agree. I think that we're going to be challenged to recognize life if it, like some of the organisms on Earth, is small and not easy to visually identify or to grow in a laboratory setting. So we're going to have to pull out all of our very best tools. And I think one of the other panelists made a very good point about our emerging microchip kind of technology where we can sequence not just the DNAs, RNAs, or XNAs, but we learn to identify and characterize other macromolecules and other biopolymers that we could easily imagine a successful Martian organism would need to survive that environment. So we can start to do synthetic Martian biology. We can do computational chemistry that gives us examples, analogs, that we can then test against, say, a sterilization procedure to see if it would denature something that we could imagine would be something produced by an extraterrestrial.
That's a bit mind-blowing. You're talking about alternatives to DNA and perhaps to proteins that we know make up life on Earth?
I think most of us assume that it would be hard to get away from protein. It might be a protein based on a different suite of amino acids or a different, handedness than life on Earth. I think more in terms of the kind of resistant, resilient biopolymer that an organism could cover itself with to minimize UV damage or damage from the harsh oxidizing or ionizing environment. So I think of it more as the coating around the exterior. On the interior, I assume that it will follow the same basic rules of biochemical reactivity that we have on Earth.
So maybe tough little critters if they're up there, and yet we go to great lengths to protect them. You surprised me backstage because I knew that Curiosity, the current rover on Mars, is being very careful about where it goes, has been very careful, no damp spots, because we know it wasn't perfectly sterilized no matter how hard JPL might have worked. But I thought that the 2020 rover launching next year was going to be in better shape, would be looking for those damp spots.
No, I think I'm glad you told me about that because it's a misconception that I need to make sure we're addressing. There are the same restrictions on the Mars 2020 rover that are on the current Curiosity rover. Now, what's different for Curiosity is it's been on Mars long enough that we might consider giving it credit for the biocidal processes on Mars and say it's now much cleaner than when it landed. And if there was an opportunity to look at a location that might have water vapor or movement of water, either day, night, or seasonally, it could be proposed by the rover operators that they be given permission to go in on the basis of the rover being orders of magnitude lower terrestrial bioburden than when it started. We've never been asked that question. I think...
Are you listening, JPL?
I think the international community would welcome the opportunity to address that question because we would want to do that by international consensus. It wouldn't be a NASA-only decision.
I hope you get that call from that international team that is still rolling across Mars with Curiosity. Okay, we'll finish with this, and it's the biggest challenge to the Red Planet, and maybe your biggest challenge. If we're going to put boots on Mars, those boots are going to be carrying all the nasty stuff that we humans have inside us and on us. How do we protect the planet then?
Well, that's a completely different, that's a different environment than we're in now scientifically. I would say the single biggest unknown on Mars is whether or not terrestrial life that would leak out of our spacesuits or leak out of our vehicles, that it can get onto the Martian dust and be moved across the entire planet. So if we could limit the human contamination or the human associated contamination to just the exploration area, I think we could manage that. The problem is we don't know whether or not we could manage contamination that is vectored by the dust. So we're actually, NASA and many other space agencies are putting increasing funding into modeling and doing wind tunnel aerodynamic studies of Martian dust analogs because we need to know. And then we need to know, really, whether or not a terrestrial organism of any of the ones we've tested, could a hardy resting cell, could a hardy spore, get onto that dust and be moved unintentionally to a damp environment.
Just a couple more, because out of that I have to ask, you must be aware of the exploration of using spacesuits that never come inside the human habitat, that you sort of jump into through the wall, they seal the door behind you, and you're out on the surface of Mars.
The problem is all of those spacesuits have joints because you have to be able to move and walk and turn your head. And so a lot of research right now associated with the Planetary Protection Office is looking at sampling, swabbing, wiping, and characterizing how much of the human biome gets across the leaky sites. So hopefully, eventually, we'll have a spacesuit that really has little or no leakage. But right now, we don't have that magic wand. So it's a big concern. You're stepping on something that makes my foot hurt.
So see if this makes your foot hurt or cringe or did it. When you saw the movie The Martian, which my friend Andy Weir, with his potatoes and all the other nasty stuff he used to grow them, and then he was single-handedly infected the planet. Did that just have you cowering in your seat?
No, for me, that movie is so emotional because I wish I was the one there. So for my family won't even let me watch that movie because all I have to do is see the opening scene, and I just have tears running down my face, and they're like, "Oh, Mom, you're just, you'd go, wouldn't you?" And I go, "I'd go on a one-way ticket."
I'll go with you.
Because, I think I'm at an age where I've done what I can do on Earth, and the chance to be an explorer on Mars would be absolutely irresistible. Thank you.
I've promised my family I won't do the one-way trip, but I would love to go with you if I have a trip back as well.
Let's go together.
Thank you. Look forward to it. Hope we get the shot. Thank you, Lisa. All right, that was Lisa Pratt, the Planetary Protection Officer for NASA and for our planet, and for that matter, for all the other worlds across our solar system. It's her job to make sure that we take care of all of them. And I'm told, I guess we had mentioned that we might be going to some Project Mars videos. We're not going to do those.
We're going to save them for later. We'll be seeing them later on in the program, which just gives us more time to tease what's coming up next. Some conversations about deep space will be coming up here in the main stage. And then, of course, as we move into the lunch hour and our breakout sessions, you can see what's happening here, and then we will post those up after the fact. And of course, join us on social media. I have 2 questions that I need to get answers for on social media. I don't think we have time to grab the people for video, so I'll answer them if you use the hashtag #HumansToMars. I'll find the right answer and I'll tweet them back to you.
Great, and you can do that. Use that hashtag, #HumansToMars, 2 spelled out. Sometimes it's the number 2. In this case, it's spelled out, right?
Spelled out.
And we will try and get those questions to, who knows, any number of the top experts.
We've got so many brilliant people in this room. We've got great answers, great questions happening on the stage, but also throughout the programming. So it's a great opportunity to get those answered. I'm also seeing a lot of school kids watching from different schools. They're watching the live stream. They're wearing thematic shirts. So they're really engaged, and I'm excited to see that as well out there.
And this afternoon, the president of Explore Mars, Janet Ivey, who has just come back to the stage, so I suspect we're ready to pick up again, she is going to be playing host to something up to like 50 kids, because this is a great part of Humans to Mars. Every year, we bring in young people, and they actually get to participate in the summit. So that's why Janet was saying earlier today that she may not be seen very much this afternoon. She'll have her hands full. With that, though, since you don't have those charges yet, Janet, I guess we're ready to take it back to the stage, and Janet Ivey.
Guys, I know it's like, what I love about the energy of this particular conference is like we enjoy one another's company, both in here inside the auditorium and outside there. So as a few more people come on in, I don't see my good friend Dr. Bob Crone in here. If you get a chance to meet Dr. Bob, I was going to get him to tell you a little bit about Kepler Space Institute. I would ask you to Google that. He's doing something fantastic. They rolled it out this week. By the fall, they will have all manner of courses online so that you could earn your master's and or your doctorate through the Kepler Space Institute. So keep that in mind, especially if you're watching online, something to check out. So let me make sure, let me see. And they're back there. All right. Looks like we are we waiting on one? All right. Well, welcome on in. A few things just to continue to update you about. Tomorrow, we have decided to meet at 9 a.m. in the cafeteria in the Rayburn building. We had, I think, about 6 people out there commit to taking our Human to Mars report to Capitol Hill tomorrow. So if you did not happen to join in, before the end of the day is out, and especially as I transition to work with the kids this afternoon, please pick up those reports if you're willing to go with us tomorrow. Even if you can only do a couple of hours, we're going to try to blanket Congress with that report. So next up, we have some National Space Council Users Advisory Group questions and answers. Our moderator for this afternoon is Dr. Mary Lynn Dittmar. Afternoon. Maybe that's just because I've been up since 3 a.m. So it's still only 10:45. Dr. Mary Lynn Dittmar is President and CEO of the Coalition for Deep Space Exploration and the Space Studies Board of the National Academies of Science, Engineering, and Medicine. In June of 2018, she was appointed by NASA Administrator Jim Bridenstine to the Users Advisory Group of the National Space Council and was then appointed by Department of Transportation Secretary Elaine Chao to the Department of Transportation Commercial Space Transportation Advisory Committee. She is a capable lady and with a very exciting panel. Please make them feel welcome.
So, good morning to all of you. Appreciate you hanging around for the policy panel, staying awake. Did you get your coffee? Just want to make sure. Well, I want to introduce my fellow panelists. I don't have their bios in front of me. Dave Thompson here on my immediate left. Dave has a distinguished, very distinguished career in aerospace. He's the founder of Orbital Sciences, parlayed that company up into a Fortune 500, and eventually became part of Northrop Grumman a bit ago. So very welcome to have you. And then my other colleague and friend, Dave, Eric Stallmer. Eric is the president of the Commercial Space Flight Federation. So we're here today representing the Users Advisory Group of the National Space Council. And the way that we're going to do this is we're just going to talk very briefly about what the Users Advisory Group is, all of the organizations that it interfaces with, what it's supposed to be doing. We're going to talk a little bit about a couple of the subcommittees that are that make up the Users Advisory Group. There are actually several of them, but we're really just going to focus on a couple that are relevant to this conference. And then we're going to open up to you. The UAG has been doing a series of these listening sessions across the United States for about the last 9 months, where we gratefully accept invitations to come to conferences and have a chance to interact with folks that are in the community. And so that's really the purpose of this today, is not for us to preach at you so much, but for you to be able to ask us questions. So I'm going to move on. So the National Space Council was stood up, as many of you know, about a year and a half ago. It was a revitalization of a previous body that last was active during the Bush administration. And the Users Advisory the Users Advisory Group was set up to advise and provide input into the National Space Council. So the National Space Council interacts with NASA for administrative work mostly. We're not a part of NASA. We don't take direction from NASA. We don't give direction to NASA. We also interact with ourselves. So there's, as I said, a number of committees. Other entities that we work with include DoD, industry, we're very much an industry representative body, scientific community. We have outreach efforts that include existing venues, so the National Space Society, IAC, American Institute of Aeronautics and Astronautics, all of these have sort of already interacted with us and will continue to interact with them. There are no issues that are off limits for the Users Advisory Group. So we don't have a constraint. We're not told ever that, no, you can't ask those questions, or no, you can't go there with those inquiries. And the chairman, who is Admiral Jim Ellis, he convenes with the National Space Council if we do not. And what's simply meant by that is that he has more interactions more frequently with the National Space Council than can the entire body of the UAG. So the description of our duties, you can read the slide, to ensure that the interests of industry, other non-federal entities, and other persons that are involved in aeronautical and space activities are adequately represented to the National Space Council, to provide subject matter expertise to the Council, to submit findings and recommendations to the Council, to conduct studies, reviews, and evaluations as requested by the Council, and to submit an annual report to the Council on our activities as reported by the Council. So one thing I want to make clear is that the UAG is not a policy-making body. We do not make policy. We don't even recommend policy very strongly. However, we do raise issues that we think that the National Space Council needs to be aware of. The construct are these subcommittees that I mentioned before. We're going to talk today a little bit about the Exploration and Discovery Committee, and then also the Economic Development and Industrial Base Committee that Eric chairs along with me. Then the Executive Committee is made up of the subcommittee chairs. So it's a straightforward organizational construct. Okay, each one of the subcommittees has a chair. Those chairs make up the Executive Committee, and that's chaired then by Admiral Ellis. So our brief discussion today of three of the subcommittees, I'm going to ask Dave talk a little bit about exploration and discovery. I'm going to ask Eric to talk about economic development and industrial base, and I'm going to come back and just say a word or two about the technology and innovation subcommittee. And then what we'll end up doing is opening the floor to you. So Dave, you want to take it away?
Okay, well, thanks, Mary Lynn, and good morning, everyone. Maybe just a little more background on the National Space Council and how it's a bit different this time around than in the past. The Space Council actually got started during the Eisenhower administration, and it was pretty active during quite a bit of the 1960s under Presidents Kennedy and Johnson, and it continued for a few years under President Nixon, and then it was largely disbanded and its charter handed over to other offices in the White House. It was revived in the late 80s, early 90s under President Bush 41, went away again for a while, and then as Mary Lynn said, has come back beginning about 18 months ago with the current administration. This time around, though, unlike in the past, the Space Council has an advisory group representing the major groups of users of space technology and systems, and you're probably mostly interested in two of those, human space flight activities and space science activities. So the first of the 6 subcommittees that we've divided ourselves into really concerns those areas, and the exploration and discovery membership is listed here. And so at I guess our first organizational meeting that occurred about a year ago, Scott Pace, who's the executive director of the Space Council, gave us some homework assignments, and a couple of those naturally fell under this subcommittee's purview. And one of those, which is listed here, I'll maybe reformulate it a little bit because it's evolved a bit since we got started. At the outset, though, the question that was posed to this subcommittee, or one of the two, was how can NASA accelerate the U.S.'s return to the moon? And that's an area where there has been some significant progress in the recent months. As I think you all know, back in March, NASA was given the high-level mandate to rethink its approach to lunar exploration such that we can put people back on the moon within about 5 years. And I think this is injecting some much-needed urgency into not only the agency's behavior, but that of its industry partners as well. Some of the things that I think are needed to accomplish this include opening up a somewhat broader set of technical and programmatic options for how we go about returning to the moon, looking at, as you've all read, scaling back, at least in the near term, or removing from the critical path the Lunar Orbit Gateway, using a mix of different launch vehicles to position the necessary landing systems in lunar orbit or in other convenient locations, and also adopting more flexible business models and contracting approaches to implement this program. A second area that you heard Jim Mazur address a little earlier this morning was the likely need for some amount of additional funding to NASA's budget over the coming years, on top of roughly the $100 billion or so that the agency was planning to spend. Another 5 or 10% may be needed on top of that to implement this accelerated program. And then finally, I think a change in culture, both at NASA and in the industry, will be needed to carry this program out. So the advisory group will continue to provide our suggestions to the Space Council to see that this accelerated return to the moon has the best chance of succeeding. Another topic that Scott Pace asked us to look into beginning about a year ago is listed here, and I would probably summarize this as in the following question. What new types of space-based science missions can be enabled or enhanced by piggybacking on the new human lunar space infrastructure that the country is going to develop and put into operation over the coming years? Space-based science is one of the big four users of space, so I'm particularly excited to see this area getting a good deal of attention. And this is an area that's been studied for a long time. The national academies have sponsored a number of reports. For instance, if you go back about 10 years, there was a very comprehensive study of lunar surface science that could be carried out once autonomous systems as well as human explorers return to the moon. And there are certainly other areas in heliophysics and planetary exploration that could benefit from this new lunar infrastructure that's being put in place as well. In discussing this, though, over the past year in a variety of settings somewhat like this with scientific experts, two particularly exciting possibilities have emerged, neither of which are completely original ideas. In fact, one goes back quite a long ways, but with modern approaches to the way they would be implemented, these two areas, I think, have a great deal of potential over the course of the next decade to enhance our understanding of the universe, and in particular, our search for life on other worlds. The first of these, an idea that stretches back at least 50 years, involves the deployment of a radio telescope array on the far side of the moon. As most of you can imagine, the far side is, from a radio frequency standpoint, the quietest place within several light years of Earth. And so it's an ideal place for a low-frequency radio telescope that can address not only some fundamental questions about the early evolution of the universe, but also can provide some very important insights into the habitability of the many exoplanets that we're discovering around other star systems. And with novel approaches to how such a radio telescope could be deployed, once we have both autonomous and human landers going back to the surface of the moon, this appears to be something that could be done pretty expeditiously and for, by space program standards, a relatively modest investment. The second area, also one that's been contemplated for a long time, involves the construction and deployment of very large aperture optical and UV telescopes in desirable locations, particularly the L2 point in the Earth-Sun system. Very large in this context means telescopes with apertures that will rival the largest ones that we're likely to have on the surface of the Earth towards the end of the next decade, 25+ meter diameter in-space telescopes. And these would, among other features, allow for direct imaging of exoplanets around hundreds of relatively nearby stars. These telescopes, however, being so large and being difficult to launch all in one piece, are likely to benefit from in-space assembly and servicing and upgrades using some of the same transportation and in-space infrastructure that we are developing now and that will evolve with the lunar program over the course of the coming decade. So those are two of the particular topics that this committee has focused on, and maybe we can come back and talk about those in a little bit, but let me now move things on to Eric, and he'll tell you about a couple of the other committees.
Thank you so much, Dave, and thank you, Mary Lynn, for sharing this. So the Economic and Development Industrial Base Committee is a really eclectic group of leaders from throughout the industry, as you can see, from ULA to SpaceX to Blue Origin, and Alabama's represented in some of the newer entrants, relativity space. As Dave gave a pretty good overview of the history of the National Space Council, my history of the National Space Council was very limited. When I got into the space industry in the 90s, the National Space Council went away. So everyone always talked about the National Space Council, and for every presidential campaign, on both sides, they said we need to get a National Space Council together. And I wasn't really sure what it did during those different administrations. But I can kind of, shed some light on what I'm seeing, what Mary Lynn is seeing, and Dave on the work that's being done, and I guess the level of enthusiasm that we're seeing. As I said, it was about a year and a half ago when they stood this up, and I think this is, it's headed up by Vice President Pence, and I would argue to say it's probably one of the top priorities for the Vice President. Obviously, he has many priorities on his plate, but the level of attention that he and his staff have given, the level of access that the National Space Council staff, led by Scott Pace and his team over there, the attentiveness that they have had on our issues has just been fantastic. So, at first it seemed like a slow boat turning, but now that it's turning and the meetings and the briefings that we're having, I'm seeing a lot of traction in it, and it gives me a lot of enthusiasm for the work that we're doing. Like Dave said, we were given a lot of topics, various areas. If you talk about industrial base or economic development, industrial base, I think it became a little clearer why Mary Lynn and I were tasked to co-chair this committee. Mary Lynn with her coalition of scores of different companies, and my organization, with the many and diverse companies that we have, we really have to put a lot of attention on what our companies are doing, what they can do, and what we should be doing. And I think this is a great opportunity for us, especially in the areas that we're focusing on in low Earth orbit, the commercialization of low Earth orbit. What are the next steps that we should be looking at and taking it, and how do we utilize the strengths that the government has to encourage and facilitate the work that the various companies are providing. So what's been very helpful for us on the Economic Development Committee is to be receiving briefings from all different organizations on what they're doing and how we can do it better. So I think it was just last week we had a briefing from the organization that used to be CASIS, the International or ISS National Labs. And they gave an overview of how they see the growth and the investment that they're putting in and where that growth is going, the variety and the diversity of companies that are investing and doing work on the International Space Station. And also we talk about what that means for the life of the International Space Station. How can we, as time is ticking, I shouldn't say it that way, but as the expected life of the ISS, do we extend that, or how do we parlay the precious NASA dollars that they have on kind of encouraging the next steps as we're talking about going on to the moon and beyond? How do we, with the $20 billion and hopefully this $1.6 billion addition, we'll see, and what that can mean. We also talked to NASA on what their plans are. What are your plans in low Earth orbit, and where do we fit in on that? And then we, from the NASA Advisory Council, we had a very good brief on what they're doing and how our efforts can parlay on those issues. I can tell you, though, that from our experience as the chair of this committee, of our interaction with the Vice President and with the President, that space is really a top priority. I don't want to name drop here, but I'm totally going to. But when Mary Lynn and I were at the White House about 3 weeks ago or so, and the Vice President came in, and there was just a handful of us there, he made it very clear what the president's goals were. And the first one he said was that he wanted to go to Mars, and he was very committed to going to Mars. And I think people said, well, before we get to Mars, maybe the moon. And so the focus and that shift is on the moon and what we're going to do to achieve that in 2024. And as we're seeing the rollout of how that's happening, I think it's very exciting. But there is a tremendous commitment by this administration on that. So the topics on this, the other one, I went ahead a little bit. The other one we're looking at, if I just go back on the focus areas, the other one, hot potato that we got handed on this committee is spectrum and the critical need and organization of our spectrum. And I made it very clear at the outset, and Mary Lynn concurred, that neither one of us were experts on spectrum. And but what we were able to do was bring in those experts out there, the folks that are working day in, day out on spectrum issues, and try to find consensus on what the problems were, what the issues were, and how can we address this. And we submitted a white paper to the Space Council on what we think the key areas are. But these are growing documents. These are living documents that, as Mary Lynn and Dave said, is the whole reason why we're here today, why what we're doing is to be an ear to the ground, to industry, to the community on what are the big problems that we should be tackling, what are the recommendations we can make, and the impact that we can have. Again, we don't make policy, but we certainly can highlight what some of the policy areas that should be addressed are, and I think we've been very effective on that. There's been 4 space policy directives that are, I think, in line with a lot of the vision of the space community. So those are some of the key areas that we're looking at. But our plate is never too full. It is too full, I should say, but we're always taking on more issues, and that's why we like to do events like this, so we can hear from the public on what the key priorities are and if we're missing anything. So with that, I'll turn it back over to you, Mary Lynn, and get going.
Thank you, Dave. I'm just going to touch briefly on the last committee that I know has relevance to some folks here. It's very focused on technology development. These are the folks that are on that committee, and it's chaired by Pam Milroy, who has a great deal of experience in technology development. She was at DARPA for some time as the Deputy of Technology Development, and was a former astronaut, and spent some time in Australia helping the Australians set up their space agency. So that committee has had a couple of telecons. Actually, since these slides were put together, they've done a little bit more. And their real focus right now is on developing a space technology roadmap. There is one. It was done several years ago, actually, with NASA and the National Academies. A lot of this conversation is very well situated here at the National Academies, because the Academies has interacted a great deal and supports a great deal of the development of U.S. Space policy. So a technology roadmap was put together several years ago, and it needs to be updated. So one of the things that's happening now is that Pam and her committee are interacting with the Academies and then also with others to talk about how it is that you frame that technology roadmap update. As you can think about it, technology development, as it touches on space exploration, space science, space commerce, it basically underlies all of those things. And so one of the biggest problems facing this committee is how do you bound it? Where is it that we want to focus in terms of looking at space technology development? And then the second one is space data as a U.S. government capability versus buying it as a service. Some of you may have been following the discussions. Is there more and more data gathering capability that now exists inside the commercial sector? How is it that the United States makes best use of that data as it's available? Do you want to be buying it as a service? Do you need the government to produce it? Well, in some cases, yes. In other cases, a service is probably better. How do you structure that entire discussion going forward? And so they're looking at that. Also focused on regulation that encourages innovation with basically necessary commonality. And the point there is essentially, if you have great ideas about innovating and developing new technologies, as soon as you start talking about standardizing that or having to meet some standards, you're introducing some constraints. So how is it that you bound that? How do you encourage innovation? Structure regulation so that it encourages innovation, opens the door to innovation, but doesn't over-constrain it. And then they're developing a list of game-changing technologies. So that's sort of our short version of 3 of the committees that are currently engaged on the UAG. We want to know what you think. I mean, you can read the slides. What do you think we should know? What are your concerns? What are your thoughts? What should we be considering or paying attention to? I also want to make a note of the fact that you can submit on your own. This is open to the public, comments and questions, white papers, okay, using this email address. It's hq-uag@mail.nasa.gov. I do want to note that the submissions are open, so they're basically available to anybody to have a look at. So if there's proprietary or confidential information, you absolutely should not submit it versus that avenue, because it will be seen. And then there's also more information that's available at the UAG, basically at this website here. So if you just Google Users Advisory Group National Space Council, it'll take you pretty much right to that page. So I think I'd like to stop now and just ask if there are questions.
Yes, good morning. My question involves long-term planning for Mars. Long-term to me is over 100 years. And so what I'm asking about is what is going on at the NSC about terraforming Mars and using Mars. You know, it's one thing to go to Mars, and this organization here is very focused and concentrated on getting to Mars and using the moon as it should be to go to Mars, and that's great. But I worked on the Apollo program, and I lived in the Apollo era, and noted that we did have a follow-on Apollo program, but because of a lack of budget, and that was because of a lack of plans, nothing happened, and here we are 50 years later. So I would hate to see the same thing happen to Mars. And to me, a long-term plan for using Mars once we get there, and possibly starting to terraform Mars and having the visibility that Mars really can be a planet you can live on would be a very good promotional activity, and to get to Mars in the first place. And so the basic question is, does the NSC have an arm looking at long-term planning for Mars, and namely terraforming? And that includes science and infrastructure and everything else.
Okay, so right now, no. In a word, the focus of the National Space Council, we probably should have said this a little bit when we were talking about the National Space Council. One of the goals of the National Space Council is to actually try and engender a whole of government approach as much as possible to deal with a lot of the issues in space, because they do tend to cut across multiple agencies. So as I'm sure you're aware, there have been discussions in science circles for some time, as well as technology development and infrastructure circles, about what is involved in actually when you get somewhere, right? So there is a whole lot of discussion about how to get there, but what are you gonna do when you get there? And so at the moment, because the focus is on the moon as that stepping stone to go to Mars, and there's so many challenges just to get to the moon, right? We're still working on architecture, as Dave mentioned earlier, right? I mean, what's the approach? What are we gonna do when we get there? There's a lot of discussion about being able to process raw materials on the moon, but the fact of the matter is that we still have a ton of prospecting work to do there before we even know really exactly what we're dealing with. So I think the idea is to think about the moon as what can we learn from it? Not all of the lessons that we'll learn on the moon are applicable to Mars. What is it that we can learn there that is applicable to Mars? So there are long-term thinkers, but as a policy matter at the moment, there's not a lot of focus on this. We'll definitely take the input.
And just to echo what Mary Lynn said on the structure and the makeup of the Space Council, the idea, as it was first laid out, was issues that, a Mars issue may focus in NASA's lane. But when these issues kind of cross over to the different agencies and different departments, how do we find resolve with that? And the Space Council as a whole, working on those issues, the Space Force was one of those that had many different agencies or departments that were impacted. But, you know, and I think it has evolved a little bit from the conflicts to more of the opportunities that they see, you know, when the Space Council gets together. And I think that's refreshing in that aspect, that it's not the, you know, the infighting between transportation and commerce. It's where's the common ground and where should the end state be.
Okay, thank you.
Thank you.
Good morning. I've got a question about the technology roadmaps. And I agree, it's probably time to revisit them. When you do, how do you try to categorize them so that don't have embedded architectural decisions in them? And by that I mean things like cryo transfer or cryo storage or artificial gravity. Those are areas where there's research that's needed, but it's not necessarily applicable to all architectures. So how do we keep from locking ourselves into one course and ignoring potentially others that may emerge?
I can do a quick call on this just because I've talked to Pam about it. And then I'm certainly going to throw it open to others. That both what you say, okay, which is to bake in the assumptions about architectures, that's one problem. The flip side is, how do you bound it, right? So that you're not trying to tackle every conceivable, possible, relevant technology. And all I can tell you right now, I wish Pam was up on the stage, is that that's the conversation they're having exactly right now. So the subcommittee is aware of those issues, and how is it that you drive it, right? So that you're able to define the way that you're going to look at that roadmap, so that you, A, don't do what you're suggesting as a possibility, which then drives the entire technology roadmap in that direction, and potentially you lose things that you should not be losing, versus opening the thing up so that now you're all over the map, right? And you never get the study done. So kudos for putting your finger on one of those key issues, and they are struggling right now. Well, I wouldn't say struggling, but they're having a discussion. They're making some progress, but they're having a discussion right now about exactly how to do that.
Okay, thank you much.
Yep.
All right, well, thank you for taking a look at asking people to provide information on groundbreaking technologies, and we appreciate that, and particularly with our next speaker who's talking about how blockchain can impact humans to Mars and space exploration. What are you doing to get the word out to non-traditional players? Because there are an awful lot of, we've seen as we were planning this conference, and we've been speaking to over the last year, a lot of different non-traditional companies that could really have this groundbreaking technology, but they're not actually aware of their opportunities to engage with the space community. And we're seeing a lot of great ideas, but I think there's just not, a lot of people don't know they can actually contribute. So what are you doing to get the word out to them that maybe you have the idea that might actually solve a big problem that we've been trying to figure out for years within the space community?
Great question.
I think as we do these type of events, you know, our spheres continue to grow a little bit with the different organizations. What might be the right answer? The certain group with AIAA is different, you know, with the Mars group. One of the areas that we look to those non-traditional or not, you know, space, you know, related companies is like the Silicon Valley, and where the investments are, and where that type of new innovation, and we're getting the word out to that area. And then sometimes it's geographical to talk about these things, and you know, for Wall Street to know where we are and those investors. So I think it's a lot has to do with the investment community of getting the word out on what we're doing, and we're trying really hard with that, you know, of getting our message out. And again, I talking with the user advisory group hat on, but also, you know, for what Mary Lynn and I do, you know, having these large coalition of companies that aren't always traditional, you know, space providers, and the type of interaction they have with other businesses, you know, the blockchain, I've always been very fascinated with that, and how that may relate to it. So I think we're trying that effort, but there's 20 some of us on the 22 or 25 on the committee, and we try to spread ourselves out at many of these different type of events, just to kind of get the message out on how we want to engage and get more people and areas engaged with it.
Another thing that we've done, Chris, is that we're actually trying to emphasize also young people. So we've done a couple of events that have been related to university work. And then Admiral Ellis and I have done some work with the Space Generation Advisory Council. Eric's group is also very involved with them. We met with them at the International Astronautical Congress in Bremen last year and had extensive conversations, and that's a global, for those of you that aren't familiar with the SGAC, it's a global organization. It's affiliated with the UN, and it is made up of a wide variety of disciplines. So it's not always the traditional aeroastronautical or space science, young emerging professional. It's also emerging professionals that are in English, they're in history, they're in philosophy, these are people who are brought together by their interest in space. And so it's wonderful to interact with them. And they have got, frankly, networks that at our age, if I could comment on our age, Eric's the youngest one on the stage, but if I comment on our age, we didn't have, right? I mean, growing up, the ability to make the kinds of connections that are now available over social networking and a lot of other different means. So I have no idea what the size of their network is, but it's tremendous. And they have been very active. As a matter of fact, I just got pinged about last week from them saying, okay, we've got some white papers teed up, we want to get to you. And when they do white papers, they're collaborating across industries, they're collaborating across disciplines, they're collaborating across countries, okay, and want to get these white papers to us. And so we're really interested in having them. But basically, we're opportunistic. This is one of those things that, again, if people have ideas about how we can continue to do outreach, this is for the entire country. This is not just about the talking to ourselves inside the bubble, to your point. So thank you for the question.
No, that's great to hear. And it sounds like you're not just focusing on rockets and habitats, all the different technologies and requirements. So thank you.
Hi, good morning. Thanks again for trying to tackle these hard problems that are setting the future for space. And when you talk about, last week I was at a satellite and we were talking about 160 new launch vehicles coming on board from non-traditional space actors in emerging space countries. And when you think about standards or spectrum, are you guys coordinating with these types of like international and global groups? And if you ever wanted reach back, I would encourage you guys to reach out to AAA SmallSat TC for like spectrum, because this has been a problem that we've been talking about for a few years right now.
Regarding the spectrum issue, again, we're sponges on this one. We're taking it from every direction we can get because we know how critical of an issue it is. On the emergence of the tremendous emergence of these small launch community, standards have come up a little bit in the discussion, but it's more focused on what we're doing as individual organizations. And I know there are several different organizations that are trying to standardize, and create and establish standards. And we personally have been working with a standards writing organization. But it's a challenge, the number, I guess, did you just say 160?
That was the number I was
the last I was on, it was like 114. I'm tracking about 12 or 15 of them that are really bending metal, but it's growing every day. The amount of launch companies that are coming out there. So it is exciting, but and that also touches on the national security issue, and which Admiral Ellis heads up, and the questions that they have, because this is a driver of economic growth and the creation of this enormous smallsat industry, but there also comes threats with that, and I think from both perspectives we have to look at that. That's a great question, though.
Dave, do you have thoughts on that? They've founded, which should be noted, the first commercial launch company. So do you have thoughts about just reaching out to that broader community?
Where do you start?
Stump.
No particular ones, no.
Okay. Thank you.
Hi, thank you first of all for such a great multi-stakeholder panel and collaboration. I'm Tatiana Indina with Mission to Mars Academy. We are a Silicon Valley-based accelerator, and we work with universities, national accelerators, and entrepreneurs in different countries, facilitate international collaboration between startups. So my question is, how can this global community of entrepreneurs be engaged in National Space Council? How can they participate and potentially contribute to this Moon 2024 mission or Mars 2024 33. What are the particular avenues, how they can be engaged and submit their projects and initiatives, and how they can get some support? Because speaking of investors in Silicon Valley, what we see is that the story with traditional investors today, that they tend to invest in a project with immediate business monetization, while many space-related initiatives are longer-term, more social impact, almost non-profit projects that do not really fall in this category of traditional startup investment. That's why we feel it will be really great for those projects to receive support from governmental organizations. And so what are the particular ways to collaborate with this community?
Well, I would first point out that of the 24 or so members of the Users Advisory Council, 4 or 5 are either current or in the past have been space entrepreneurs. So the viewpoint from a new venture standpoint is pretty well represented on our group. As Mary Lynn said, we are eager to hear the best ideas from all sources for how we can advance our country's aspirations in space, and certainly from the entrepreneurial sector, we're very eager to understand what the views are with respect to new markets and new technologies that are evolving there. But you're right, fundamentally, whether it's space or something completely unrelated, you've got to take into account, just like we have to deal with the laws of physics, we also have to deal with the principles of economics and the necessity to have projects that are going to return at least the cost of their capital over their lifetime. And that makes things that are more than a decade in the future pretty tough sells. So I would suggest looking at the examples of some other new ventures that have comparable timescales. For instance, commercial nuclear power comes to mind as a pretty capital-intensive, relatively long-term investment area that is attracting a fair amount of private capital. A lot of that, though, is coming not so much from traditional venture investors as from individuals that have done well in other fields and are now setting aside a certain fraction of their personal wealth to these longer-term projects. So I think that's likely to be where, at this stage of the game, you're most you have the best chance of finding early-stage capital for projects that span multiple decades.
And just to add on that, we've seen a lot of, as I mentioned, the Silicon Valley models, and as Dave highlighted really well, a lot of these are investors that have made well in other industries. Mr. Bezos comes to mind, who's putting his money in his own company. But there's several angel investors out there that we see, and I work with the Space Angels Network, just as an example, and some of their investors are really serial investors with the knowledge that they probably won't get a return on the investment, but it's the satisfaction that they have of investing in some of these startup companies and giving that boost. And sometimes when you go out and you meet with these entrepreneurs, it's their 3rd or 4th startup company. And I always just assumed that the first 3 or 4 were all successes and they moved on, but probably they weren't, but they're keeping at it, and they have an investment line that comes in. And again, I know one person who's invested in over 45 companies, not in the billionaire range, but he's made a good fortune and he continues to invest in it because he sees the upside to that. So, and I'd also add from an international perspective, keep your eyes open, in October here in Washington as the IAC comes to town, because I think you're going to see with the the whole hoopla of the 50th anniversary of Apollo and to the moon missions, I think you're going to see a wider aperture of the engagement with the international community. So I think that's
Thank you so much. I know NASA has a small grants program for businesses entrepreneurs that was mentioned here. If you could point us to some other sources of governmental support for startup initiatives in space, so that would be great.
Okay.
Yeah. Thank you.
Jeff?
Hey.
No comment.
All right, no comment.
At the User Advisory Group meeting last month at Space Symposium, there was some discussion about the group playing a role in reviewing NASA's exploration plans, serving as sort of like a red team or something. Has there been any evolution in how that would work in terms of evaluating the technology and the budgets and so on, and how that would avoid duplication of, say, what the NAC would do for that review?
That was Les's plan.
Yeah, I can talk a little bit about it. So the discussion about defining, first of all, what happened. The Space Symposium discussion was about really putting together what we call a term of reference, a TOR, which is essentially a work statement, basically. And you reported accurately, actually I read carefully, that the discussion, thank you, that the discussion was actually about proposing that this TOR be written as opposed to proposing the red team be done, right? Which was, so the TOR has been written, and the way that it is being defined right now is to put together subject matter experts who exist inside the UAG, and there are several, as you know. There's some sitting right here on the stage. We also have astronauts who have been involved in the program for a long time, and then others who have a great deal of expertise. And to put together that group and then essentially ask NASA to come in and present what the planning is. As you also know, the planning has gone through a bit of a change since that Space Symposium meeting, given the decision to attempt to accelerate everything until 2024. So I can't speak for Les Lyles, General Lyles, who's chairing that subcommittee, but I would imagine that we're prepared to give NASA a bit of time to catch up with itself with regard to all this planning activity that's been going at just a frantic pace inside the agency right now before we do it. But that's where we are at the moment. Anyone else? Well, listen, I want to thank you again for your questions and for your interest, and I also want to thank the panelists that were I'm so grateful that you were able to come here and represent and help discuss this. So thank you.
It just keeps getting better and better. Thank you guys so very much for all you're doing for space exploration. As we say goodbye to you guys, we begin to welcome on someone else coming to the stage. And I think that we've heard a little bit about him before, but I want to read you something that I just think is quite remarkable. This gentleman I'm about to introduce is Ari Tro. He said, like Tro, your boat. So Ari Tro, he is with the XYO Network. And my first question to him is, so you're the guy that's going to help me send a text message from Mars in less than 30 minutes. So he said he's working on it. But one of the things that he is like a serial entrepreneur, and I think maybe my favorite fact about him is that he was very interested in computers, found the Atari computer system, learned how to do all of the programming, started a business at 13, some kind of printing business, and so I think he's been starting up companies ever since then. So please make welcome Ari Tro and listen to all of the innovation in Bitcoin and fabulous things he has in store to help us get to Mars. Come on out here, Ari.
Thank you very much. First of all, thank you very much to Humans to Mars for having me here. I'm a little bit of a strange guest, I suppose, from the fact that no conference or summit is complete nowadays until somebody stands up on stage and says the word blockchain, because it's this buzzword that everyone must be hearing about. And so I'm that guy today. I'm the guy who's going to talk about blockchain and and talk about buzzwords, basically. But the big question, of course, you guys have is, well, how does it apply to space or to the moon or to Mars or any of these things? And I'll get to that, but the thing I want to talk about first is like, what part of blockchain really fascinates me. And most people, when they think about blockchain, they think about crypto, which is going to be like Bitcoin or cryptocurrency and those sorts of things. And that's obviously a big part of it. And then there's also governance. You know, some people talk about making nations or citizenship or voting with blockchain, and there's a lot of uses for those. So those are actually two things you could have in space as well, and people have talked about that and proposed that. So, well, how do you actually, in space, do those sorts of things? Like, how do you have a citizen of the moon or a citizen of Mars? How do you have currency on those? And you can actually use blockchain for those. But the thing which really fascinates me is data. And so I'm a self-proclaimed dataist. And so I tend to be very much about generating, sharing, and securing data, really, is what it comes down to, and making sure I know where the data came from or what the data's provenance and value is. And also, the value which I place on data is very high. Like, for example, I used to, she mentioned, have an Atari computer, and I love old video games and that sort of a thing. So to me, the value of an old disk that has this almost a little piece of art, because somebody out there made this piece of data that's unique. And if you lose it, it kind of goes away forever. And so the way I look at the world, and I kind of started my current company in 2012 thinking about this, is the whole world just all it is a bunch of different data sets that intersect with each other. And they're these Venn diagrams, and it's data set theory, basically. So if you can actually capture all this data and view all this data, you can actually get this complete view of what actually is reality and the world. But it's kind of in a different lens. So if you go and ask different people, each person has like this view in their mind of what the world is and what they view as a world. That's why you have differences of opinions. Somebody cuts you off in traffic, it's probably because they freaked out because they wanted to get to the off-ramp, right? In their reality, they were doing the right thing. In my reality, I was doing the right thing. This kind of conflicted. So you have these different perspectives. And so when we started my company, we're making IoT devices. And the idea of these IoT devices was to be able to collect data with sensors and to be able to see the world. But we ran into a pretty major problem. And that problem is, how do you actually share this data? And if you have one system, it's pretty easy. So if I was Apple and I have all these devices that are all Apple devices, I can share all my data pretty easily with myself because I trust myself. And so you end up with these silos of data, but they call them data swamps nowadays. And the data swamps are pretty much 99% of data goes unused or goes wasted because there's no way for other parties to be able to see the data. So for example, on the first trip to Mars, this is not going to be a big problem because I'm pretty sure everyone in this room is pretty trustworthy, and I even leave my backpack in my chair here because I don't think anyone's going to be stealing my backpack. And you guys are pretty sure you're not going to get to Mars and there's going to be somebody out there who's going to be providing data that is nefarious or error-prone on purpose because there's actually no one there. You're the only party. So there's no concern about data security or data vulnerabilities from that standpoint at this point in time. But it will get there, right? Well, someday we'll have a lot of different people on Mars, a lot of different people on the moon, but we're already getting there in space. If you look at satellites, and there's like this cone of innovation that we get, and it's getting faster and faster. And so that's really where I'm kind of fascinated with this whole data thing. So how many people here are familiar with blockchain or have heard blockchain before or understand how it works? Okay, well, I'll explain it a little bit for some people who don't know about it. All blockchain really is you take data and you use cryptography to be able to sign it and put it into a chain so you know the sequence of data that happens. So for example, if I'm recording someone's heart rate or any sort of sensor data, I can see this series of events that went in there. And then later on, if one of them's removed or one of them's changed, it's very evident because the hash will break. The hash will no longer be true of the data that I had collected before. And if I were to remove one of the blocks, then the hashes that are inside these blocks won't match anymore. So I'll know data has been either removed or has been changed. So it's a very self-evident thing. And the biggest use for this is for systems that are decentralized. So if you have parties that don't trust each other, so trustless data sharing is really where XYO, my company, is focused. And so the O in XYO, by the way, stands for Oracle. And so the idea of an Oracle is it can view the world. It gives you an answer about reality. So what we do is we make sensors, and we collect data from sensors. You can even get sensors on your phones. We have an app on our phone. Collect those sensors, and you can share them. But all these sharing things that go on peer-to-peer we sign these, and each of our devices has its own little blockchain. It's not a decentralized ledger, it's just its own little memory. So you can think of it as the memory a person would have in their brain, because each person has these sets of memories, and then when we talk to people, we actually can communicate those, and we have shared memories. So the best analogy I've used for this is if I were to go around and every single person I run into, I'm forced to take a selfie with them and have them sign it and I sign it, and we each take a copy of the selfie. And each person goes and puts this in a photo album in order, and you have to do this. And if the photo albums change, everyone knows. So if you have all these and you combine them all into one big picture, you actually have a very accurate representation of reality, of the world, because for any one party to go out there and actually change a data point becomes evident that they've changed it, and so it's been altered or it's been changed from the past. So without a central authority, you can actually have a very, very stable and a very, very accurate data set. So the use for this is almost always in a case where there's multiple parties and things grow. And as we're seeing, like SpaceX, for example, and NASA, they're working on cost reduction for a lot of these different things. And the IoT world on Earth is already there, where we have billions of devices from different manufacturers that can't really talk, but how do you actually share data between them without having to worry about where they came from? So that's what you use something like this for, because you have these untrusted data sources, but I want to trust that a sensor reading came from one device and I can actually use that data. An example of that, I think I have it here somewhere, is that a car, for example, if you have an autonomous vehicle or a swarm of vehicles, a car can drive itself a lot better if it can actually get data from the other cars around it. But how do I know that someone's not feeding me bad data? So I'm sure you guys also that Tesla accident where they brushed the side of the freeway on the little bumper there. The reason for it is because it was using its own sensors and its own video to be able to see where the freeway's edge was, and it didn't notice it until it was too late. But if it could get data, metadata or actual data from the car in front of it or the other cars around it, or for that reason, cameras that are on the traffic signs, and trust that data, it could have seen that all the rest of the cars are kind of swerving a little bit before they get there, and it would have known way ahead of time that that actually happened. But normally you can't do that because of privacy concerns or just because, why would Tesla trust BMW data or vice versa? So in a situation like this, if you have this data and you can always know where it came from, and it gets handed around, I can actually take a piece of data from that car and say, hey, I know this came from a Tesla or from a BMW, it was signed, and then now I pass it to the next car. So I can take the data from 3 or 4 cars ahead of me and keep on passing it down, and nobody has to go and actually ask a server, is this data valid? Because they can use math. They can use cryptography to say, is this signature valid? Does it actually link up with the rest of the blockchain? So you can share that data there. But the need for this is because you have a whole bunch of autonomous vehicles and autonomous devices trying to work together, but needing to share data that's separate. And you see this problem right now in smart homes. I don't know if any of you guys have smart homes at home, or connected homes, as I actually call them. Do they actually talk to each other? Does your Alexa and your Apple and your Google Home all communicate very well? Probably not, right? So if they could actually do a lot more together there. So one of the things we do also is the AI portion of it. And so at the edge devices, we take data like video and we boil it down to metadata. And this is the topography of our network out there. So the Sentinels are what's on these edge devices, and they go and they collect the different data. They boil it down to metadata if they have to. And then the bridges send it to our archivists, and the archivists store it, and the diviners answer the questions. So that's a pretty straightforward, basic architecture view of the network, but it's all decentralized, so nobody has to actually go and trust each other. So it helps with GPS, for example. So one of the problems with GPS is I can go and set up broadcasters, and I can broadcast fake GPS signals, and then jam people, or they can, I can affect where they go to, but there's no way to know if that GPS signal is valid or not. So in our system, we tie a piece of data to a very specific place and time in the universe. That's what we call our company XY, but it's really an XYZT exercise, and it's all relative data. The reason why we use relative data is that you can only mathematically prove the existence of relative data. I can prove that I'm in this room right now with you guys, but I can't prove that I'm in Washington, D.C. However, like in a normal mathematical proof, if I were to say, I'm in Washington, D.C., I'm going to assert that I'm in Washington, D.C., it's an axiom to me, then I can say, in my reality, since you guys are all within a certain proximity of me, you must be in Washington, D.C. as well. So you can actually mathematically get certain answers from relative data points, but you can't get any absolute answers. So many of the use cases, as we have on here, there's logistics, there's e-commerce, smart cities, autonomous vehicles and devices. They all can benefit from this cross sharing of the data that's out there. And then you basically have a public view of all this data. And that's kind of the dataism side of me, where I personally believe that transparency and more data is actually a better way to communicate with each other as opposed to privacy and secretiveness, because that way we know what's going on around us. And there's kind of a cultural shift, and I think right now we see it kind of going the opposite direction. So in space, for example, one of the things that's happening, we have more and more satellites that's out there, and they're from different countries and different organizations out there. So being able to actually use relative data in space, to be able to have them know where they are relative to each other, and the ability for them to communicate is something which can definitely be done with a protocol like this in a decentralized way. And the thing which is nice about it being decentralized is there's no, well, this is my system, I want everyone else to use it. No one's actually controlling a system. It's just a protocol that people agree on, and it is completely unmanaged, for lack of a better term. So there's very little contention on who controls it. So that's why I think Russia right now they have their own GPS system, the US has their own GPS system, and China has their own GPS system, because they all want to control their own GPS system because they don't trust each other. So if you can have a system where trust is not required, it's completely trustless, it makes it way easier to collaborate. So on Earth right now, we're building this thing out with all the different IoT devices that's out there to have the system work and have topography. We have about 1 million devices that we've generated to date. We have a whole bunch of people using our apps. So we have a live system that's collecting all this data. People share it. They share it voluntarily because they're either dataists or they also get some tokens from our system to be able to do it. And this model is something which will scale perfectly to any of the rest of the levels as that need arrives. So as satellites need this communication because there's more and more of them, and as the moon would need them, for example, we would want to have those there as well. My personal belief is that the pace of use is always nonlinear compared to the cost. So I think the rule of thumb is every time you half the cost of something, you go up an order of magnitude of demand for that device. So every time you half the cost of satellite launches, for example, you're going to have 10x use of satellites. So for us to get to hundreds of thousands or millions of satellites and these low microsatellites is going to be something which happens really soon. And once the cost of the moon goes lower and lower and lower, you're going to have hotels there, and you're going to have all these different things. So having collaborative protocols for data that goes on there, I think is something which is very important for any of these really fast-growing, fast-moving environments that specifically don't have very good definition over who governs those rules. Because I think it's one of the problems in space in general is there's no governing body that can force anybody to actually follow the rules. So having an agreed upon protocol, I think, is a good value there. The proof of concept is basically our ground-based system, and then we also are looking at using satellites to link the different systems together. So being able to use satellites to be a calibration point for our system on Earth is something which is very valuable, but then once you have that, you can also link the data from Earth to the data on the satellites and that sort of thing. So you can actually have links between the different strata of the different systems that are out there. So that's pretty much the overview of how we view data collaboration and trustless data sharing in the current terrestrial Earth view of IoT devices, and how that goes to the level of satellites and then further out as that need grows. But in the short term, once you only have one party going out there, it's not necessarily required soon for Mars. Obviously, I would love for us to have 100 different participants all having some sort of presence on Mars in 10 years, but I'm not sure that's going to happen that soon. Well, thank you very much.
You all have questions? Anybody want to ask a question? Yeah.
As a Silicon Valley person, hi, I want to say I really like your company. As a policy person in my past, I can say, I want to ask you this question. how do you envision all those governments with competitive policies that everybody wants to lock things out? Like, remember what happened with internet, designed originally as a global good that is free of borders. What we see now is like this balkanization, that every government wants to link its data separately, China, Russia, United States. I understand that space is everybody's mission, but don't you think this is what exactly can happen in the future? That like we will, because it is competitive, it's because it is a space race, that there will be policy difficulties and jurisdictional and country difficulties to share this data. So how do you suggest to overcome this policy kind of confrontation?
Well, I think it has some of the same difficulties that the internet has, but the internet has the concern where it's still an authoritative-based system. You have to actually go to a name server to actually get data of where to go to for the IP resolution. And for example, one of the easy ways for governments to block the internet is to just not resolve certain names, or not allow certain names to be resolved, or their name registration services could ban people from registering names and so on and so forth. You can use firewalls from people to actually get there. The thing which is nice about a system like this is that it's all peer-to-peer. So for example, people can opt out. I'm sure there's countries in the world, I think China's talked about this, of saying, well, let's ban this cryptocurrency or blockchain or whatever it is. And so they can outlaw it, but to actually make it technically really challenging for a person not to be able to communicate with the network is really difficult, because the network is not centralized at all. So there's no name resolution, there's no way to block that. Obviously you can cut off all the different wires from it, so if you can isolate it, you can do that, but I would think most concerns out there would want to not opt out of the system from the standpoint that all you're doing is isolating yourself. It's a very isolationist approach, and it's really difficult. Like, for example, if we were to pass a law right now that Bitcoin's legal in the US, to actually enforce that law would be very, very problematic, where I think outlawing certain websites is a lot easier from a technical and practical standpoint. So I think blockchain and cryptography, because it's a self-evident and self-supporting system without the need of servers and authority to actually make it work, is a lot more robust solution for regulation resistance, should I say.
And you, my dear?
Yep. In relation to the Internet of Things, you've mentioned a lot of capabilities that blockchain has to bring to the scene, and I was just curious, since some of those capabilities are talking about being enabled by 5G, what the introduction of 5G, how it further enables what you can do, or whether it attracts or detracts from what you're doing.
Well, I think that's a great question. 5G is coming very fast, and it definitely does not detract from what we're doing. I think 5G is going to be making everything even better, and it's going to be faster. The biggest value or I guess the biggest cost and benefit of 5G is you have more data. And one of the biggest problems in general is our data volume that we have that's growing, and we have this out of control system. People have these 40 megabit pixels on their phones, and they're taking 20 pictures a day. And so our data storage needs as a society, and that growth is something which is getting a little more and more out of control. And 5G is actually going to make it worse. People are going to be having 4K videos that they're storing and they're doing. So one of the ways that we work around that in our system is we make metadata out of it. So we have these diviners, and what it'll do is it'll take the data at your edge device, and it'll look at that, and you can distill it either by compressing it and making a lower version of the video, or you can actually look at that and say, well, there's a person in there, or you can get the location from it, and you can actually store the metadata without actually storing all the video if you want to. So there's different ways to distill that data down to more compressed versions. But there's also like IPFS, for example, which is a great solution for blockchain. And the idea of IPFS, and I love the name, by the way, it's Interplanetary File System, so it's very apropos for discussions like Mars and that sort of thing. But the idea of IPFS is any data set. Like if I have a video and I share a video with somebody else, it would hash to the same number that's out there. So it's a lot easier for us to take one piece of content that might be shared 1 million times, and instead of having 1 million copies of it, we can have 1 or 2 or 3 copies of it somewhere in a cache, and everybody can just refer to this hash of it. So you actually reduce the amount of digital waste, for lack of a better term, in many, many ways. So I think that's one of the ways that cryptography and blockchain actually is very eco-friendly from the standpoint that it reduces that digital waste. Bitcoin itself is very un-eco-friendly because you have to do proof of work to do that. But I think like 5G and creating more data, having more sensors, having phones that can see more things is really where a lot of the expansion is going to go. The ability to see through walls, for example, is going to be something which, we're going to have to deal with some of these privacy concerns eventually, but sensors that are almost like Star Trek level sensors where we'll be able to have a view of the entire world almost in real time because of this mesh of all these different sensors we have, that's what 5G is going to make available to us. And it's going to cause some interesting social questions, like how much data transparency is enough, and what do we do in the case where we have a data transparency, and how do we potentially socially evolve as humans to deal with the lack of privacy and the fact that that's going to be changing for us. Thanks.
What are some of the key technologies that you still need to see come online to make this really viable in a space context?
Well, I think that one of the biggest challenges for any of these technologies is latency. So like Mars is 30 minutes away for communication. So the way our system works is the selfie analogy is I have to actually go and I get a copy of the payload, I sign it, I give you the copy of the payload with my hash, and then you sign it, and we kind of go back and forth 4 or 5 times. So in theory, a bound witness transaction in our system with somebody on Mars from here would take 2 hours or 3 hours perhaps, which is very impractical. But the thing which is kind of nice about it is you can do a whole bunch of bound witness transactions on Mars, and then just once in a while, once in a day, say for example, you go and link it to Earth or you link it to the Moon, and that way you still have a system which is contiguous because you have that bridge between the 2 different data sets. So it still becomes one contiguous data set. But being able to have systems, especially in long-range systems in space, which reduce latency, and I'm, from a physics standpoint, I'm not a physicist, but from a physics standpoint, my understanding is there's only so much we can do as far as actually getting that faster. So getting the data transport layers as good as possible and as fast as possible and energy efficient as possible also, because one of the things I've heard from a lot of these panels since I've been here is always, battery, how do you get electricity, can you use solar panels, can you use nuclear reactors? So power consumption for satellites and for space devices in general is always going to be a problem, just like it is for us. Like, we make this little device. Like, I have a pocket here somewhere, but we make a little device that's more powerful than my Apple II computer or my Atari computer from when I was a kid, and it costs only a few dollars to make, and has a battery in there, and this battery will last 5 years. Well, depending on how much you use, it can last between 6 months and 5 years. But it's a little itty-bitty device like this and costs a few dollars. So the efficiency has gone really, really, really high. And so, but this is only Bluetooth, so it only broadcasts a few hundred meters at most. Now, if we want to make something like this that we can throw out into space, that's going to last 5 years, but be able to actually communicate far enough with each other, those battery efficient or those power efficient transport layers, I think, is one of the biggest challenges.
Thank you.
Please, let's give Ari Tro another big round of applause. I feel like I'm looking at a genius. It's like, I love this conversation. So next up, we have another brilliant panel before we head into our lunch hour. Moderating for this next session is Rebecca Kaiser. She is an experienced associate deputy administrator. She has a history of working in aerospace, science, policy, and international relations. She's very skilled at strong, strategic, professionally garnered partnerships. This crosses both the private and government sectors. She's been involved in international negotiations, procurement, intelligence analysis, you name it, I believe she may just do it. So please welcome Rebecca and her entire team to our panel today. Come on in.
Take a leg. We'll do that. We'll do it that way.
This is perfect.
Good morning/afternoon, everyone, and thank you so much for coming. I am Rebecca Kaiser, and it's an absolute pleasure to see you all today, and we have a wonderful panel. This topic of international collaboration and space exploration is very timely indeed, and my boss, the director of the National Science Foundation, is actually testifying on the Hill right now about the Event Horizon Telescope finding the picture of the black hole, which was an exemplary example if I can say that, of international collaboration with amazing contributions from Japan, Taiwan, Europe, and really across the globe. We can't really do space exploration these days without international collaboration, so I look forward to our conversation. We're going to start with some introductory comments from each of our panelists about their role in international collaboration and deep space exploration and how they actually work on this topic. So let me start here with Ryan Whitley, the Director of Civil Space at the National Space Council. If you can give us some of your thoughts about how you work on this topic of international collaboration and deep space exploration.
Thanks, Rebecca. Really appreciate it. So at the Space Council, we deal with all things in all space domains for the White House. And so, as I think many of you know, space exploration, deep space exploration is an important topic for the White House. The big first space policy directive that came out of the Space Council was about exploration. And I'll just read it real quick because I think it really sums up what we're looking for partnership is lead an innovative and sustainable program of exploration with commercial and international partners to enable human expansion across the solar system and to bring back to Earth new knowledge and opportunities. Beginning with missions beyond low Earth orbit, the United States will lead the return of humans to the moon for long-term exploration and utilization, followed by human missions to Mars and other destinations. So some key words there, moon and Mars, beyond LEO, international and commercial partners. So clearly, this is the White House directive to say, this is part of the plan, this is what we want to see. So now it's about implementing that. And so that's kind of what the next steps are, is figuring out what does that mean for exploration, both robotic and human. And so I think many of you know that just a few weeks ago, almost about 2 months ago, we had a charge from the Vice President to expound on this and set some urgency for getting back to the lunar surface in 5 years. And so the question may be, what does that mean for our partnerships? And I guess the way I'd sum that up is it means that we need to have that same sense of urgency around building those partnerships around these shared visions. And fortunately, the moon is a shared vision. I mean, Mars is too, but as the largest spacefaring nation, the means to get to Mars is more within the US sphere than it is in these other nations. And so they understand the importance of involving the moon on that path. And so, if we focus on those partnerships, include both our current ISS partners that are really strong in our both moon and Mars planning, extending that forward, and also looking at new partners. There's developing nations like India, Brazil, South Korea, UAE. We want to involve them as well. So we're going to we have conversations, and the White House works to meet and discuss these opportunities. And LEO is not gone, right? We were talking about deep space in this panel, but LEO is still important. And so as we transition from ISS to future other platforms, that's important too. We want to have partnerships in LEO. So the future, just real quickly, about where we want to focus our partnerships is going to be around this vision that the Vice President outlined is around the moon. And so that's two spheres, the Lunar Gateway, which we've already identified some of those opportunities already, which are great. We want to build on those. And then also on the lunar surface. So we want to have one day being side by side with our allies on the surface of the moon. That is the dream, that is the goal. So how we work towards that is the work before us. So thanks.
Masami Onoda is Director of the Washington, D.C. office of the Japan Aerospace Exploration Agency, JAXA. And Masami-san, can you talk to us a little bit about your role in international collaboration and deep space exploration?
Certainly. Thanks, Rebecca. So let me start with a little bit of history. On July 31st, 1969, that is exactly the year and just weeks after the Apollo 11 moon landing. The Japanese and US governments signed an exchange of notes on space cooperation, and so that led to the establishment of JAXA, then called the National Space Development Agency of Japan, which was established on October 1st, 1969. And so US-Japan civil space cooperation today covers a wide range of activities. And also we've built very close cooperation with agencies, space agencies in countries worldwide, Europe and elsewhere in the world, and Asia. And we are really excited to be part of the deep space exploration efforts, of course. My role in Washington, D.C. as the JAXA representative is to, of course, represent JAXA and in some parts the Japanese ministries as a whole, as we are the central Japanese space agency. And we do interact a lot with all of the colleagues here, with the White House and State Department and the AIA, the industry, daily. So that's what we do, and we closely, of course, follow the US policy, and we do try to align with that and be part of the international deep exploration policy and programs, because no country alone can do this. So, and the Japan-US space cooperation, as you all know, is supported from the top level of both countries. Last year in November, Vice President Pence met with our Prime Minister. They talked about space, and this was a press release to strengthen comprehensive space cooperation, including security, industry, and science and technology. And so this had been the basis for, supported the revision of our roadmap of our basic plan for space policy to newly include activities on international space exploration. And the Prime Minister also, Abe, also instructed to advance international coordination so that Japan can make a contribution with its technology to participate in the Lunar Gateway. And this year, as you all might know or might not know, we have the Japanese era. And this May 1st, we entered into a new era with the enthronement of our new emperor. It's moved from Heisei formally to Reiwa now. So this is really positive in Japan. And we are also, with this new era starting, we are expecting the President of the United States to be visiting us in a few weeks. This is all very exciting and very positive. And along those lines, I think space exploration is the most positive topic that we have in between both countries to discuss. Also, which would, in other aspects, support national security and the stable situation, international situation in the region in broad terms. So this is very important as well as positive for us, and we very much look forward to this, and we would like to expand further our cooperation, not just with the US, but with all international partners. Thanks.
Thank you, Masami-san. Chris Cannizzaro is from the Office of Space and Advanced Technology at the U.S. Department of State. So when we think of international relations, we think of the Department of State. And I was wondering if you could talk a little bit about how you do this regarding deep space exploration.
Sure. Thank you, Rebecca. And obviously, I'm not Dave Turner. Dave got called away for some international negotiations in Europe. So I'm actually a former engineer working at the State Department. I'm our lead for space exploration applications and technology in the office. As space is an international domain, of course. We play an important role in strengthening the U.S. leadership in space by advancing our U.S. national policies and programs through international engagement and encouraging the use of U.S. space capability systems and mutually beneficial cooperation. Our office, we have primary responsibility for U.S. representation to the United Nations Committee on Peaceful Uses of Outer Space, or COPUOS. I think many of the people here are familiar with COPUOS. Established in 1959, it developed the Outer Space Treaties and the three related conventions. and which are generally considered to be the bedrock of the international space governance framework. Our office also organizes and or leads a number of government-to-government, let's say whole-of-government space policy dialogues with all of the leading spacefaring nations. We look forward to hosting Japan for what will be our 6th comprehensive dialogue in July. We also have dialogues with India, Europe through the European Commission, and even with China, focused on spaceflight safety and long-term sustainability issues. We've also recently been engaging with a number of the emerging spacefaring countries. So, for example, a few months ago, we hosted our first dialogue with Indonesia. I think State Department is a member of the Space Council, or Secretary of State, and we are actively advancing each of the President's space policy directives, certainly the international components, and perhaps I'll stop there. Maybe we'll get into those a little bit later.
Thank you, Chris. And Dak Hardwick, Assistant Vice President for International and Acting Vice President for Space for the Aerospace Industries Association, AIA. Can you talk also about how AIA plays in this, especially representing private industry?
So Rebecca, thank you, and obviously a pleasure to be here today. The Aerospace Industries Association represents nearly 340 members of the aerospace and defense sector here in the United States. We've been one of the leading advocates for not only greater civil space funding, but space funding across the board in order to realize a vision that we put out this year. So this year we're celebrating our 100th anniversary, and we put out a document called Vision 2050. And it really is one of these defining documents that looks forward 30 years about what technologies are going to change our way of life. And I can tell you, of the Vision 2050 document, the research that went into that, almost every single one of those technologies that is going to change our way of life is somehow either space-based or space-enabled. And when you start to think about that, you really understand how important just the general funding is. And so as an association, we continue to be very supportive of a lot of the investment you see both on the public side and on the private side. Specifically, representing the industry is very interesting because the pathway to Mars actually runs through the industry. And the great example that I will use here is many of us attended the Apollo 11 film premiere that was on Tuesday evening with the Vice President. And there's a scene in the movie that shows all of the companies that were supporting Apollo 11, and it's the engineers, and they have their white lab coats on, and you see the logos of those companies on the backs of those engineers, and it's Grumman Aircraft Corporation, which is part of Northrop Grumman now, and it's Rockwell, and it's just and all of those engineers and all of those contractors literally built the machines that took us to the moon, and that is going to happen again. So the contractors and the engineers that are bending metal, that are going through all of the just engineering challenges, all of that is going to be done by industry. There are many examples of how internationally we did that as part of Apollo 11 or as part of the Apollo mission, but ultimately for the international portion going forward to get back to the moon and get to Mars, there's going to be an increased international aspect to that. So, AIA is able to speak frankly to the supply chain that is required to get back to the moon. So it's not just your large integrators. It's not just the companies that you know that are on the side. It is parts and components that are made by suppliers in counties and cities in this country that you don't even know exist. And they are part of the space industrial base, and they are feeding those parts and components in. It is entrepreneurial. It is breaking through technology in a way that we haven't seen in the past. And the industry, AIA, is very happy to represent the entire range of that supply chain, from the largest integrators to the smallest suppliers. In terms of international space collaboration on the industry side, frankly, it's in our DNA. It really is. The best example here is, if there are any Canadians in the room, you will appreciate the fact that the LEM lander legs were built in Canada. You will appreciate that the telemetry and the data that was used to pull the Christmas Eve message for Apollo 8 was channeled through relay stations in Australia. And those are just some basic examples of at least international collaboration we did for Apollo. I can tell you going forward that we are the only way to get back to the moon and the only way to get to Mars is through international collaboration. And I'll leave you with this. For those of us that watch the Mars series on Nat Geo, or you read any Andy Weir novels, how many of them indicate that only the United States will be the country that will go to Mars? And the answer is none of them. It's almost assumed that in order to get to Mars, we will have international collaboration. I think that's right. And on the industry side, because we have a global supply chain that supports our aviation sector, that same global supply chain is going to support our space sector as we get from the moon to the moon and back to Mars. So I'll stop there.
Thank you. Excellent point about the whole ecosystem and supply chain being global. And we think about formal collaborations, but it's another huge aspect of international connection.
So industrial partnerships obviously are important. The aerospace sector has traded tariff-free for almost 40 years. And we have seen tremendous international growth. It has allowed the U.S. economy to expand greatly in the aerospace sector. And frankly, it's seen international collaboration or international supply chain suppliers rise up through countries that are emerging and continue to emerge. And the U.S. aerospace and defense sector is frankly excited to take advantage of those supply chain and the technology that is existing in those countries.
Very nice. So let's talk about things that work well in international collaboration. Chris, can you talk about some examples of international collaboration in deep space exploration, some things that have worked well in this arena?
Well, sure. I mean, we have the obvious example of the International Space Station. We always point to the tremendous work that is, how well all of the partners work together on the space station, and the technologies as a proving ground for going beyond the low Earth orbit. And I think, of course, we have a number of great examples in the robotic space exploration sphere. And the one that I always look to is the Mars Science Laboratory with the Curiosity rover. I was just did a bit of research on that, and so all of those agreements, all of NASA's international agreements come through our office for processing and looking at. I see that there are 10 scientific payloads on the Mars Scientific Laboratory, and that over 400 international scientists working on there. And I know we have instruments from France and Germany on there, and several other countries. So that would be one example I would give.
That's excellent. And Masami-san, can you talk about some of JAXA's international collaborations or some other examples that you could point to?
Yes, ask the space agency to advertise. We have all these satellites. We are all, of course, very excited when Hayabusa 2 successfully touched down on the target asteroid, Ryugu. That was this February, and then it made its artificial crater on the asteroid in April. And Hayabusa 2 is a joint international mission. The mascot lander last October landed on Ryugu, jointly developed, and this was jointly developed by DLR and CNES. And this was released from Hayabusa 2 and made a successful landing on the asteroid. We will also cooperate with OSIRIS-REx mission of the US by exchanging the Ryugu samples with the Bennu samples that OSIRIS-REx will collect. And our science team also reported that Hayabusa 2 has detected small amounts of minerals containing water on the surface of the asteroid Ryugu. So we really look forward to its return to Earth in 2020. In October last year, Mercury Magnetospheric Orbiter MMO, which is nicknamed MEO, and Mercury Planetary Orbiter MPO were launched on Bepi-Colombo, a cooperation with ESA. And also, so this will take 7 years approximately to get to Mercury, and it will stay there, carry out observations for about a year. JAXA also planning the Mars Moon Sample Return, MMX, currently aiming for launch in 2024, which will also be a global collaborative mission in its development and operations and science. This May 1st at Goddard Space Flight Center, just close to here, JAXA joined the Goddard team for the selection event of CESAR, a comet exploration and sample return mission. We hope that this will be chosen for the NASA's New Frontiers program. Now, currently, we are in competition with Dragonfly, a mission to Saturn's moon Titan. So if this is all successful, we have this ambition that we will have samples coming back to Earth every 10 years. This is such a grand thing to go on. So first from an asteroid, and then from Mars, moon, and then from a comet. So this is what we envision for the next 30 years.
Thank you. Hayabusa is particularly resonant with me, as my NASA colleague Mark Allen and I signed the original Hayabusa agreement with Japan on the launch pad for Hayabusa 1. So we did it, which shows one potential challenge to international collaboration, and it's getting the formal agreements in place. And of course, we depend on Department of State to help us in that regard, and they do a very good job. But I was wondering, Dak, if you could talk about what you see as a few of the other challenges that we face regarding international collaboration in space.
Absolutely. And so not only do I come at this from the space side, I also come at it from the international trade side. And technology transfer and collaboration and technology going forward. And those of us that work on technology transfer understand that we have a gold standard regime here in the United States about the International Trafficking in Arms Regulations and the U.S. munitions list. And those of us that deal in export controls understand that in Category 4 and Category 15, dealing with launch and then human spaceflight, there are certain restrictions about technology transfer that under U.S. law we have to abide by. And I think the last administration and I think this administration are conscious of the need to continually evaluate and reevaluate the emergence of technology. The challenge will always be is that technology will always outpace regulation, always. And it's making sure that we have the right level of flexibility to change the way in which we apply that technology, especially when we're getting into partnerships with international partners. I like to tell this story just because I use it as an example of what not to do. So I was a space camp kid. So I went to space camp when I was in 7th grade, right? So I'm lucky enough to not only do I wanted to be an astronaut, right? And I figured out when I was very young that I did not do very well at math, so engineering probably wasn't my direction. But I got to go back to the Space and Rocket Center last year before. It's the first time I've been back in about 30 years. And met with the folks at Space Camp and had a very nice visit. Well, about 2 months after I was down there, one of the officials at Space Camp called me and they said, well, do you do export control? And I said, unfortunately, I do. And he said, we have some visitors coming in from another country. We have a display in the museum of some of the technology that was used to take us to the moon. And we are being told that we have to take the exhibit down because it displays technology that has not been transferred under US law. 50 years ago. And so the pace of technology and the regulatory environment has to keep up with each other. Again, I think in launch and in human spaceflight, we're making some good, but it continues to be a challenge. And it will always be a challenge. And so for those of us on the industry side, we will always ask our government the question. And because ultimately it is the international partners that are asking us the question. And we want to make sure that we get to the right answer as quickly as we can, because that is where the international collaboration starts.
So export control, Chris, of course, I have to turn to you. Do you have any thoughts on that topic or any other challenges we have to international collaboration?
So my office is not directly engaged in the State Department's export control. Well, we're indirectly involved, but not directly. But there is a lot of good work happening in that area by my colleagues and across the government and commerce and the Department of Defense under the SPD2. And we heard about some of that progress at the last Space Council meeting, and maybe Ryan will maybe talk a little bit more about that. I think another challenge with space exploration is the huge cost involved in getting the political buy-in for space exploration. NASA enjoys has broad authority in the U.S., but many of the international other space agencies or our partners don't enjoy such broad authority, and so to elevate space within their country does sometimes entail engaging with more senior officials within their government and getting that political buy-in. And one area where the State Department, together with Europe and Japan, tried to help in that regard was to create the International Space Exploration Forum, or ISEF. The Department of State hosted the first ISEF in 2014, ministerial level dialogue on space, bringing together not just the space agencies, but also the ministries, the Ministry of Science and foreign ministries. And we were very fortunate to have Japan pick up the mantle and host the second ISEF in 2018, and Europe has committed to host the third ISEF in 2020, 2021, and we think that's really important to have that political support when we're talking about billion-dollar investments over decades.
And Ryan, I know that Space Council has been working diligently on this issue of regulation and balancing the right around of regulation for space exploration. Do you want to talk about that or any other efforts that you're undertaking to improve collaboration and improve space exploration overall?
Sure. Yeah, Chris alluded to the last Space Council meeting, and we are working actively on the export control reform. And so that's an ongoing process. We had a list of recommendations, and we're moving forward on those. It's a big task before us. Dak's story was actually very applicable because there are ones that we need to fix, and there's others we need to maybe strengthen. So it's a balanced portfolio. We have to figure out what the right level is, but it's definitely a major focus of the council. I would say, since we're at a Humans to Mars Summit, talk about the human exploration side of this a little bit. That is, we've had wide success with the ISS, and it's been this great thing. We have something called an intergovernmental agreement that has shaped that. It's a very long document that kind of spells out the relationships between the different ISS partners. And the challenge, I think, before us for human exploration is identifying how that is useful going forward, how we bring in the Moon and Mars exploration into those spheres. You have different agreements with different nations and how those barter arrangements work out. We've started that with at the working level and the Lunar Gateway activity, and we want to expand that. We want to go beyond that. And like Chris mentioned, we're talking billions of dollars of investment. So it has to make sense for each nation and how they engage in that, how they identify which industries are going to serve those projects, and then how they fit together in a piece, because we now become dependent on each other. So this gets really complicated and potentially difficult as you work across the government spheres. So on a technical level, maybe it's pretty straightforward. You're like, yeah, I see that hole. We need that module. Yes, great, let's do it. And then you have to actually get the governments involved and make those agreements. In the end, it's entirely worth it. I mean, exploration together is worth the endeavor, but it's hard work. And it takes people who are willing to make those sacrifices to reach across the aisle and say, yes, come with us, and let's figure out how to do that. But I think going forward, it's how do you bring those other spheres of deep space exploration into focus and get those governments to invest in those industries, and noting that everyone has their government cycle. We have our cycles here in Congress and administrations. Europe has tons of countries to deal with and organize, and you can have even heard stories about how Japan works and how difficult it can be to get consensus on things. So every nation has their challenges to get together that consensus, and so I think those are the big challenges going forward for human exploration.
Ryan, where do you see, if you could paint for us kind of a vision of the future in space exploration and how international partnerships might play in that. What would that vision look like?
Yeah, I think in the long term, Mars is where we want to be. I think that what Dak illustrated about Hollywood and how we portray it. I mean, that's the reality, right? We are a global society. Now, we also have nations, and those nations have interests, and so every nation wants to do these great things, and so you're seeing that in our country today, this reinvigoration from the administration focused on space, and so there is, from the White House perspective, we want to lead the parade, right? So we want to be part of this parade where we all go out together, and so I think, like I said before about ISS transitioning to other arenas, we want to have those partners every step along the way. And so that's going to be around the moon. And that's the near-term thing, I think, for humans is around the moon. Now, robotic collaborations will continue indefinitely, and I think those are great. I mean, there's a number of new Mars ones. At the Mars Summit, so I'll highlight those. I mean, there's the ExoMars and then the InSight activities that are major partnerships across international circles. I think those can be springboarded into the larger Mars partnership. But in the end, for the humans, it's going to take those broader agreements and focus areas, and we have to really be careful and specific about where those collaborations occur, because as administrations change, as those things morph, we can maybe lose sight of that. So, but in general, I think the moon in the near term, Mars in the long term is where we're heading for exploration, never leaving LEO. So that's a big portfolio, and with limited budgets, that's the challenge.
Great. And Masami-san, how do you view international collaboration in the future?
In the future, so of course, as everybody says, going out to deep space, we cannot do this alone, and so international collaboration is probably a given. That said, it strikes me, so I arrived here last July, so it hasn't been a year yet. As we just talked, I get to experience the wonderful shutdown also. And so it strikes us really, and I didn't know, I knew it by knowledge, but I didn't feel it until I came here, how different the decision-making process is like if we take Japan and the US. And I'm sure Europe also has its own way of decision-making in all the individual countries. Imagine putting together 27 or 28 together. So each of us have so much difference. For instance, in the US, so you have this democracy, where you have to continuously individual different parts of the government or justice, they try to balance by correcting each other. That is how I understand it. And in Japan, though, ours is much more incremental. I hear a lot of that. So observation is Japan very, very incremental. We hate surprises. We love to plan, and so I think everyone in diplomacy at all would know this, and the U.S. of course continuously surprises us, and so
we surprise ourselves at times.
I know. So, but still, we have to work with each other, and we love to work with each other. Like when there was a shutdown, we had a problem on export control where so we have in fiscal year 2020, we have the plan to launch our new launch vehicle H3. And in H3, we will have these components that we have to import from the US, and we had to have this export control cleared by a certain timeline. And this, because of the shutdown, was delayed and we had serious problems. We could just immediately call up our friends in the government and see what's happening. And although it was, of course, shut down, the people tried to work with this as much as it could, and we did meet the deadline, so it did not impact our development. But this at every level, we need international, very close friendship and cooperation and communication. And to overcome this in the grander view in our moon landing and gateway, and then further on to Mars, we hope to understand each other and to put together this in a way that we can then put together our technology and to tackle this challenge together.
Excellent points, thank you. And Dak, from the private sector perspective, how do you see the future with international and space exploration?
So it's certainly very positive. Like I said, the pop culture references I think are a given for all of us. I want to go back to one thing that's one of the challenges that we haven't talked about, and it's something that is unique to the aerospace sector, but it's not unique to the United States. In that we are in a global race for the talent that will build the machines that take us to Mars. And let me use an example, not to disparage a large company which is a cell phone provider or a telecommunications company. But during the NCAA basketball tournament, I was watching the game, and there was a commercial that came on, and the first image on the commercial was Buzz Aldrin standing on the moon. And I thought to myself, wow, this is going to be an amazing commercial for one of the AIA member companies, or one of the partners, the international partners that we work with, or whatnot, about going to the moon and going back to Mars. And the commercial went like this: in this world, we can do anything we want. We stood on the moon, and this is why you should buy Verizon. So I use it as an example because our friends in Silicon Valley, who are pushing the edge on technology, have cornered the market on the concept that that is the only place to go if you want to change the world. And we change the world in the aerospace sector. We not only change it, we also go visit other worlds. And we are in a race for that talent. And it doesn't start at the post-secondary education level. It starts at pre-K. It starts at K through 12, and it continues on through college. The conversation that we talk about workforce is, if we don't have those students by the time they go to college, they're lost. We have already lost them because they don't have the fundamental skills to be able to be the next engineer, to be the best technicians. And it's not just engineers. We need skilled tradespeople that understand how metal and electricity flows through, that are just experts in those areas. We had that 50 years ago, and we've lost some of that trade skill. We need to bring that back. Getting back to your question about, from the industry side on international collaboration, one of the things that I think is fascinating, at least we see on the defense side, is that many countries like to specialize in certain types of things within the supply chain. Some of them are wing manufacturers. Some of them do avionics. Some of them build landing gear. Some of them build interiors. But that is their niche capability. They are very good at it. They have a supply base that allows them to break that technology and then integrate and then allow U.S. companies that are relatively large to buy that from the supply chain and then integrate it into the larger whole. So if I were a country and I was looking to build a space program, I don't necessarily need to be an independent spacefaring nation. I can be part of a space supply chain that allows me to integrate into the larger whole. Last example I'll use. I grew up in West Virginia. And so in my hometown, we had this company called Huntington Alloys. We called it the nickel plant, but it was called Huntington Alloys. Well, that company built the space shuttle tiles. And for somebody that had never seen a launch, had only looked up at the night sky and was very interested in this, I was proud of the fact that right down the street was this company that was providing this thing that was going to space. And I use that example because internationally, that's a great example. If a country wants to develop a supply chain, train its people, identify those suppliers, and be part of a supply chain that can be used by not only U.S. companies, but also other companies that may not be U.S. based, that are sending people to the moon and to Mars, then we should do that. So,
excellent point. Thank you. Well, thank you all. Let's turn to some questions from the audience. Let's see. Is there a mic that? Yep.
Hi there. Thank you, everybody. Great panel. I have a question So we've talked a lot about the heavy investment from both states and private actors, but we've also heard from other speakers and panelists about threats and challenges to our national security in space. So I was just wondering, what are the initiatives, what are the goals from each of your perspectives about how to keep space as a peaceful domain for all of mankind?
So,
Chris?
Okay, I'll start. I would say within the department, we have a number of offices that work on the security issues. That's not my office, although we work closely with them. Certainly, the U.S. was watching closely the ASAT test recently in India, and I would say my office, principally, we've been engaged through COPUOS, the UN Committee on Peaceful Uses of Outer Space, on long-term sustainability of space. So make sure that countries are engaging in space in a responsible manner and putting in guidelines in place for that. Other offices work through other parts of the UN First Committee, to talk about various security issues. And I guess I'll leave it there and turn to one of my panelists.
So yeah, and I represent the civil space at the National Space Council, but we have a defense policy expert. And as you know, we had Space Policy Directive 4, which was the initiation of the Space Force, and that alludes to the fact that there is a warfighting domain in space. Now, it's not what you think. We're not having people up in space fighting each other for territory of space. It's more, we have nations who are in conflict and using space as that domain, and that's a real thing. That's a reality we have to live with. I think we are taking the measured steps to deal with that, and we have a strong defense that is looking to make things peaceful. That's always the goal. So there's a reality and there's the ideal. I think the ideal is still to have peaceful use of space, and so that's why we have a separate civil space agency. I mean, it could be worse or it could be different if we had, those things not separated, but we have those things separated, so we have an opportunity for peaceful use of space while we still deal with the threats. But the threats are reality, and we have to work through those.
Question on this side.
Okay, thank you all for an excellent panel. Mosami-san, thank you very much for educating me on JAXA. And now, Chris, I'm going to put you in the hot spot. All right, Charles Bolden, when he was administrator of NASA, he would come here every year, and the question would always come up, why isn't China on the ISS? And he'd always scratch his head. He said, I'm open to the idea, like with a lot of qualifications, of course. But then he said, the State Department has me handcuffed. I can't do anything before them. What's going on with China, the China space program and the State Department? And generally, what would they have to do to get themselves in a position where they would be allowed to cooperate with us?
I'll pull out my standard talking point here. And it's, State Department, we get, so the department in consultation with Congress, and this is very important because Congress has a very big say on what the executive branch can and cannot do with China. There are specific, as you very likely know, there are specific restrictions placed on NASA, which does put my department in place to host a civil space dialogue with China, and we've been doing that for about 5 years. We're planning to hold another dialogue later this year, and in that venue, it's principally an information sharing. So we talk about our plans, China talks about their plans. And our real focus is on spaceflight safety and also on transparent behavior in space, and that gets a little bit more into the security issues. Beyond that, discussions, we talk with the Chinese, we certainly talk with China in multilateral venues and COPUOS. They're actually quite helpful there. It will take a number of decisions to move forward with the White House and Congress to do anything further.
And I'll add to that, we anticipate this question always, right? So we know that this is an issue that people are interested in. The formulation from the U.S.-China summit says that we're open to cooperation that is reciprocal, transparent, and mutually beneficial. So those are 3 key items, and that's where the challenge is with China today. So we also recognize that space cooperation follows and reflects, it does not lead or drive the overall nature of international relationships. So, NASA can't lead what the nation hasn't already identified as a cooperative opportunity. So when those things come to reality, then we can work collaboratively. In the meantime, if we can share data from missions, that does happen. There's opportunities for that. So we just got to identify areas in which those can exist. And for now, that's not in the human domain, but maybe someday.
Thank you.
Thank you. Question over here.
Hi. Thank you guys for this amazing discussion. I think it's really relevant with where space is today and becoming a global society. Earlier, you mentioned the importance of technology from countries like Canada and Australia being used in a global effort for space missions. Are there any efforts to encourage smaller countries that might feel left out or might feel that they have higher priorities other than space? Are there any efforts to encourage them to become part of the supply chain and to provide whatever trade skills or expertise that they could?
So what I would say is it's a two-way street. So not only do countries have to identify that they want to be part of that supply chain, but the U.S. industry needs to identify that they have a gap that they have to fill. And when we deal with supply chain related issues on the industry side, it's actually pretty difficult because you have to evaluate not only the supplier base, you have to identify whether that workforce is able to absorb the requirements that you have to in order to integrate into the supply chain. But also, we might be able to take a cue here from some of the security cooperation policy of the United States government, where there are some countries where they want to develop certain technologies or certain capabilities in certain countries. On the defense side, there's no reason to say that we couldn't do that on the space side as well. I don't know if we're quite there yet, but it provides a relatively good model in order for us to think about that. But smaller countries need to consider whether they want to be part of the space industrial base. And frankly, I think many of them would want to be, with support from the U.S. industry and also the U.S. government.
Well, unfortunately, it looks like we're out of time. I know that there are a lot of more questions. And so I believe that there is a social media opportunity as well to submit questions in. But I do want to thank our panelists today. Please join me in thanking them for some great insight. Thank you very much. We'll turn it over to Artemis.
Thank you, Rebecca. By the way, lunch is 20 minutes later than it says in your program, because there's a slight change of plan, but you will have 20 minutes tacked on at the end of the lunch break time. So I now have the pleasure to introduce Henk Rogers, whom I just found out is Dutch. He may live on Hawaii, he speaks Dutch even, because he was born in the Netherlands and only later moved away from there. Henk Rogers has a passion for the environment. And having been to Hawaii, I would have a passion even more than I have in my own home country for the environment. And a healthy Earth, splendid idea. Next to his passion for the human colonization of the moon. And he will tell us how to do this, how to make way for space colonization, real and present us now here. How you do this? Will it help us to get to Mars? Will it be helpful at all? I hope the answer is yes. And Henk, the floor is yours.
Testing. Hello. Hi. You know, the worst thing you can do is go before lunch. That's and even worse than that is you can actually delay lunch. So I apologize. I have a plane to catch, and the original schedule said 12:40, and the book said 2 o'clock. So there's a confusion. I live in Hawaii, And I had the opportunity to join the Polynesian Voyaging Society on part of their worldwide voyage, which sailed in a double-hulled canoe around the world using only celestial navigation, meaning no instruments. We had an emergency sat phone, but it was only for emergencies. So we basically looked at the stars, the sun, the moon, the wind, the waves, and the birds for guidance as to where we were going. So what were we doing? We were sort of recreating the technology that existed, which enabled the Polynesians to first find Hawaii. And where did they come from? You know, they came from somewhere like Tahiti or the Marquesas. How did they get there? You know, if we can trace it back, you can kind of trace it back to the area of Indonesia and the Philippines. And so they didn't start in Indonesia and sail to Hawaii the first time they ever sailed. It just didn't work that way. My theory, but there's no record of any of this, of course, is that they sailed to islands that they could see, and then they could little by little see a little bit further because of cloud formations, and then they started noticing birds that were going to other places, and they started connecting the dots, and they were able to sail to places that they couldn't see on the horizon. But this is only after they learned how to sail to the islands that are on the horizon. And so my suggestion again here is, how does this work? I mean, how does colonization work in the first place? So the Polynesians obviously must have, at some point in their history, had an exploratory mission to follow some set of birds across, I don't know, it's 2,000 miles of open ocean, to find out where the birds were going. And then obviously they made it back, because then there was a colonization effort after that, meaning they probably went back and got wives and pigs and things that would help them colonize. So here we are. It's now the 21st century, and we're trying to figure out how to do colonization. And the answer is, let's do the island on the horizon first, learn how to row back and forth, sail, learn how to sail, and go farther and farther until we figure out, yes, we've got this down, and then we go to Mars. So I have a plan. Actually, I started with science fiction. If you go back, I was just crazy about Star Trek and all that kind of good stuff. And so when it came time for me to find my missions in life, I found mission number 3 was to make a backup of life on Earth by going to other planets. The obvious planet that we need to go to make a backup is Mars, because it's the most Earth-like. We have got maybe an extra 40 or 50 minutes per day. It's got day and night. It looks like there used to be surface water. And it looks like, well, if we spend enough time and money, we can terraform Mars into another Earth. We're kind of terraforming Earth into something else, by the way, just so you know. I don't know, the aliens are here and they like it warmer. And so they've gotten us to heat up this planet. And so we understand how to warm up a planet. We're pretty good at it, and we can do the same thing on Mars. Just kidding. So here's my plan. First of all, I said to myself, I don't know enough about this stuff to really make a plan or to do anything. So the first thing I said, let's get all the experts, the experts that I could reach out to in one place, and let's talk about how to build a moon base. So we did. We had the Moon Base Summit. It'll be a year and a half now. The book that's over there is who came to the summit and what they had to say. We had lots of different sessions, and I came away with that buzzing with all kinds of information, more than I could handle. But I have a pretty crazy way of thinking about it, that we can actually do this by the end of the next decade. And I think that that's a good target for us to actually do something, to have a target by which, if you don't have a deadline, things just don't happen. We've been putzing around about going back to the moon for the last 50 years. We don't have a deadline. We need a deadline. I think the end of the next decade is a good deadline. I have a little Mars moon habitat where we practice being on the other planets, and that little flyer that's next to it is about that. We spent the last 5 years doing Mars missions. Thank you, NASA and University of Hawaii. They got together to figure out what's going to happen when we put people in a small space for a long time. We've had 5 missions, and I think Kim Binstead spoke to you guys yesterday, so you know all about that. Where do we go from here? First of all, we've pivoted from doing Mars missions, which are like 4 months, 8 months, 12 months, to moon missions, which are going to be 1-2 weeks. I pick 1-2 weeks because I'm looking forward to the day when there's going to be regular traffic between here and the moon, which is much easier than regular traffic between here and Mars. We can only do that once every 2 years, something like that. We can go anytime to the moon, and we can send resupply. So the Mars, or the Moon Mars High Seas, is made out of, it's a steel structure with a kind of a fancy plastic skin that resists UV. It's not sealed. It's 1,200 square feet. And it's built, there's no way for us to make food in there. It's just not big enough. 6 people stay in 1,200 square feet. Basically, we give them all the food that they're ever going to eat during the entire mission at the beginning of the mission. All they do is add water. So we have freeze-dried food. We have lots of powdered stuff. Anyway, all long shelf life stuff. And that, in my understanding of the way colonies worked in history, is that there hasn't been a colony that survived that wasn't self-sufficient. If you wait for your home country to keep on sending you food, then it's not really a colony. It's not working. It's maybe a research station or something, but it's not a colony. The colony has to be able to grow its own food. So I'm working, trying to get 1,000 acres on the Big Island of Hawaii out of the military. They have 140,000 acres, which is way too much. They use part of it as bombing practice. They have little fake villages that they capture, and they do all of that. They even send planes and drop bombs, and they do artillery. It's the only place in the Pacific where they can practice. So they're not going to give up the base. But I'm asking for 1,000, which is even not even 1%. So what's the big deal? Hopefully NASA will help me, or Bridenstine will help me, or somebody will help me push them over the edge, because they don't really care. And what I want to do there is build a campus, the International Lunar Research and Development Park, where all space agencies, all space companies, all space institutions can work together and build moon-based prototypes. My first moon-based prototype, I'm thinking should be, I think it should be like 20 people. I have a guy, Rodrigo Romo, who's working for me in Pisces, and he spent 8 months in Biosphere 2. In Biosphere 2, 8 people spent 8 months. All they did was grow food, and they were always hungry. So that is not a good formula for success of a colony or a moon or a Mars mission. So what I want to do is do, I'm originally from Holland. I became the honorary consul of the Kingdom of the Netherlands to Hawaii, Guam, and the Northern Marianas, wherever the hell they are. And Holland turns out to be the second largest exporter of food product, or of ag product in the world, $100 billion export business in a space the size of Hawaii. It's like, how the hell do they do that? And the answer is they do it indoors, and they don't do it outdoors. And they don't do it in the ground, they do it on concrete. So it's all hydroponic. I think that's the way we need to grow food on the moon and Mars. We can't try to duplicate a forest and try to grow food in the forest. We actually have to get really clever about it. And that's something that we have to study. I think people are studying this, by the way. So the next moon base, I think 20 people, that's just a guess. Somebody's going to have to correct me on this, because I'm not an expert in any of this. And then a big space to grow that food. Maybe 2 or 3 of them will be growing food, and the rest of them can do what we expect people to do on the moon and Mars. So the first one, I'm expecting it to be sort of metal and plastic. The second one, once we figure out, whether we got the size right at the cheap structure, I want to make the second one out of concrete and pressurize it. I want to pressurize it to the same difference of the atmosphere inside and outside as the moon. Moon, let's say it's 1 atmosphere in the base, it's 0 atmosphere on the outside. That difference, we can pressurize the base so that the inside and the outside has the same difference. So if you go outside, you're going to have to go through an airlock, or something bad is going to happen to you. So I think we can simulate the moon base, including everything that we grow, out of concrete. That's the next phase. In the meantime, I'm expecting us to develop robots that can actually dig into the ground and that can 3D print that moon base out of the in situ resources. So we've been practicing by sintering Hawaiian regolith, which is the rock in Hawaii. Why rock in Hawaii is so similar to the moon and Mars is because it's oceanic crust. The moon and Mars is all oceanic crust. So if you're going to build something out of in situ resources on this planet, pick Iceland, Galapagos, or someplace else that's made out of oceanic crust. We even have lava tubes and skylights for those of us out there who believe that we're actually going to try to build stuff inside lava tubes. By the way, a lava tube, the way we know that they're there is it's called a skylight. I've been down skylights. There's a bunch of them around our high seas habitat. And it is a dangerous climb down. And especially more difficult if you're wearing a suit, which we make everybody wear. Every EVA is wearing a suit. It's just a hard thing to do. And at the bottom, you've got these big boulders, so anything you roll down gets stuck in the boulders, because that's the collapsed roof of the skylight. So I would much rather have a fleet of robots go to the moon, dig holes just like termites do, and then create spaces, and then harden the spaces using 3D printing. And all we have to do is add doors, meaning so that we can get in and out of the pressurized, create the atmosphere and pressurize it. So whatever we do in Hawaii or whatever we do on the moon, I think it's directly applicable to what we do on Mars. I think it should be underground because that protects us against radiation. We can send a fleet of robots. They can get on with building the moon base before we ever go there. And then we have those spaces that we've built to our specifications, not to the lava tube specifications. And we can, engineer them rather than hope that we find one that fits the bill. I don't want to take too much time talking. I want to make sure that we get plenty of questions. I'm not an expert in any of this, but I do have a vision, and I do plan to build a moon base on the moon with the help of all of you by the end of the next decade. Did I forget something?
I know you guys are quite ready. Anybody have a question for Hank before he goes and hops on a plane? I see Robert coming down.
When you start thinking about colonization, I don't know if we can get away with just vegetarian diets. A lot of people always focus on the plant growth. Have you given any thought to animal growth or seafood or any other alternatives to vegetables? Well, to plants, rather.
Right. So to figure this out, by the way, I stopped eating meat and fish last year, and I just started eating it again. But I mean, I got away with a year without eating meat or fish. So we're perfectly capable of having a diet. When you think of a cow got to be a cow because it ate grass. So all the stuff that you need is actually contained in the vegetable matter. It's really hard to keep fish alive or anything alive. I would say probably chicken is the easiest way, but I don't know how chicken's going to react to anything except Earth gravity. So we may have to put weights on their feet or something and make them think they're on Earth, or who knows. But chicken I can see, because our chickens, they eat whatever our scraps are and turn it into eggs. How awesome is that? Eggs are great. It's just have to give them the eggshells back to them so they have calcium, and they eat our kitchen scraps. So.
Well,
in response to that specifically, we had a lovely breakout session yesterday about agriculture and food that we could be having on the moon or Mars, including cell-based, growing fish just from cell cultures. So I highly recommend checking that out from Finless Fish. But my question is, right now you have this analog base on Earth, and how are you using that in order to invite people outside of the space industry in order to have that kind of experience and get inspired? Who are you inviting whenever you aren't doing research?
So we all have to quote unquote do research. That's the permit that we have from the Department of Land and Natural Resources. So we did think about, like, what about doing some, lunar Airbnb? And in fact, we did talk to Airbnb, but the thing is, it's like going up to the ISS. Not really that interested in having people go up there and just for vacation. I would like to inspire them. And I do take people up there, and I myself go up for 48-hour missions. If I can get people that are interested or somehow motivated, whatever, then I'll take them up for a 48-hour mission, take them on EVAs, by the way, which you have to wear sort of a spacesuit. So I've taken a lot of people who weren't specifically interested in Mars or the moon to spend time there so they can understand it. And the other reason for going from like 8 months missions to 1 week, 2 weeks is that we can get students, give students the opportunity to spend time on the moon or Mars. But when they're in a mission, they're going to continue to carry out experiments that we start that are multi-mission experiments, whether it be geology, whether it have to do with food growth or whatever it is. The difference between the Mars missions, where they were comparing different psychologies of different groups, and therefore they couldn't change the conditions of the test, so we couldn't change the habitat, basically. That's out the door now. We want to get feedback from every crew that stays with us and find out how can we improve it, and we want to iterate and iterate so that when we get to the point where we're actually building a big one that includes food generation, that we have already improved it to the point where we know something about something.
And last question over there.
So the idea of an international moon-based campus is really phenomenal, and I want to know what is the next step and what this community can do to help.
Okay, so I have a weekly call with a group of people at NASA Ames. It used to be called the NASA Lunar University, and now it's the I forget, they've changed the name several times. But it is a concerted effort by myself, a couple of people in Hawaii, and the NASA Ames people. And the idea there is to have a campus in Silicon Valley at NASA Ames and another campus where you can actually have regolith outside your door. 1,000 acres, I would think that there's going to be a bunch of buildings where people send people to do research, where we internationally cooperate on things like what percentage of, what should the pressure be? Should we be using metric? Should we, all these things that seem fairly obvious to most of the world don't necessarily seem so obvious in this country. But they should be obvious on the moon. We should standardize. And the idea of the moon base would be that anybody who has an idea about how a moon base should be built can just connect their section of the moon base to an airlock. And therefore, you can have many different ideas. You can have an inflatable, you can have something at the surface that's buried, or you can have something that's buried underground or dug out from underground in the first place. So I want to make sure that that what we do there is inclusive. My model is like international airport. Once you get there, we don't care where you came from. We're just there to survive and live on. We don't need you to tell us what country you're from, because that is not the important thing. We're all humans, and we're trying to survive in a very harsh environment, and we need everybody's help to do this. So it's going to be the same on the moon. We'll practice, and then we'll get to Mars once we know what we're doing.
Give Hank another big round of applause. Before I bid you goodbye for lunch, please just let me impose on you for a few more moments. We have another couple of exciting announcements. We're going to do the Mars Ambassadors Program, but what I'm really, truly excited about is we're partnering with my very dear friend and colleague, Holly Malier of STEAM Space. And next year, probably the weekend prior to the H2M Summit in 2020, we will be doing a student competition called Cities in Space. Take a look at their video.
I believe that humanity's destiny is in the stars.
Just getting to space is in fact the easiest part, because once you're in space, you actually have to live in it.
And while they get that ready, Cities in Space is a very different kind of competition, because it's like this past year, through some contacts that I had made in Pakistan, there was an online kind of competition. Some 10-year-olds in Pakistan designed their cities in space. They can do it out of Minecraft. They can do it out of, I've seen elaborate things made out of Legos. I've seen them really, you will be stunned and amazed. And our hope is that once the kids participate in that weekend before, that the winners might stick around and kind of wow you with what they've done. You guys ready back there with the video?
It's the closest chance to Earth we have in outside of Earth.
We'll have a colony that can grow and that can move mankind to another place.
Reach, try the new, experiment, learn.
So we're going to use algae to clean the water if it ever gets dirty.
That is what our thorium reactor.
We had to use actual research journals and published papers.
And
we didn't know about
technical dust bunnies somewhere, the dust storms of tech, right? But very soon indeed, I think, and please come and get, it looks like Hank has left us some materials here. Please come and get that. I tell you what, if we cannot get the video rolling just yet, I promise that when we come back from lunch, we will have that for your viewing pleasure. And again, thank you guys so much for bestowing on us your best grace. And we'll dismiss now for lunch. Come back and see Cities in Space, inquire more, ask me. We're launching all kinds of programs. We'll see you back at 2:20. 2:20. I nearly forgot. So back in here, everybody, at 2:20. Thank you so much.
So we probably should head over to the
Yes.
build. Yeah.
And let me grab. I got to grab my key so we can grab. Can you
So
grab
we've reached the midpoint in the last day of the 2019 Humans to Mars Summit, coming to you from the National Academy of Sciences here in Washington, D.C. I'm Matt Kaplan of the Planetary Society, here for Explore Mars, the producers of the Humans to Mars Summit, with Sonia Gavankar.
I'm excited to tell you what's coming up, but I also wanted to tell you a story about Hank. Last night, there was an after event for some of the folks here, and it was a cocktail reception where we were all getting to know each other, and he told me that the perfect temperature to do work is 13 degrees Celsius, which turns out to be the same temperature basically that it is in Silicon Valley. So if you need any more reason to drop the temperature in your house and get to work, if we can be at his level, I think that I'm willing to get a little chilly to do some work.
Can I wear a heavy sweater? And considering he's from Hawaii, he doesn't experience that much.
This is what I said to him. I said, my perfect scenario is in a comforter, with a heating pad. And he said, no, you got to be a little chilly. It's what stimulates the brain. So.
All right, well, it worked.
Maybe you do also need to take a little time in Hawaii, which I'm also willing to do.
Yeah, I any time at all. And if he wants to host me for one of those 48-hour stays in high seas, I will definitely be there. We do have the entire afternoon left with lots more great content to entertain you, and educate you with, and inspire you as we pick up today after lunch. Now, we're hitting lunch a little bit late. I suspect we will still be coming back at about 2:20. I think that's about the right time. And we do have much more lined up for you. I am supposedly going to be talking with Masami Onoda, who was in the International Collaboration Panel a few minutes ago. I don't think she's here with me right now, but you're ready to go, aren't you, Sonia? I'm going to hand you the mic.
Thank you so much. I want to introduce you to Aitro, who was here earlier today. You saw him during the live stream, talking about the future of money. Can I call it money if it's blockchain and it's currency, it's currency.
Well, I think one of the big misconceptions is that that's all that it is, right? I think currency is one of the many uses for it, and it's probably the most commonly thought of use right now. But really, it's data, and money is just a ledger of data that people have shared. But I think more importantly, like sharing sensor data, sharing video, sharing metadata, that sort of a thing, without having to have trust of other systems. And so basically data sovereignty in itself using blockchain is something which I think is a very important thing which is happening on Earth right now, but also it'll start going towards the satellite networks and any IoT devices, swarms of IoT devices that do things also, like we talked about that a few different people here, where if you can get 20, 30, 100 little devices that can go out and build a little habitat for you, right? How do they all communicate? How do you always know that nothing malicious is being sent to them and that sort of a thing? So at a certain point, if you have enough people on the moon, there might be an interest for somebody to go and send bad data to your devices. So your devices go over there where they're not supposed to be, while you go and do something over here. So there's, it's all data centric, the blockchain thing, but it's really meant for a decentralized, non-central authority system, which everybody can actually subscribe to, because that way it's fair.
So I'm a pessimist, so I always look for, the devil's advocate side of things and the negative side. If there's no central authority, who's in charge?
Well, that's the idea. It's, no one's in charge. It's math, really. Math is in charge.
Math is in charge. That scares me even more.
Well, it's the thing which is nice about blockchain is you can look at the math, you can look at the data, and you can validate it as true. So, for example, if I have a block of data and I produce that, then I signed that and we co-signed it or whatever it is. Later on, I don't have to ask you if it's still true. I can go validate it myself with a zero-knowledge proof. And the idea of a zero-knowledge proof is you don't have to have any outside data. I don't have to go and ask, oh, is this true? Is this valid? I can look at the data itself, and it's self-sovereign, and it has its own ability to be validated without having to have an authority do it. So math is the way that you can actually validate it's true.
Should we get on board now? Should this be something we're moving to now? I know there are a lot of concerns, but do you think that people need to be early adopters of this, so by the time we get to all traveling to space and to Mars, that it's second nature? It's just like using our debit cards, which seemed so new to us just a couple of years ago.
Yeah, as I said on stage, I'm a self-proclaimed dataist, and I think that the idea of people getting familiar with dataism and the idea that data is something which is valuable and has a lot of use and a lot of utility between people is something people should get used to on Earth. I think they actually are right now. People have gotten, they share everything on Facebook and on Instagram and that sort of a thing. So understanding all the costs and all the benefits of data and data sharing and like being able to validate data and data certainty versus data accuracy is also a big question. People often say, well, accuracy is important, but would you rather have certainty and as opposed to accuracy? And in many cases, certainty is more important. So I think people are starting to get that paradigm and that cultural shift going on Earth, and with all these IoT devices that are out there. And I think that will just naturally bleed over into these more nascent systems like the satellites, and then eventually to the moon and to Mars. But you have to have a place where A, the technology can actually reach it, and B, you have multiple parties which actually need to share data or get the benefit from it, because there is overhead to using blockchain. It makes it a little bit slower. There's a little more data storage and stuff like that. So if you don't actually get any of the benefit of it, why would you actually pay for that overhead? So there's, it's not a hammer that fits every nail.
Thank you so much for being with us and for not only demystifying it for us, but telling us what the future is and these different dynamic uses of technology. Math is in charge. Yes. Well, thank you so much. Thanks for being here. I'm going to pass it over back to Matt for our next interview.
Thank you, Sonia. I'm going to bring over Masami Onoda, as we had expected, to be able to talk with her a little bit about international collaboration, but really more specifically, the Japanese Space Agency, JAXA. Please come right down here next to me. Thank you. And thank you very much for doing this.
Oh, thank you for having me.
And you direct the JAXA office based here in Washington?
Yes, exactly. We are a small office of 3 people in Washington, D.C. We are independent from the embassy, but related to, of course, and I'm the head of the office.
And your fairly recent arrival, I think I heard you say on stage?
Oh, yes. I arrived in July last year, so it hasn't been a year yet. Yes.
Well, I hope you're enjoying Washington.
Mm-hmm. I do. The community is great. We are very closely communicating with each other, like at events like this or various events. We bump into each other all the time, and we exchange views, and we talk about our current problems, our future aspirations, and it's great.
And I'm not surprised to hear that JAXA has an office in Washington because the level of space collaboration between JAXA and NASA is quite extensive. But then JAXA has relationships with ESA, the European Space Agency, and other agencies as well.
Yes, so we have worldwide offices in Paris, in Moscow, in Bangkok, and here in Washington, D.C., of course, and Houston for the ISS program. And so we are very internationally engaged.
And I'm glad you brought up the ISS because, of course, Japan is a major partner in the International Space Station with the Kaibo module on the space station, still quite busy doing a lot of science.
Yes, so we are very active on the ISS, and now the Vice President, Wakata, used to be an astronaut. I mean, he is still an active astronaut and still, I believe, wishing to go to space if he has a chance. And so we are very active in human spaceflight as well, towards lunar exploration, towards the Gateway, and also very currently active in the ISS on R&D, also engaging the private sector to work with us.
And I want to get to the great robotic successes that JAXA has enjoyed in recent years, but because you mentioned the Gateway, the Lunar Gateway, you no doubt have been in many conversations since the big announcement that we had on Monday from the NASA administrator and the U.S. administration about plans, the somewhat of a downgrade of the Lunar Gateway, but still a lot of talk about the importance of international collaboration. Does Japan hope to be, does JAXA hope to be a part of this effort to put people back on the moon?
Absolutely. So currently we have plans for astronaut Noguchi and astronaut Hoshide to be on the ISS, and we continue to work with our astronauts to send them to space and to have a presence in space. And we would very much like to work with the international partners for of course, the landing on the moon, to do science, to do the groundwork for that, to lay the infrastructure as well, and of course to be a part, as has been negotiated in the past years and studied, to become a partner in the Gateway as well. So we are just in the course of studying it and coordinating it internationally, and we would like to closely, together with international partners, continue this.
Still studying, which is a good deal of, I think, of what is still going on at NASA headquarters here, as this has all happened just in the last few weeks. Let's get to some of those. I think remarkable is a good word for the successes, the recent successes by JAXA, and some that are not so recent. I mean, I'm with the Planetary Society, and as you know, we have a solar sail, our LightSail 2 launching with luck on June 22nd. But I just earlier today, during one of these breaks, talked about Icaros, the enormously successful and innovative solar sail launched by JAXA.
Yes, so we launched this very, very successful mission in 2010. It's already completed all its missions and is in hibernation mode right now, but it's still up there. And we had the pleasure of welcoming Mr. Bill Nye to our office a few days ago.
My boss.
Yes, exactly. And yes, he was so friendly, and we loved it having him in our office. It felt surreal.
So even in Japan, you had some idea of his reputation?
Oh, yes, the science guy, right? Yes, exactly. So we did very much enjoy, yes.
And no one is more enthusiastic about international collaboration. But this is a very important thing to explore Mars, the creators of the Humans to Mars Summit as well, which is why I know they were very happy to have me talk to you. Let's talk about that much more recent success of Hayabusa 2, a mission that is still very much underway.
Yes. So as I talked on the panel as well, we were very excited with all the successes up to now. With the last October having the mascot, this was an international collaboration with the French and German space agencies. So it was
That's CNES and DLR.
CNES and DLR, and we were all very excited because this was around the International Astronautical Congress last year in Bremen. So it was all very timely, and so this landed on Ryugu successfully. Then this February, the Hayabusa 2 itself touched down on the asteroid Ryugu. It looks like we are sure that it collected samples there, and it will be coming back 2020 to Earth.
And made a good-sized hole in Ryugu as well.
Exactly. So that was very recent, this April, that they made an artificial crater, we call it. Yes. So that was also exciting. Yes.
Interesting that a parallel mission, OSIRIS-REx, a NASA mission, but with international collaboration, there is a great deal of data sharing between these two missions because the two objects that they are visiting seem to be quite similar.
Yes, so OSIRIS-REx is going to Bennu, and with the Ryugu asteroid, we will exchange samples and data for this. And in most of our science missions, I would say we have many, many scientists from all over the world come together to study the new sciences and the new discoveries that we have and share the data. So this space science data typically is very open and the science is very open. So it is all of our missions, science missions, are very international.
So I wonder if you have the impression, which Bill Nye likes to talk about as well, which is that space brings us together and brings out the best in us, that it seems to be an area of international collaboration which is particularly successful, fruitful.
Yes, I'm sure that is the case. And also space brings lots of benefits. They inspire the new generation, of course, next generation. It will bring these days what we call new space, many emerging innovative businesses, and it would boost the economy, hopefully, and it is already lots of investments coming in, and hopefully we can show return to those investments and expand our economy, space economy, as planned in, for instance, in Japan, we have this Space Vision 2030 that tries to double our space economy base in Japan. Yes, so we are very much positive that this might happen, and we are working with the private sector to further boost the space economy and bring benefits, more applications from space, and as we just said, science inspires everybody, so it's great, yes.
I'm sure you're looking forward to enjoying lunch, a late lunch here at the Humans to Mars Summit. Just one other question. Whatever may happen with Artemis, the new lunar plans, what is just ahead for JAXA? I know you mentioned a couple of things on stage.
Yes, so for us, with regards to Moon, we have our own projects also, a good project called SLIM for precise landing on the Moon, currently planned for 2021. And we also have next coming up a Moon lander project, a exploration project to explore the pole of the Moon, polar regions of the Moon with the Indian Space Agency. Yes, and then to have a lander also with the European Space Agency, Canadian Space Agency, and then followed by what we recently announced for 2029. Right now we are aiming at for a rover with Toyota, as you might all know. So yes, we have some very exciting projects coming up, and we, of course, next year, as I said, are expecting the Hayabusa to come back to the desert in Australia. We will go to fetch it, and the capsule will come and hard land on the desert. So that's very exciting too. Looking forward to also the H3 launch in fiscal year 2020.
Brand new rocket.
Brand new rocket. So we currently have the H2A and H2B. Now this new H3 is going to be launched in the next fiscal year. And also, that happens to be the year of the Tokyo Olympics and Paralympics. So the whole Japan is positively very excited about all of this happening, and we hope to be part of it.
A lot to be excited about, both in space and on the ground. Thank you so much for taking a few moments to join us, well, for participating in the Humans to Mars Summit and for being part of our webcast here at the summit as well. Thank you. Domo arigato.
ありがとうございました. Thanks so much.
Masami Onoda is the director of JAXA operations at their office, as you heard, here in Washington, D.C. All right, we are about to go back into lunch. I'll be rejoined by Sonia.
Hello.
And we can talk a little bit about what's ahead. We've already mentioned a few times that closing session, which should be very fun.
It's going to be like a lightning round of what we've learned over the last 3 days. So coming back after lunch, which will be happening at 2:20, we'll be joining you again with live programming from our main theater. And then we are going to wrap it up with this great final panel of all things that we've learned, all things that we can take into the future. Kind of in passing and in conversation, we've been saying, now what? But we kind of know now what is going to be happening. So let's be inspired and let's leave this space to go into the future.
And a bit of how we're going to maintain the momentum, which we certainly feel in this room, but has to be continued on the outside. Also coming up, a session about using social media to further space exploration and getting people to the moon and Mars. One that I'm really looking forward to, Avi Loeb from Harvard University, who's going to talk about how Mars might be a stepping stone to beyond the solar system.
Yeah, why stop here with just talking about Mars? Let's take it even further. I spoke to somebody at NASA during one of the breaks, and she was saying she works in robotics and she's about to start working on the human side of things, and she said it's really interesting for my day-to-day that I do that seems, you know, just kind of what she does day-to-day, to be re-inspired by all the people who are working on all the other parts of the process, the rest of the team, and be excited for what they're doing and how her piece fits into that. So that's kind of cool to hear from the people who are taking all these steps. So now we're working together. Let's shoot past Mars.
All right, we are going to say goodbye for the moment. We'll be back just before the end of the lunch break to reintroduce, get things going again on stage here at the Humans to Mars Summit. To keep you entertained and informed until then, we're going to go back to Living Maths. That, again, is Steve Sherman, our colleague in South Africa, who has been a multi-year participant in the Humans to Mars Summit, but doing it from halfway around the world. And what we have is another of his terrific interviews that he taped remotely from his base in South Africa as part of the great work he does with young people in Living Maths. So we can go to that now.
I believe that humanity's destiny is in the stars.
Just getting to space is in fact the easiest part, because once you're in space, you actually have to live in it, right? And space wants you dead.
I have learned that through STEAM we can solve many different problems.
Altitude convergence, the radar has locked on the ground. Touchdown.
Let's say we are attacked by asteroids. After our probe locates the asteroid.
You guys are here at a really exciting time. We're all talking about space.
STEAM is going to help our generation.
Want to go to space? Let's go.
We're going to be the new generation in Mars.
It's the closest chance to Earth we have in outside of Earth.
We'll have a colony that can grow and that can move mankind to another place.
Reach. Try the new. Experiment. Learn.
So we're going to use algae to clean the water if it ever gets dirty.
That is for our thorium reactor.
We had to use like actual research journals and like published papers.
At first, we didn't know about sulfur concrete at all.
We'll get it from other planets and then we'll purify it and then we'll divvy it out to everybody.
To have a truly thriving community, everyone is needed.
One of the first times we ever realized that there are no real borders was when we were in space.
If you try hard enough, you can accomplish anything.
Wonderful job, you guys. Everyone clap, everybody. And I'll see you next year.
Now you, go out there in that world. Go build something amazing.
So we are now live officially with Dr. Jancy McPhee, and you are by profession what? I mean, you've studied so many things. What is the actual profession that you go by?
So I have a PhD in neuroscience. So my story is that I was always interested in science and always good at it, but all of my hobbies were music and theater.
Mhm.
So when I went to college and had to decide what I wanted to study, I tried to find something that would blend all of my interests together. So I chose neuroscience, which is the biology of thoughts and emotions and creativity and movement. So it allowed me to kind of put all my interests together. And then I became a laboratory research scientist. And I studied the cells and molecules that make your nervous system work.
Mhm.
And parts of cells and molecules, very, very small pieces. And then I missed the big picture a little bit. So I went to NASA Johnson Space Center. And I used all that scientific training, but in a slightly different way. I used it to help coordinate international space life sciences research programs.
So what does that mean? International space science research programs.
Right. So it meant a couple of things. So the thing that I did the most was I tried to coordinate multiple sites around the world who wanted to do research together that was performed in a way that was standardized so that we could actually pool our data. So each site would be able to do, in science, we have to have things to compare our data to, and the data you get is more meaningful if you have larger numbers of samples that you have collected. So, but the research we were doing was very expensive and complicated, and so the idea was if each of the 3 different sites could do a third of the data collection, it would save each of the sites money. But in order to do that, we had to design our equipment and how we do our experiments in a similar enough way that we could actually compare and pool our data. So it was a lot of work, but I wasn't just interested in standardizing research. I was also interested in fostering collaborations so that we could, we're talking about space exploration is off the planet. But a lot of the groundwork testing is done here on the planet, and I think it's beneficial to get a diverse viewpoint about what is the best science, what needs to happen, what are we going to do while we're in space. So the work was largely about in-person human exploration, my work with NASA, and less about robotic exploration. So those were the kinds of things I was doing.
Interesting. And I mean, you were doing that how many years ago?
So I actually am still doing not exactly that work, but I do some work where I'm interested in thinking about kind of the next steps of space exploration. So I think that word is filtering out that we are many countries around the world are interested in going back to the moon. And we are going to go to the surface of the moon. We're going to go with robotic instruments and landers. And we're also going to try to go back in person. So the world is preparing to return to the moon and stay a longer time and live and work and build habitats and have an entire commercial economy and do a lot of science. There's a lot that we can learn, not just about the moon, but about our own planet and about the universe and our solar system by studying things from the moon.
Aha. There's obviously a commercial value to that information. So what happens to that research once you find it?
So A number of things. Yes, there is an important commercial aspect to that. And actually, more and more of the government-led agencies are actually trying to figure out how to work more collaboratively, not just with other countries and agencies, but also with commercial entities who are interested in space exploration. So it's kind of a new model, and everyone is trying to figure out how to do that, because historically it used to be that there were just a couple of very large space agencies and they pretty much ran everything. But it's very clear that more and more countries are interested in space exploration, and more companies are interested in, is there an ecosystem? Are there things that we can mine? Is there actually an economic structure, even just in the supporting of space science and engineering as we move further away off the planet? Now, obviously, there is already a space economy. We have satellites, and they communicate and take data, and there are commercial entities that have worked with the International Space Station as it's been orbiting for more than a decade. And so there's quite a bit of economy already, but now we're entering the next level. And one of the things that we're interested in knowing is, can we live and work on the moon? Can we live and work on the moon and use it as a test bed to figure out how we will live and work and do science on Mars? And one of the big questions, for example, is how will we use resources that are on the surface of either the moon or Mars or another location? How will we use that to build the things that we need to get some of the things that we need to keep the human alive? And all of those different things are very interesting, and potentially there will be an economy associated with identifying those resources and mining them and then turning them into useful products. But first we need to do some more science to understand exactly where they're located and how we will actually test the technology to turn those raw materials into useful things. And it's really a wonderful partnership when agencies and commercial entities work together, because the more research we do, the more we know about the commercial possibilities, and the less risk it is for commercial entities to get involved. So it's a real partnership here that the world is trying to develop. And it's a very interesting new era of space exploration, and it's happening soon.
Probably sooner than most people think. I mean, within the next few years, we've been to the moon before. So as difficult as that task was back then, we are way more prepared. The equipment is better. The people are far more organized. Now we've got cheaper modes of transport that will get there quicker and probably a little bit more safer. So I do think that from a potential, a growth point of view, we're going to be able to obviously do a lot more. But so my question is, when we get to the moon, there's obviously a human aspect. It's not just the case of, can we find water, can we find rocks, and can we find certain things we can turn into resources that can be used? Do we take our own stuff with us? Do we become self-sustainable? I mean, are we taking a little module with us that we're going to live inside so that we don't have any issues, but we don't rely on the moon? But then what's the point? Why go to the moon if we're going to take a self-sustaining environment with us?
So you broke up a little bit there, but I think you're asking about the human aspect of basically space development and exploration. And it's a very interesting topic. There's a lot of discussion over what can be done robotically and what can be done in person. And actually, they're mowing the lawn. So if you hear a new buzz outside, there's a little extra noise, but it hopefully won't last very long. So I am very interested in the human aspect from a lot of different perspectives. So to start closer to the question you were asking, so there are still a lot of things that the human being is better at than the robots. And so that's an important aspect. There are a lot of discussions with my colleagues about, for instance, if you just think about lunar or Martian geology, how much can we do with robots remotely and autonomously? How many decisions need to be made in person by a trained human being? So there are a lot of advantages. And in order to support longer missions, we are going to need to develop the tools we need to live and work on the surface. And so we're going to need some sort of habitat structure. And, you know, we've been living in space for a long time on the International Space Station, and there's been a lot of research about what is needed to keep the human healthy physically and emotionally and mentally as well. And we've made great strides there, but there will be more research required with each new environment that we go to, because each one brings a new set of challenges. Some of them are physical, some of them are emotional. So there's a lot of interesting research into taking care not just of the human body, but also the human behavior and welfare. And there are a lot of people who are asking questions. If we're really out in space for a long time, what are we going to do for entertainment? And what are we going to do to keep all the other parts of being human alive, like, you know, the role of art on the interior of a habitat, the ability to make things creatively, the recreation that will be available. So we've had a lot of focus on being safe and healthy, and some on recreation, but there's even more research that needs to be done. Now, to move a little further away from your question, when I gave the introduction about sort of my formal credentials, I didn't tell you that during my process of working with NASA, I realized how important there were a couple of aspects that I'm very interested in. And you could tell that when I was a neuroscientist, when I chose to become a neuroscientist, but sometimes you don't understand your path and your journey until you're looking back at it. You don't always know what is influencing you along the way. You don't know what experiences are going to turn out to really affect you and be important. And therefore, when I talk to people, I always say, keep yourself open to broad experiences as much as possible. So the three things that I realized I was very interested in were, how do we communicate about space and all the underlying science and technology? It seemed to me, and I started thinking about these things about 10 years ago, it seemed to me that we could be doing a better job. So that was the first thing. So it's communication and education. The other thing that I was very interested in is, what is the process of being creative? We have so many future challenges in moving to the next steps in space exploration, but also we have future challenges in other science and technology fields as well. How can we address those challenges? How can we best prepare ourselves and our teams to work collaboratively to come up with those solutions? And then the third thing is, just because I think this is more based on my personality than anything, but I am very much the teaming queen. I am very interested in how we get different kinds of people to work together in an effective way to solve these challenges. So all of these things come back to our challenges, but I think those three different things, the communication, the creativity, and the teamwork, are three important elements that we could know more about and work on to prepare ourselves to solve some of our challenges. So I did start a nonprofit, but the work that preceded that nonprofit began while I was a scientist, and it basically was called the Humans in Space Art Program, and it involved using art integration techniques to help foster some of these things that I think are important. So the basic idea is we hold international multimedia contests about an important or interesting question about space exploration. And sometimes we're asking children to provide musical, literary, visual, or film artwork. Sometimes we're inviting young adults and early career professionals. Other times we're actually inviting professional artists or even professional scientists to create artwork about their work so that we can weave this artwork into multimedia displays that then engage and inspire everyone who sees the artwork about the future of space exploration. So we touch the lives of the participant. We encourage them to learn the topic. So if they're a scientist or engineer, they learn to create something different and to look at their science and engineering differently and to become a better communicator. If they are an artist, we invite them to learn about space and contribute to the future and become invested in it. So it's a very broad effort to invite basically everyone to get more engaged in the future of space exploration, but also to prepare and train themselves to be better equipped to help us solve the grand challenges. So, sorry, that was a long.
No. That hit the nail on the head. So the real issue at the moment is that we are planning to go to Mars, but obviously it makes sense to first go to the moon and test out, the living environment on the moon before we go venture a little bit further down the line to Mars. But of course, it makes more sense to first try some things on Earth too. I mean, I know of a few what they call analog projects where people are putting themselves in extreme environments to see if they can survive under very difficult circumstances. And then obviously the moon would be a breeze without the breeze, of course, because there's no atmosphere. So, I mean, it would be so much easier to go to the moon if we've tested many of the different living environments on Earth.
Absolutely, and that is exactly what we're doing. So we have a lot of work that we do in the desert. We have work we do in caves. We have work in the Arctic and the Antarctic. We also have special facilities that are built to mimic being isolated from the outside world for long periods of time. We also have research that mimics the long-term effects of being in a reduced gravity environment. Interestingly, most of our scientific data, though, both on the Earth and in space, is the simulations mostly look at the effect of essentially no gravity on the human body. And we know what it's like to live on Earth, which is, a one gravity unit. Mm-hmm. But what we don't know is what it's going to be like to live on the moon and Mars.
And sixth of the gravity.
Right. Or 3/8, because we have no data between 0 and 1, except for some simulations that we have tried to do. And more people are proposing work to try to understand what would be the effects on the human body to be in an environment that's between 0 and 1, especially for a long period of time. And the moon will allow us to get a little bit of data, at least at 1/6 G. Will it be very much like living with no gravity? Or will it be very much like living on Earth with the gravity that we're accustomed to? Mm-hmm. We just don't know, because we don't know whether it's a straight line between 0 and 1, or a curve like that, or a curve like that. We just don't know how the plot will look between those 2 points.
Okay,
so it's very interesting.
You're going to be involved in the Humans to Mars Summit. And obviously at this particular event, there's a lot of discussion surrounding the trip to Mars, how we're going to live there. So you've obviously put a lot of thought into landing on the moon and doing the stuff on the moon. Do you also put a lot of thought into going to Mars?
Yes. So that is one of the important things that drives the quests for science and research, both for the humans and robotic and equipment. So it's a very important set of questions. But our most recently completed contest artwork is actually a suite of films and posters asking college and early career professionals to create the films and posters about what will it be like to go to Mars as the first humans. So all of those are online and available for display. So we actually have a huge suite of artwork just about Mars. So I am very equal opportunity in my interest in the questions that need to be explored. And I am also very interested in, as I mentioned, giving as many different kinds of people an opportunity to get engaged. And so by asking the public to create artwork, we are giving them an opportunity to really to share their views of what this future should be like, and to also feel a part of it, but they're also telling their story. And the topic of my lecture at Humans to Mars is actually going to be, why do we need to tell the story of the future of humans on Mars, and who is responsible to do that? And I will, not to, make it so that nobody needs to go, but basically I'm going to say that we all need to tell that story, because we all have something to share about that story. Everyone has a different human experience base. And I think it's an important thing. Everyone needs to get engaged. This is a next step for humans. And we are inherently curious, and we like to experiment. And it's very natural for this to become one of the most important things that we do next. It's just, how are we going to handle it? And for instance, you haven't asked this, but a lot of the artwork that we get basically asks the question, why are we going further into space when we have so many issues here on Earth?
And that's a very topical issue.
It is. It's very topical. It's very important. There are a lot of questions like that that need to be addressed. And the art form allows the why of space exploration better than our white papers and technical reports. And why is important. If we want to have support, if we want people to want to learn the skills to participate in this future, if we want them to vote for this future, if we want them to help us develop the technology and do the research, if we want them to tell our story in the newspapers and social media, we want them to paint the insides of our habitats or help us to live a full life there. The why is very important. And so it's a good question to be asking, and we have some answers, but it's important even just the act of asking the question.
Of course, I think once you build a natural curiosity and you start asking why, people then start finding innovative ways to answer that question, and sometimes that results in certain discoveries because the question challenged people on something that they took for granted. So that makes sense. Let's go back to 1969. A couple of guys landed on a big rock floating in space. If social media was around then, and your arts initiative was around then, how do you think the story would have played out from a storytelling point of view? Because you're telling me it's so important to talk about the story of going to the moon and going to Mars and who's going to report it. We know about a situation where we went to the moon in 1969. If you'd go back then, how would you have reported it?
So I was alive in 1969.
No, I know that, but I'm just saying the project was running at that particular time.
No, it wasn't. I think that it would have been fascinating to have invited people to contribute their feelings and impressions of that time. A good example is there have been great efforts at many of our future space missions who have invited the public to get engaged in their missions. Curiosity, most recently New Horizons. There's a huge long list, and I'm not doing justice by giving you a broader perspective. But I think it's a wonderful opportunity. If someone wants to write a song about our return to the moon, or if someone wanted to write a song, landing on the moon made it into music. It was all over television. It was in eloquent speeches going forward. It was heard in the voices of the astronauts from the surface of the planet. So we had that 50 years ago, but now we have a chance for even more people to talk about the awe and the impact and how it makes them feel and why it's important and all of those different things. And we are trying to do a small part in that by actually, we have an open contest right now that is for anyone from around the world, ages 10 to 18, and it's called the Moon. It's about what will we do on the moon, and it's part of our Humans in Space youth art competition, and it's asking young people between ages 10 and 18 to create music and literature and film and visual art about what will we do on the moon. And it's open until the middle of May. So there's still lots of time for young people to work together, to learn a little bit about why we're going back to the moon, and think about their visions and their views and what impressions they would like to share through these creative formats.
Well, I mean, I will say this: if one is being creative, then one has to obviously explore certain scientific facts. If you're going to portray the moon or life on the moon, you can't just say, oh well, then we'll be pouring tea from a jug, because there's a certain science that says that's not going to happen. So what I do think is that sometimes the art can be inspired by the science behind it. So that's, I mean, it's a bit of a no-brainer. That's pretty much why I want to lead into the next topic, and that is, right now it's very popular to have STEM education, the science, technology, engineering, and maths. And in the last, I don't know, I'd say about the decade, people were talking about STEAM. And then afterwards, they went from STEAM, they switched into STEAMY or eSTEM, or they've given it all different names, but effectively they are talking about using the art within the science. And I'm very curious to hear from you your opinion on, putting art into the science and why schools are missing out if they don't include the art.
So I will start with a little bit of perspective as having been trained as a scientist, and I will also provide a little bit of data. So first of all, I think that the STEAM movement is fabulous, but I also think that it's a little bit of going back to the Renaissance. And I do think that's important because the neuroscientist in me, there's this very oversimplified idea that you're either left-brained or right-brained, and that's just kind of the way you are. And that is, there are definitely parts of the brain that are specialized for particular activities, but why would anybody ever want to only use half their brain? That just doesn't make sense to me. Plus, it's not really the way it works. In order to be creative, whether you're a scientist or an engineer or an artist, what you do is you pull on all the different kinds of experience that you have, your detailed knowledge and your broad knowledge, and you make new connections between that information. So everybody needs to be using their full capacity as much as possible. So by teaching young people to be good at only one or the other, some of it is by necessity, because you do have to specialize in order to contribute to the workforce in many cases. But my plea is to allow the broadness as much as possible. So by encouraging, for instance, if you look at our scientists and engineers, there's a big difference between a good scientist and a great one. And I believe that some of those differences are the other skills that we don't tend to teach in our science and engineering classes, like the ability to communicate, the ability to work well with other people, the ability to approach a problem in multiple different ways, using different mental devices and mental approaches. And I think those are very important skills to be really an excellent scientist and an engineer. Plus, I think that we tend to be a little exclusive and we don't invite people who have different kinds of training into our science and engineering problem solving. So we need to develop sensitivities between people to make them better team players. Oh yes, I'm going to work with that person. That person's an artist. I believe that they have something to contribute. I know that they use different words than I do. I know that they may approach the problem solving differently. But I have had some training and I understand and value that, and we're going to figure out how to work together. Similarly, the artist is saying, well, you know, I don't think exactly the way the scientist does, but I respect and value that, and we're going to work together. I think there's a lot that we can do to allow a more collaborative problem solving. So I think inserting the A or the M or the Y or all the other letters into our education system is really just a general plea for don't be so narrow in what a student is taught. And within an art class, you can take on a science or technology topic.
Okay, sorry, I had to mute there. All right. I know we've got some people who are watching it live, and we also have people who are joining us in the room over here as well. So we'll start with Mr. McNulty. Are you guys joining us for the rest of the session? If you are, do you have any questions? And any of the panel over here, Katrine and is it Rihanna? I'm not sure who else is there with us. You can just type in your names and then where you're from, so we can let everyone know who you are. I know we had Kiki from Greece, but she has left with her group. So Mr. McNulty, any questions from your side? You guys, are you a stream? Are you a STEAM? Are you a STEM middle school? What are you?
Well, you can hear us right now, right?
We can.
Excellent, good sound. I have a question right off the bat. I heard you talking about collaborative work, working together, the basic human skills that we don't always talk about. But this is a middle school. That's what we're all about. Can you give us an example of a project that your organization does that brings together that kind of teamwork, maybe a collaborative project of some sort?
So we are still fairly a relatively young nonprofit. So we are still working on that. But I do a lot of lecturing and workshops and training to try to develop some of those team skills. That's a much more in-person activity. And I also have a lot of colleagues that I work with as we try to develop what does it take to be a good team player. A lot of the international online contests have people who enter as teams. And so I know that a lot of teachers use our online contest as a model to actually practice team skills right there in their environment. So they will put together a team or have young people assemble their own team to take on one of these prompts for the international contests. And that allows them to really try to take on something that has a lot of different diverse aspects to it, and that brings to the forefront a lot of the training that's required. You know, in order to be a strong team, you need to have empathy for where other people are coming from, where their ideas are coming from. You have to communicate in a language that takes into account the priorities and the way other people are talking. You need to be resilient when your idea is not always the one that's selected by the majority of the team. There's a lot of things that get practiced by doing those team activities.
I mean, that's an incredibly valid point. I see it. You do have another question. We'll come back to you, Mr. McNulty. Katrine, do you guys have a question there in Germany? You can just unmute yourself.
Yes, not at the moment. We are just listen to the interview. Maybe later.
Okay, that's no problem. No problem.
Okay.
I think we have a guest from Russia. Do you have a question that you want to ask? We have no response yet. Okay. We'll come back to Mr. McNulty. You want to ask another question?
By the way, I didn't introduce, but this is Holland Middle School. We're in Pennsylvania near Philadelphia. And our questioner's coming up. He's going to introduce himself in a minute.
So I grew up in Pennsylvania,
Oh, really? Where at?
just north of Philadelphia.
That's us. Yeah, we're in Bucks County near Newtown, Doylestown, that whole area. All right, now go ahead.
I grew up in Tottenham.
And I have a question. Do you think Elon Musk will use this art research to find a way to Mars?
Can you ask the question? You broke up.
Do you think Elon Musk will use this art research to find a way to Mars?
Will Elon Musk use art research to find a way to Mars?
Could he be inspired by maybe, students who develop a way to get to Mars, and then they create rocket ships in their imagination, and that inspires him to create something that most people would say it can't be done?
So the question you're asking is how does so Steve already mentioned how science and technology inspires art. But the larger question of what you're asking is how does art inspire science and technology? And so we didn't talk about that flip side. And so you're right on target. You're being very specific in your question, because Elon Musk is definitely a personality that everybody knows.
Mm-hmm.
He's also extremely engaging in many ways, and I would argue he's already using art. When he sent that car, Spaceman, Rocket Man, whatever he was named, into space. So he's already engaging in art and allowing this to inspire what he wants to do and to use it as a tool to inspire others. But the larger issue is just how does art impact science? And I am really fascinated in that topic because I'd like to see it happen in a more concrete way. But we definitely have obvious examples where, first of all, art is a fabulous communicator. And, policies, public opinions, voting, all of that can be well communicated through art. And that includes advertising, whether it's music or film or posters or things that you see. But I think that Steve was already mentioning that a lot of times what happens is there are ideas out there that are not reality. And so you can't just go out and take a picture and say, okay, this is what we're going to do. You have to turn these nebulous ideas from the brains of the one person or the team and turn them into something that everybody can relate to. So a lot of times that will be, for instance, a visual concept. And one of the people who has really helped us along the way was a fairly well-known space artist who actually worked in an engineering company. And he would sit in on all of the technical discussions, and he would actually capture through visual art a lot of what was being proposed around the table. And it was fabulous because a lot of times it wasn't exactly what they were thinking, but by seeing it conceived, it kept the dialogue going. And sometimes something is visualized in art that then strikes an idea in a scientist or an engineer. And just going back to the work that I started to talk about that I used to do internationally, the topic that we used to look at was whether or not we should have artificial gravity on long duration space missions, because we don't know what will happen for really long periods of time without gravity, years and years and years. So there are a lot of different ways to generate gravity. You can spin someone in a small centrifuge for a couple of hours a day, or you can spin the entire spacecraft. And we have never had an entire spacecraft like that spinning. And so whenever somebody wanted to talk about it in these scientific meetings, they would clip out an image from the movie 2001: A Space Odyssey, which had been made decades before, because the best portrayal of that was actually from a movie. So these are interesting things. It's an excellent question. Thank you for asking that.
Yeah, I mean, if I can say, I mean, not only is it a great question, but the reality is, if you guys go back to your Netflix and you pull a series, you probably never heard of it. It's called Star Trek, and Star Trek is a series that people that my age might be able to relate to, where they had these things called aliens and rockets, and they even were able to move people from one place to another using wizardry in science. But what has happened is that, you know, when you look at the way they communicated with their little flip, what they call the flip communicators, I mean, those are replicas of the old Motorola cell phones that are now so old, we don't even consider that as technology anymore. And what we have noticed is that science fiction has become science fact. And that's because of the creative minds of the people who put together the Star Trek series. So now what I've noticed is that in the old days, people used their creativity and they put programs on. Nowadays, they are so focused on accuracy that they don't take creative license enough. And that means that, yes, if they are going to portray a ship, they are going to try and portray a realistic one, and they're not going to think too much outside of the box, because people are going to go, oh, that's so unrealistic. And already when I interview astronauts and I interview people from NASA and from ESA, they will always tell me which aspects of the movies were unrealistic. But the reality is that sometimes we need that whimsical, outside of the box thinking to inspire people to say, you know, that's not possible, but something that is similar is. And let's maybe look at that. I mean, when people watch rockets flying off and then they would come and land in the ocean, along comes Elon Musk and says, why don't we get a vertical rocket to land back on the launch pad? I mean, that was just the most insane thing. And if you actually picture a vertical rocket and you're thinking, how do you control this thing to actually land vertically? It's mind-blowing. But yet he managed to do it. And I think that was based on some of the creative things he might have seen. So it would be very sad if we only had accurate portrayals of where we are going. And of course, we haven't been to space, to Mars yet from a human point of view. So yes, there will be some creative license. And already we've had a couple of movies that are a little interpretive of, you know, the storms, the dust storms that we have. We've had Jim Green, the chief NASA scientist, tell us that no, the dust storms the dust is so fine that you wouldn't even know the dust was going over you if there was a dust storm, and it wouldn't be like in the movie with what was it called? It was called
The Martian.
The Martian. There we go. With it'll come to me. I can picture his face. You know who I'm talking about? Yes.
I do. I can't remember his name right this minute either.
It's that time of day. But what is fascinating is that, you know, we do need that kind of creativity to spark ideas. And the group wasn't here, Ms. McNulty's group was not here earlier. But can you just tell us a little bit more about this organization that you run? Maybe give us a little bit of context in terms of the history, and then tell us about some of these art competitions that these students can take part in.
Okay, so as I was explaining earlier, I was a scientist at NASA, and while I was there, I really felt that we needed to do a better job communicating about the future of space exploration and getting everyone engaged in that future. So I was actually on the scientific planning committee for an international space research meeting, and it was a difficult time. It was very much a transition time for space exploration. The shuttle was going away, and everyone was thinking about the next thing. And so the science planner said, let's make it the next golden age of human spaceflight. And somehow this was a light bulb moment for me, you know, just like out of the movies, when I felt like we really needed to engage those who were going to carry out that golden age. So it's those of you in Holland Middle School right now are the ones who are actually going to carry out that future. And if we don't engage you in some way in that future, you're not going to prepare yourself and you're not going to be interested in contributing. And so I needed a common language that could create a dialogue across the generations and across the national borders. And so I selected art. And when I say art, I mean multimedia. So it's music, it's films, it's literature, it's visual art. And that was the first Humans in Space Youth Art Competition. It was held in Houston. Then a couple of years later, we did something similar, and it wasn't held in Houston. It had a live performance event when the contest was over in Houston. Then we did it again when the German Space Agency was running this international meeting, and they also wanted to reach out worldwide and engage young people in the future of space exploration. So it was clear that it was a decent model. It was at the appropriate time. It was timely in this interest in developing more than just facts and analytical skills, but also the abilities of people to be better communicators and more creative. And it was also the right time in space exploration. So that was the Humans in Space art program. And about 7 years later, I spun that work off to be managed under our nonprofit, SciArt Exchange. So that's at sciartexchange.org. And we are now continuing to hold international contests about the future of space exploration and to weave all.
It's nice how the music cut out, like, hey, she's on stage, so let's start the show. I realize that there's still people out there and there still might be lunching, so let me start with an announcement. Please stay until the very end if you can, because I do believe that the last panel about what next will be very interesting. I've been talking to the others, I know what I'm going to say. I recommend that you stay and experience it real life and ask us about, our what next ideas. Now, the next panel is about launching Mars, using social media to inform and inspire. I know that it can make a difference in social media, and sometimes you have a hit. Most of the times I have a miss in the sense that I post something and my very closest friends react and nobody else, even if it's something that's interesting. But how to do it and how to make it work for us is something Karina Perez, who's going to moderate the next panel, is going to talk us through. Now, Karina knows her way around politics on the Hill. She's conscious of the biases that are there and that society has against those outside the norm. She's used to handle public policy for a major American city and hosted a great number of panels on pop culture, next to the subjects of science, politics, and diversity, and that I just mentioned. Today, Karina and her panel will let us dive into the social media and what it can do for Mars. Karina and your panel, please come out.
You're on.
Oh, is the mic on? Perfect. So, welcome everyone. Thank you for coming tonight. Well, tonight. I'm already thinking it's tonight. So welcome to the Launching Mars Using Social Media to Inform and Inspire. Before I introduce your amazing panelists, let me tell you a little bit about myself and why I'm here. So my name's Karina Perez, and I work for the Aerospace Industries Association. Some of you might know it as AIA. I've been hosting similar panels throughout Comic-Cons at Southern California, but I was very excited to be able to do this at Humans to Mars, since it is a passion of mine to inspire the next gen to pursue this type of things. And just a little bit of a background, AIA is actually celebrating 100 years of advocating on behalf of the aerospace industry. And so in honor of that, we released a study called What's Next for the Aerospace and Defense Industry, A Vision of 2050, where we look at the future of the industry, the trends, technologies, and the opportunities we believe will be available. But we really can't get there without inspiring the next generation. We really can't get there without industry and without government working together. And what is best than to use social media to inspire those people and show them what we can actually do? With that said, let me introduce you to these amazing individuals who they will inspire the future generation and get us to Mars. Let me start with Kelly Jardy, who is an aerospace and defense professional and a popular science communicator. I'm sure you've all seen all her photos and her amazing dresses. She has worked with DARPA, Masten Space Systems, the Commercial Spaceflight Federation, and she serves on the Defense Council for the Truman National Security Project. Her work on bioastronautics research has been featured across a broad range of television and media, including guest appearances on ABC's The View and Nightlife. She also has profiles in Vogue, Popular Mechanics, and the New York Times. Wow. Next we have, we switched up a little bit. We have Raquel Nuno, who is a planetary scientist and science educator at UCLA. She is the creator of The Space Geologist, where she educates her followers on space exploration topics and chronicles her life as a scientist. And on the side, she likes to spend her days providing early astronaut training for her toddlers. I feel like I need to sign up. That is my level of training, so let's talk after this.
Welcome anytime.
Then we have Ron Sparkman, who is the founder and editor-in-chief of Stardom, a space media company who I'm sure you've seen throughout all the social media on Explore Mars. He's been running it throughout the week. I think it's the weekend. See where I am now.
We're hoping for the weekend.
Ready for the weekend.
Ready for it, right?
He also was the co-creator of I Love Mars, one of the largest communities of Mars for Mars fans on social media. And last but not least, we have Rich Cooper, who is the Vice President of Strategic Communications and Outreach for the Space Foundation. That is where he leads a team who is working to tell the story of the next great human adventure in space. That's amazing. Prior to joining the Space Foundation in September of last year, he held a senior position at SAS, the U.S. Chamber of Commerce, Homeland Security, U.S. Department, NASA, and other private sector companies. He's also a frequent media contributor to international, national, and issue outlets that range on plenty of issues, but he's presently the editor at large at Homeland Security Today. How do you have any time to do anything?
That and 3 teenagers. On Netflix.
And
Netflix, yes.
Perfect. So with all those introductions out of the way, let me start with the questions. One of the most important questions that I'll start with, since it's social media, what's your favorite emoji? I'm kidding. But you will have to answer this. But your first question is, you all work for incredible organizations, and you're like UCLA, Space Foundation, things of that nature. But how do you get here, and how did you choose to focus on science communication?
So I can kick us off, and in the spirit of social media and being like totally transparent, I'm going to let everyone know that I have a microphone tucked into my Spanx right now. So if I'm shifting uncomfortably, that's what's going on. But so thank you for the kind introduction, and it's so awesome to be here. So like Karina said, I started out in aerospace and defense and stumbled my way onto social media and found a lot of like-minded folks along the way. Personally and professionally, I have always dedicated myself to expanding our footprint in the solar system. On the professional side, that's working with companies like Masten and perfecting precision landing technologies for that future pinpoint landing on Mars. On the personal side, it was bioastronautics research and testing spacesuits, being a part of the publishable research that will help us advance our footprint in the solar system. And social media has been the way that I've been able to bring everyone along for the ride and also start to moving from the popularity of social media to the influence of social media and using that to really try to advance some outcomes that we're trying to see. Get in the door to the people who are decision making, really influence the public to understand why space is not only exciting, but it's also essential. And so that's really, I'm looking forward to the discussion. I know we'll have time for questions at the end, but that's sort of my entree to social media.
Yeah, I can, just to add on to that, I think that's a really good way to, try to influence the future. But for what I saw for me was I was trying to educate my students. And then I saw a quote somewhere that said that over 68% of US adults were getting the news from social media. And so to me, I'm trying to disseminate information. I'm trying to tell people about the science research that we're doing and the exciting things that are happening in space. And I thought, well, if people are consuming that information online through social media, I can help. There's a lot of misinformation out there, and I can put out the true information and the correct information, and then people will consume it that way. So for me, I came at it from, I know that's where people are consuming news, and if I can help put out good news out there, that's what I want to do.
For me, it was everything that I've done has been based around social media. My DJ career took off because I was able to utilize social media to get my name out there, present myself in a way that I hadn't been able to before. So once I figured out I was able to utilize that, once I fell in love with space and science, I'm the only person on this stage that probably doesn't have a degree in space and science yet. Yeah, well, see, and that's it. It has allowed me to have a voice and say, I know that I don't understand these things. Where am I going to go? That was the basis of Stardom when I started it. I watched Cosmos and said, okay, now what? What do I do after this? I'm obsessed with this. And I jumped into the next thing and tried to watch The Inexplicable Universe by Neil deGrasse Tyson, and I didn't understand any of it. What's a quark? What are these things? And so I jumped from one side to the other. And I wanted to put together a list of the things that I did that would allow me to get the information that I got out to other people. So once that happened, I utilized social media, and it started building up from there. And then I realized that there's a lot of people out there like me who are nerdy that want to ask these people questions and want to start out somewhere. So many of these interviews that are done are complex, and why not start out with asking somebody like Alan Stern, what is a planetary scientist? So that way people can find out about these things and understand what they are. She educated me a few moments ago about the fact that it's no longer called astrogeology. It's changed, it's planetary geology. It's awesome. How many people don't know that? So that was kind of the thing, the basis for me that I figured there's a way for me to get that information out there.
We're all products of our environment. And as the old guy here on the stage, I remember life before social media, particularly when it comes to communicating a lot of the different programs. And I remember in my early portion of my career as a NASA contractor and working with some highly technical programs, and a lot of the materials that we would be given again, you often needed a PhD to kind of go through some of this. But whenever you had to take that program and either get it in front of the media to generate coverage or to get public interest, or for that matter to get support for it on the Hill, you really had to condense this down into means that would help people understand why a particular congressman and his district would benefit from a particular investment. And I think social media has been that great decentralizer, that great equalizer that is forcing a lot of technical audiences to, boil it down to how regular people can understand it. I often call this the sweet potato conversation that we often have at our Thanksgiving table, to where you see that older aunt and she looks at you and says, Ron, what do you do for a living? And pass the sweet potatoes. Now, the answer that Ron would give to something like that would be different than what would be maybe posted on LinkedIn or something, or some other sort of formal environment. Or if you're here in Washington, you wouldn't be giving your aunt the OMB response or the congressional testimony. You would be very candidly and politely, I'm sure, Ron, explain to her, well, I connect people to science through multimedia. And okay, I understand what that is. And it is a huge humanizing element of this to help people allow themselves to participate in it. And when I see social media as it is a necessary tool to obviously connect to your audience, but it is also a tool that you've got to be inherently responsible with as well. Particularly, there's lots of people who will give, whether it's fake news or misinformation or not being fully informed. You have to be prepared to make sure that you can explain this in terms that are real, that have facts and have that information, and be prepared to be that advocate. Social media is going to require you to be that full-time sentry and advocate for whatever the issue may be.
Well, I'm very glad you brought up, because a lot of your jobs is to translate very complicated topics and issues in very small snippets. You have a tweet, you have an Instagram story, you have a Snapchat story, you have a 4-minute video. What type of content really helps you to translate all these topics to the general public?
So for me, I'll start. As a planetary geologist, I'm kind of lucky because we have really amazing images from NASA missions. And so the public really engages with those. So when I do post pictures of like, hey, this is the mission that I'm working on. So I work on the NASA's Lunar Reconnaissance Orbiter, and we have amazing images from the camera on board looking at all these different features at the surface. So we have like craters and little mountains, and people just get really excited about that. And then showing them, for example, we have the same thing here on Earth. You know, the basalt that we see on the moon is the same type of basalt that's coming out of Hawaii. So images I find very, very important when I'm trying to share information with people, and they really engage with that. And bringing it back to the Earth, showing that Earth has very similar things happening on it that are on other planetary bodies, people really resonate with that.
No one can beat the space community for visuals. We inspire Hollywood.
Hashtag Hubble.
Literally. And Hubble is literally an instrument that rewrote every astronomy textbook ever. But again, it was the images that sort of unfolded the larger imagination. People were connected to it in ways that, again, if there were an astronomer that had to explain Hubble to a group of folks and didn't give any images, it would be a really boring conversation. And people would not be able to connect. But the minute that you show them the image and recognize that this is out there, it's part of our universe and we're connected to it, there is that immediate connection. And that's where, again, Dr. Tyson has given the speech about we're all made of space dust in that particular way. It's a humanizing piece that, again, makes people feel a larger part of their universe and have that connectivity.
And on the human side, you know, I encourage all the companies that I work with to showcase their workforce too. And it's something that I do on my personal channels. It's not just always the space images, it's me as a woman in the space industry. You know, you can wear glitter Gucci shoes and still train for space flight, right? This isn't, you know, what society tells us are the more frivolous parts of our personalities aren't mutually exclusive. And representation is just so important, and we as an industry have so far to go. If we want to convince the rest of the world that this is important and that this is critical for the species, we as an industry have to be reflective of the rest of the species and show that we have, all a diversity of viewpoints, of people, of everyone. So, you know, that's one area that I plug into very deeply on social media and make it a point to surface the viewpoints and the expertise of underrepresented communities in space and show that this is for everyone. You know, there are folks who you can find a role model in across the industry, across every discipline.
Kelly's point is really powerful because if you've not seen the video that came out this week that NASA put out about the Artemis program and going back to the moon, that video does an incredible job of highlighting the diversity of the space community that is forging this new adventure. Now, again, there's a wonderful film. It's at the Smithsonian number of science centers that has redigitized the 70 millimeter footage of seeing the Apollo 11 mission. And it's really cool to see mission control and what was state of the art, but you're looking at a room full of white guys in white shirts and dark ties and pocket protectors, one woman in the entire room, no one else there in color. But you look at into the workforce, watch any SpaceX launch or watch any other type of launch, and you look at the mission control, and there are students of anywhere in the world can see people that look like them now. And that is very, very powerful to put out so that every kid, parent, taxpayer, whomever they might be, sees themselves reflected in their space program. And that's what I think will make the next journey back to the moon even more exciting. Yes, we've been there, done that, but now there's more people that look like everybody else that are part of it than ever before.
For me, it's been, I am my team, and I am the people that I interview. I get to go on and nerd out with the best scientists in the world, and I don't have that degree, so I'm going to be asking the things that I want everybody else wants to know. Where does this come from? How do we understand these things? I am fascinated by that stuff. But to find somebody that works with that I work with at the Astronomical Society, to find a father and son that have the ability to communicate what it is to be at an astronomical society, to play around with the telescope, what are the ways that we can utilize this? How can I do something, create something, produce something that allows somebody to connect to it? A 14-year-old kid sees another 14-year-old kid teaching them about astronomy. They want to get involved with it. It's a father and son. Now you know it's something that's a family activity. And you can take away all those things of, I want to go out and I want to buy a telescope, a $1,000 telescope. No, get a star map, go outside, go to some dark skies. Don't be afraid to go to your astronomical society. And then it's very similar of utilizing very much the people that are on the stage, of asking someone like Kelly, and we're talking about Project Possum and Possum 13, these projects that are out there, break it down, give us what these things are, because I never thought I could have any sort of dealings with an astronautics program. And now I'm part of one of the best ones in the world, and the diversity is amazing. Alyssa Carson just turned 18. She speaks 4 languages, and she's doing all these amazing things. She inspires me. We're sitting there and doing our homework. I'm doing my pre-calculus, and she's doing physics, calculus-based physics. And then we're all going to get on a micro-G flight later. And I get to do something like that, knowing that I have that ability, and sharing that with people allows them to see what's possible for them. If I can do it, some goofball DJ, you know, why can't you do it? Why can't you go out there and create something? And I think the stories that are around us are what's most important to get out there. And of course, there's the fun stuff like the videos and social media curation of Hubble pictures and those things. But it's all about the stories and the diversity of people and ages, faces that are out there.
And I think it all comes back down to the human connection. And social media does a great thing where you can automatically connect with these people. You can have an interaction. You can ask those questions and see people who look like you within the industry, something that you might not see mainstream, but social media does a really great job of translating. And I highly recommend you all follow everyone on the stage because they do provide that content. And on that, I want to ask, has there been any interaction that has stuck with you from social media? And because you do have those direct interactions with people.
I'll share just one funny story when I was totally unused to getting media attention. This is before I ever did television or anything like that. So years ago, I was doing a rotation at the Mars Desert Research Station, and I was with a crew from JAXA and NASA, and we did a lot of really exciting research, but the thing that stuck with us, and the thing that's still on my Wikipedia page, is that we were the first team to academically prove that you could produce beer on Mars. Okay, so that was our claim to fame. Nice. And all of a sudden, we got this mass media attention, like this little team in the middle of the desert in nowhere. None of us were savvy enough to know what was coming. And so I got a phone call from Playboy. And the woman is on the phone, this is after a rotation, and she was talking to me, she was like, we want to do a feature on you. And already I'm like putting down my croissant. I'm like, okay. And then, you know, partway through the conversation, I'm like already rationalizing in my head, okay, my career's taken a turn, but I'm going to go with it. And she clarifies, no, we want you in the full spacesuit. Like, so there I was, visor down in a spacesuit, like the most covered woman to ever appear in Playboy. And so that has just stuck with me for years, and is still, it's a joke that now my parents always remind me how proud they are of my choices.
And your parents are very proud of that particular appearance.
Yeah.
I will say, yeah.
For me, I think mine was a little bit, it's definitely a personal one. Having a brand and being able to reach out across the world. This young woman had gotten a hold of me. Her name's Yumna Majid, and she is from Pakistan. And her story is incredible that as a teenager, she said that she wanted to start doing outreach in her community, and it was something that was somewhat frowned upon. And she just kept working and kept working and kept working. And I get so many messages from people, and you don't really know. You know, you get somebody that has, you know, somewhat broken English trying to get a hold of you, and it's, okay, what or who is this person? Are they even real? Is this just some, you know, weird thing? And there was something about it, and to hear her story and the way that she has grown, and she has now created her own organization, and she's done all these things. And before she had a personal loss in her life that I know that was really rough for her, and kind of, I think it was one of the things that kept her going, and she keeps facing those challenges. And to watch her do that kind of has helped me get through like my tough patches whenever I've had that kind of connection, to be able to do that, to inspire somebody on the other side of the world that I have nothing. I would have never thought I had anything in common with. Like, I want to get on a plane and go visit her. We've talked about this stuff about possibly filming and doing some of the things we've been doing there. Let me tell your story. I would love to see somebody do very similar to what Anthony Bourdain did with connecting space and science to culture the way that he did it with food and culture. Show these people that are, Pranvera, I can't say her last name right, unfortunately, but she's done an amazing thing where she's done space and astronomy outreach in a country, and it has gotten to such a point that she got to stand in front of her government and ask them for money to build something that will teach space science to her country, and they said yes. She's achieved a dream, and she's in her 20s. And she started with just a telescope and a local outreach. Those stories are incredible, and a lot of that came from her social media presence. I think USA Today has written a story on her. There's so many stories out there like that, and it's amazing to be even in that conversation.
I have a much smaller reach than probably all of you guys. So for me, like I get messages from parents. So I also highlight my life as a mom in science, and that's really important to me, that I'm a woman and I'm a mom, but I'm also a scientist. Usually scientists are portrayed as this one facet of just dude in a white coat and not working with anyone else. And so I try to highlight, no, that's just, science is just one side of my life. There's lots of other things that I'm interested in. And I've had other parents tell me, oh, I show your stories to my daughter every day. She loves seeing a scientist doing what they do every day. She loves knowing that you can be a scientist and you can be a woman and you can have a life outside of it and you can have a family. And that's something that's often not portrayed in traditional media, in movies or TV shows. It's changing, it's definitely changing, but it's so varied. The field is so varied that it's really nice to get those messages saying that I'm inspiring a little girl to going into science because she sees herself as a scientist, because she also wants a family, she wants kids one day, and she thought that she'd have to choose between the two. And this is something that you do really wonderfully as well through your social media channels.
Just a huge plus one to that. That is so important. I also have an 18-month-old at home. Her name is Delta V, so very, very, I mean, it goes deep. but yeah, it's like we were just talking right before the panel that being a woman and a mom in science is like, you know, the Schrodinger's cat of motherhood. You have to parent like you don't have a job, and you have to work like you don't have a family, and that's never showed. Like what the mess that looks like behind the Instagram filter is me and my husband screaming at each other because a flight was delayed and our nanny isn't supposed to stay past 6, and we're like, what are we gonna do with the baby? And you know, that kind of mess behind the scenes. So it's so important that everyone shows what that looks like, and you know, you can achieve it. It takes work, but it's possible.
Use that authenticity, the genuineness if you can. We all show, social media can be the thing that allows you to show the highlights of your life. It allows you to put on a different mask, but the most reaction I'll get is whenever I take the time to say, hey, you know, a few years ago, you know, I was out here, I was living this life. I had no desire to go back to school for anything. And because of a TV show, which is hysterical, you know, I went back, got my GED and part of an astronautics program. I have this platform and I'm able to do these things. And absolutely every person that works for me is smarter than me, more educated than me, 15 years younger than me. And they're all doing these amazing things, and I get to help them share the stories that they're saying because of this platform that I have. And it's incredible to be able to connect with, except for, I met Rich because of what I was doing with social media, and I know these two because of social media. And actually, everybody on this platform really is pretty much from social media, and that is a game changer. There was no way that I could have been in this conversation years ago, and now I get to be a part of it. That's, if I can, then again, you know, to plant that flag yet again, is that anybody can. And that's what's so important about it, is that everybody has a place. The artists have a place. The designers have a place. You know, everybody can be a part of it. Find your place and tell your story, because you might inspire somebody else. You have no idea. Look at Janet.
The International Space Station is the greatest engineering feat we've ever done. A number of nations coming together to put all those pieces together in orbit, 20 years in operation, doing some really incredible science. Best minds in the world making something like that happen. But it took a father and son to deliver what I think was the most humanizing piece of the entire space station mission. Canadian astronaut Chris Hartfeld, with his son, did a music video of David Bowie's classic Space Oddity, Major Tom. And I remember Monday morning driving to work and hearing about something on the radio about there's a new version of Major Tom and it comes from the space station. And that video that went out was put together by clips that Chris had, shot on camera, sent to his son via email. His son put it together. They upload this, and a version of a song that everyone in the space community knows. It has an entirely new set of fans, and it is showing this man in a tin can, as the song goes, on that type of journey. Now, I'm sure David Bowie's copyright attorneys and the record label were all ready to file any number of injunctions to, file copyright infringement. And David Bowie, God bless him, called off the attorneys and said, no, this guy gets it. That particular type of video, I think, did more to humanize the mission on board Space Station than anything that's been done. Now, again, we've had lots of fabulous downlinks to schools and to legislatures and everything else. Those are all great, but when you take a song that crosses generation, made by a cultural icon, by an international astronaut with an international crew going around the world, how can you not feel connected to that? Exactly. And again, it was nothing that was planned by NASA or anybody else. A father on orbit, a son on the ground did that. And I think that is truly one of the most humanizing space pieces that has ever been done, period. That'll be hard to top.
And it's a thing about bringing those images to people, making that connection. And it kind of makes me think about the fact of how the access to space has changed. Not just in general of launching, his access to space has changed in that manner as well, but the access to space for the regular person. Now you take out your phone and you can get a tweet from an astronaut in the International Space Station. They can directly go into your classroom via a web chat. But before, as you mentioned earlier, we hosted an event for the Apollo 11 mission, the Apollo 11 documentary, and I learned that there was a nightly broadcast and people tuned in and you had to tune in, but now you get it immediately. I wonder, what do you guys think is going to happen as we move forward with both technology, social media, and our different space missions? How do you think those connections are going to be made and how the technology will influence that?
As the old guy on the panel, I'm going to raise my hand and get to go first and say the way it used to be. I'm not 60, but over 60 years ago, Life magazine had an exclusive relationship with NASA and the astronauts. They had first access to the families and what was going on. There are these marvelous Life magazine issues. I've got them in my own collection. I know that you, as we were talking, you've got them as well. It gave you this absolutely beautiful, blow-dried, perfectly, the dog, the white picket fence, the perfectly tended yard. It showed you everything was just great with the original 7 astronauts and then the next 9 and everything else. That was, again, an exclusive type of relationship. That will never happen again, for a lot of different reasons. And this past week, we celebrated the 20th anniversary of the first tweet from space with Mike Massimino, okay? We've been doing this now 20 years, and now you can only imagine where this is going to end up going, because we're having people on crew who are regularly updating what's going on, connecting to classrooms, let alone their families. This is going to be a challenge, not just for the governments and the companies that are involved, but it's going to be a absolute, I will call it, brand centric type of effort to pay attention to curating that brand, being vigilant and looking about it. How this is going to be incredibly decentralized going forward, but it's going to be a much more immersive experience that we get to go along for the ride. For years and years and years, whenever you saw a shuttle launch, you only saw it from the angles of the cameras, but now we put a camera on the back of the external tank, turn it upside down, and it was BFU were belted to the external tank and taking off. What would it look like? Well, you finally got that look. Well, now we're being able to capture all of these other images that we get to go along for the ride. And when you think about virtual reality and you think about all the other immersive technologies, hey, wouldn't we all like to go on that ride? We're not going to be able to do that. And that is where the human condition is always about exploring and feeling connected, we get to be a crew member. And that's unparalleled.
And I'll just add, I hope we do all get to do that. I think, like, you know, with the advent of the commercial spaceflight industry in particular, the democratization of access to space, like, that is a game changer. I mean, you know, not only for scientists and academics to be able to finally afford to fly some of their payloads and experiments in representative environments in spaceflight, but also for folks like us, for anyone in this room. Yeah, it might be cost prohibitive today for many of us, but it's not out of reach. The same as a down payment on a home or something, you know, and it'll continue to come down. And as we continue to democratize access to space, to expand Earth's economic sphere, I think we're really going to have the possibility for average citizens to experience spaceflight, to experience the overview effect, to know what that's like and to see themselves in that environment and to experience it.
I think that what I see NASA doing, they're really leaning into the social media side. NASA does these things called NASA Socials, where they invite what they call influencers, so people who have a social media presence, to come out to their sites, to go to launches, to talk to scientists, and they're reaching an audience that they probably have never been able to reach before. You know, they get dancers with millions of followers on Instagram to come out and cover, as journalists would, the launches and the different science that's happening at NASA. And I think that that's really powerful. And I think that they're really leaning into social media. Whereas before, people were more apprehensive. I'm like, well, you know, you don't want to put the wrong information out there. We got to be careful. We got to tell the right story. We can't show the mistakes. But people resonate with the stories. I think the thread in all this panel is how powerful storytelling is, and that's what people listen to stories. Even just an image might be, if there's no story behind it, it kind of loses the excitement and the wonder. And so social media really lets you do that, to tell a story and to bring people along, like you said, and even in immersive experiences along for the ride. Yeah.
I think with, and Kelly makes a great point, we're all going to be able to have the chance to probably go to, well, hopefully we're all going to have the chance to at least go to suborbital space. Making that affordable, the first one of us that, you know, goes, someone average person and does a Facebook Live on the edge of space to kind of tell the flat earthers what we think about them. You have that chance to be able to get out there and show it. It's real people now. There's nothing behind me saying that I'm trying to perpetrate a lie or anything like that. To be able to do that, to utilize what we have to show everyone what's really out there. As soon as we normalize this idea that any and all of us can be a part of the spacefaring culture, that changes everything. Once more and more people are doing it, it's no longer astronauts, it no longer feels elite, that you have to be a genius to be able to do these things, that all of us can go and be a part of that. That changes it all. One of the ideas that I heard, let's jump forward a little bit, of going to Mars is the idea of augmented or virtual reality, that what if there's a camera on the first astronaut that lands on Mars, and as they walk out, you have the ability to, in VR, take those steps with them. That would be mind-blowing. There was an AT&T commercial that said, where will you be? And it shows somebody on a phone watching, somebody walk out on Mars. There's a giant TV screen. You see them, and everybody's seeing, everybody is in it together around the world. It connects people and connected us in ways we can't even imagine. I think it's not just what we can think will happen, it's that we have no idea what that's gonna look like between now and hopefully 2033.
Wow. Well, I mean, even now, we have people, if you look around, there's around 6 live streams going on that connect us directly to people. And space, especially now, is that type of way where if I want to watch a launch, I just pick up my phone and watch it underneath my desk. So people think that I'm doing work.
It's funny you use that example. Several weeks ago at the Goddard Memorial Dinner, the young woman who was the keynote speaker, she was part of a SmallSat or CubeSat team in California. She's graduating high school, on her way to Stanford, going to do absolutely amazing things. Talked about the CubeSat that was being launched by SpaceX. She was in her 3rd period Spanish class watching her payload launch on SpaceX. I'm thinking of all the things I was doing in my third period Spanish class way back when. We certainly didn't have a phone. That was down in the faculty lounge, of course, if you were there, had access to it. But holy cow, this kid is interrupting I would have interrupted anything going in a lesson. My payload is going up now, and being able to do that, that's wonderful. But another point that goes with capturing, we've all talked about all the good things, but there are also the other aspect that, and goes with the challenge, and this is where I really have to give a shout out to the SpaceX team. I was meeting with a member of the SpaceX team a couple weeks ago, and we were sort of talking about social media and the various platforms and communicating with people. And they shared the most downloaded and the most watched video out of the SpaceX library of launches is the video that they encapsulated all of their anomalies. The failures, the rockets that didn't land where they were supposed to land, or land.
Reel.
It was the unscheduled disassembly.
Yes, the unscheduled disassemblies. And again, failure is hard for anybody to accept, but when you do it in what is a very public atmosphere, which social media only amplifies, makes it even a more challenging way to navigate. Elon and his team, I give a lot of credit to that. They didn't make excuses. It was there. It assembled much faster or it disassembled in ways they didn't want it to be. But they put those failures out there to share them, to help them understand that there is hard science behind this. There's a lot of work that's got to go into this. We're going to get smarter as a result of these things. It's not always perfect. And that is, I think, a big challenge I think everybody has seen in social media. It's not always perfect. And I know that's hard for a lot of companies, that you always want to show things are perfect. But in this environment, I've got to give a shout out to SpaceX and other companies who have made sure those failures were out there, but didn't ignore them or try to gloss them over. This is hard stuff, and it is challenging stuff, but we learn from our failures.
And I think that is one of the things is that social media is not just inspiring people to join the industry, but the industry itself is changing because of social media. And a lot of companies are way more open about their workforce, who they have, what they do. I think I've seen Aerojet Rocketdyne and their CEO constantly go to their facilities and talk to their people, what they're actually doing, and demystify a lot of what it is to be in the industry, and opening up the door to what everybody does. It's not just individuals now. I think now the companies themselves are learning about, hey, let me open the door through social media for people to know exactly what we're doing.
Right.
And on that note, I'll let you guys have some closing remarks so we can have a couple of minutes of Q&A.
Well, actually, I would like to go off of that. I think you make a great point, is that the voices are within your company. Emily Calandrelli had an incredible, she closed Hall of Fame last year with her talk, directly telling everybody in there, you need to find the voices in your company and let them tell your story, because they're going to be able to connect with you. Everybody remembered, Bobek for what he did with, hey, it's the guy crying with the mohawk. And if you don't follow him on social media, the man is incredible. He's always sharing amazing things. Emily shared her story of her and her husband are having a child, and she launched it and told the world about it. And she shared the initial reaction when she flipped over the pregnancy test and what she looks like. It's making me kind of tear up now. I've got chills again. We all feel connected to people because of that. We feel connected to her. We feel that her story. And to kind of touch on what Rich said, we've got to go the opposite. We've got to try to stop acting that failure is a bad thing. Fail over and over and over again. Talk about it all the time, because you learn so many lessons from it. I am nothing without my failures. I wouldn't be where I'm at today. If I had succeeded in everything I wanted to do, I wouldn't be here now. I would probably not even care about the space industry. If I wasn't in possibly the worst place in my life whenever I was watching Cosmos, there's no way that I get in the space industry. I'd be fine playing on some decks and goofing off and doing what I was doing. That changes the game, and it allowed me to be able to interact and be able to work with people like Kelly on an amazing program like Possum 13 that's inspiring women in STEM kids to be able to go out there and possibly fly something in a micro G flight. That's a game changer for somebody's life out there, and to be a part of that, there's none of that without social media and being able to tell my story.
Yeah, and closing thoughts for me is I bet every single one of you in this room is known as the space person in your own families and communities. It's a differentiator. If even being at this conference, I'm sure everyone in your network is like, wow, he or she, I don't know what they do, but it's so freaking cool. And, use that, leverage that. You are a space influencer, every single one of you, but, use it to affect change and outcomes, bring people into the conversation. Social media drives politics. Politics drives space policy. We don't have space programs without the will of the people, and the people live on social media. Use your powers wisely.
I just want to say people are hungry for information. People are hungry for science information, for science topics. So give it to them. Social media is such a unique opportunity to do that and do that well, telling your stories, telling your employee stories, and share your failures like both of you mentioned. It's a very awesome opportunity that companies have to do. Yeah.
You're a brand. Every one of you is a brand, and how you curate that brand is in your hands. When you see the iconic brands that we all recognize, the Hershey's, the Coca-Colas, even the NASA meatball, those brands come up visually to you. They bring a number of thoughts and ideas that come to you. Same thing with the social media feed. And that's where, again, being a responsible steward of your brand is critically important, particularly as you go into this arena and connect with other people. If you're not going to curate your brand and you're not going to look after it, there are lots of people who will, impugn and soil your brand. You have to be that steward 24/7, 365, 366 every 4 years, we know. But the point being, you have to take responsibility on that. And that's owning the good with the bad. If you make a mistake, own up to it, and move forward on it. But being humble and being honest about it is going to really be impactful.
So we have one question over there.
Yeah, thank you all for this amazing discussion about communication. And I know I've personally learned so much from you guys. My question pertains to this idea of any and all of us, really to the global community that I think each and every one of you have talked about. This is Humans to Mars Summit. It's not, America to Mars. And my question is, what is your guys' role in connecting with the global community? So with nations that aren't necessarily represented by a big space agency or a lot of money or anything like that. Thank you.
I'm going to take a stab at that. Space Foundation, we host every year the annual Space Symposium. This year we had over 15,000 people show up in Colorado Springs from 40 different countries. I mean it when I say to my team and at the Space Foundation, we get to be the storyteller of the next great human adventure in space. That's NASA, but that's everybody else. That is also commercial. That is academic. That is across the sphere. That is building relationships with those persons and inviting them in to share their story. Lots of countries have space programs, but they may not have, human programs that are launching their citizens up in space. They may be going up on other nations there. But when you take a look at what the Japanese have been doing as far as going out and touching asteroids and doing those types of work, let alone the new Chinese lander on the moon, all of these countries are doing things a little bit differently. And when you can share the same passion to explore things, but see how people do it differently, it starts a great conversation. And I think one of the things that I took away from my Space Symposium experience is being able to sit down and talk to those people and see how they do what they do. And their spacesuits look a little differently. Their missions are planned a little bit differently. Their mission controls are different too. Why is that? And it's a great conversation starter. And the more conversations you can have, and social media allows us to connect to those things and share those stories in ways that might otherwise not get any attention. I think the Chinese have even learned, as they have had their lander out there, the power of the images that weren't just necessarily in instilling their own national pride, but letting the world see, what else can be discovered of what's going on the moon. And they've made some pretty phenomenal discoveries of what they've done. creates a great conversation.
And I think also space is for everyone. And when we go somewhere as humans, not a country, when the U.S. landed on the moon, it was everyone. It was a U.S. effort, but we can all connect. It's back to that human connection. It's, yes, countries are working tirelessly to do their work, but ultimately it's us working. It's humans working there. So we have time for one last question.
If it's short, we can do two. We got 2 minutes.
I'm gonna do two.
So
All
right,
we'll
so-
try to do 1 and 1.
I work at Children's STEAM Museum, and we focus our programming on elementary students. And I'd like to be able to engage older students, high schoolers and middle schoolers who maybe lost interest at STEAM, in STEAM at some point. And how could you guys suggest that we use our social media presence to attract the older kids?
So a couple things, I can take this one quickly. You know, absolutely. Research latest has shown that in particular young girls between 11 and 15 is where they lose interest in science and math for a variety of societal and factors. However, what I think the power of social media can do is reach out to people who you think might engage with them. You know, someone like me, maybe it's not me, maybe it's someone like Raquel who has a background in something like planetary geology, but reach out. I think you'll find that almost all of us are immediately responsive and wanting to engage, you know, happy to visit schools. I do a million Google Hangouts with different classrooms all the time, just chatting about like, where do you see yourself? Like, what planet would you want to go to if you could go anywhere? Like, those are so rewarding. And I think if you take the time to reach out to folks who you think might help, you'll be surprised in finding how many of us are super responsive and willing to do that.
And I think one last thing is reminding them that being in the space industry or being in a STEM industry doesn't necessarily mean you need to have a STEM degree. There is plenty of jobs that are within the industry. You can work in policy, communications, anything and everything you can think of is a part of making the mission happen.
And if I can make a real quick point, one of the things I do all the time, every time I'm in a new city, I'm in a new place, I go on Stardom and I go to the museums and I run around and show the stories and I goof off and show those things. One of the best places, absolute best places that you're gonna see where children are absolutely engaged, their phones are down, is a science museum. Watch them running around Perot, American Museum of Natural History, all these things. There's all these places that they can go to and they're so connected with it. It shows that they love space and science. Show those things. Use your Instagram stories. Use your Snapchat. Use that. Use you know, what you are, the personality, what you're seeing every day. Those things that are inspiring.
We are now being played off like at the Oscars and the Grammys. So before we go, just quickly say your social media handles where they can find you.
Well, I was going to say, can I use my time and let this guy ask a quick question?
We are over time, but
Thank you.
sorry about that. We'll be around.
Find us after.
Yeah, we'll be around. You can find us after.
Okay.
Sorry about that. So quickly, social media handles.
LinkedIn, Facebook, Twitter, all of those things. God, I don't remember them all at this point, but they're all over there. Yeah, and I'll be around afterwards and happy to share a card. I've got it all on my business card.
At Stardom Space, Facebook, Twitter, Instagram, and then on Instagram at The Space Bro.
Instagram, The Space Geologist, and then LinkedIn and Facebook, and what else is there? Yeah, Twitter, yeah, Raquel Nuno, just my name.
And just Kelly Girardi across all platforms.
Follow AIA Speaks. They're a little bit more interesting and I give them content.
And I promise we will put it up on our website of Explore Mars so you can find them. Fair enough?
Thank you.
Thank you.
Thanks.
Okay. This conference is about getting humans on Mars and let them thrive there. Our next speaker, however, is thinking far more in the long run, searching for a way to go beyond by knowing the universe better, much better. With Avi Loeb's long list of accomplishments at Harvard in science, physics, as well as his other duties at the Breakthrough Prize Foundation, I expect him to take us by the hand and show us the path. Avi, the floor is yours.
Thank you very much. So what I'd like to discuss today is
well beyond Mars. Mars is really the very first step in exploring our cosmic neighborhood. With telescopes, we're able to see well beyond the solar system, and we have a very good view of the fact that about a quarter of all the stars in the Milky Way galaxy have a planet like the Earth with surface conditions that are similar to the Earth and potentially having liquid water on the surface and the chemistry of life as we know it. And so one of the fundamental questions is, are we alone? And one way to find out is by going places, not only within the solar system, but beyond. And the reason this question is important is not only to figure out our place in the universe, but also to figure out whether we are the smartest kid on the block. Because if we are not, we can learn something. It might feel like cheating in an exam. We might get answers to challenges from other civilizations, but it can also give us a better perspective about what they were accomplishing over the past billion years or so. Our technology is only, a century old, but if another civilization had 1 billion years to develop space travel, they may teach us how to do it. So there is also a practical benefit. And of course, going to the moon first and then to Mars are the baby steps in this journey to go beyond the boundary of the solar system. And that's what I'll describe in my talk. And you can see Mars here as one of the stepping stones to going beyond, first of all, the Kuiper Belt, the surface that separates the solar wind from the interstellar medium, and then eventually going to the nearest star system. We live on Earth. It's a piece of rock that was left as debris from the formation of the sun. It is our home. We love it. It has beautiful life on it, but only for a while. Ultimately, in less than 1 billion years, the sun will warm up enough to boil off all the oceans on Earth. Clearly, we wouldn't be able to stay here beyond that. But well before that, there might be an asteroid impact, or we might change the planet in a way that would not allow us to continue staying on it. And so there are internal threats that could originate from non-conventional wars, climate change, but also external threats. And we should think more broadly. Currently, all our eggs are in one basket, and we might want to spread our civilization well beyond that. And of course, going to Mars is the first step. One thing to keep in mind is that we feel pretty comfortable here on the surface of the Earth, where the acceleration is 1g. Pilots endeavor in larger accelerations when they board a fighter jet, for example. But if you were to board a spacecraft that accelerates at 1g, it actually can bring you to the speed of light in 1 year. That's an interesting coincidence. The problem is that you need a lot of fuel for that, and it's not practical. But if you were to board a spacecraft for a year that accelerates at 1g, it would feel just as if you are here on the surface of the Earth. It would feel very comfortable. According to Einstein's theory of gravity, there is no difference between a gravitational force and an acceleration of a spacecraft. If you board a free-falling elevator, you don't feel gravity because the elevator is falling together with you. So in principle, the opposite effect from a spacecraft accelerating at 1g would feel just like the force of gravity on the surface of the Earth. And if you do that for 25 years, you could in principle cross the entire universe, because you will get very close to the speed of light. As I mentioned, we know of many planets now around other stars that are in the habitable zone. That's the region around the star where the surface temperature of rocky planets is similar to the Earth, and liquid water may exist. we don't know if any of them has life, and there are ways to remotely sense those planets. But another approach would be to travel to the vicinity of other stars and figure it out from up close. Of course, to have liquid water, the planet also needs to retain its atmosphere, because if you take water ice and put it in space and warm it up, it goes directly into gas phase. We know that from comets. The cometary tails carry the gaseous water vapor that is a result of warming up of the surface of the comet by the sunlight. So in order to have liquid water, you need an external pressure, and that is provided by an atmosphere. Mars lost the atmosphere. That's why we don't see liquid water on its surface right now. And the idea would be to visit a nearby star. The nearest star is Proxima Centauri. It does host a habitable planet, interestingly, that was discovered just a few years ago, Proxima b. The problem is that it's 4 light years away. So it takes light 4 years to travel from us to that planet. If there is anyone out there, they don't know yet the results of the 2016 elections. And this particular star, Proxima Centauri, is a dwarf star, the most abundant type of star in the Milky Way galaxy. The Sun is unusual. It's not the typical star that you find out there. Proxima Centauri is the typical star. It's about 12% of the mass of the Sun. And it has this planet, because it's much fainter, because it's a dwarf star, the habitable zone is closer in. So this planet is 20 times closer to the star, and it actually has a permanent night side and a permanent day side. Because of its proximity to the star, we believe that it's tidally locked. So my daughter said, if we ever go and visit that place, she would like to have 2 homes, one in the permanent night side where she would sleep, and the second in the permanent sunset strip, where you would have sunset forever. And that's where she would have her vacations. The problem is that if you want to reach that planet within our lifetime, it requires the spacecraft to move at a fraction of the speed of light. So in order for the journey to be 20 years, the spacecraft needs to move at a fifth of the speed of light. And the question is, how can you do that? And of course, if we consider other stars, it even takes longer than that. There is a system of 7 planets around the TRAPPIST-1 star, which is a little bit farther away. But as I said, Proxima b offers the prospect for very high values of real estate along the sunset strip. Oops. So just a few words about myself. I grew up on a farm in Israel, collected eggs every afternoon, drove a tractor, and eventually got to Harvard, and now I'm the chair of the astronomy department there. But about 4 years ago, I was approached by Yuri Milner, an entrepreneur with a physics background from Silicon Valley, who encouraged me to think about the possibility of visiting other stars. And he asked me to come up with a suggestion for how we could do that. And within 6 months or so, it looked like there is only one technology that can do it. And that's the technology we are now exploring in the project called Starshot. And it's basically a light sail technology. So how do you launch a spacecraft to a fraction of the speed of light? If you were to use fuel, as we often do with chemical rockets, the problem is that you're limited by the exhaust speed. You're limited to that speed times some logarithmic factor that includes the mass of the fuel relative to the mass of the payload. So you cannot really reach much more than several tens of kilometers per second, and that's pretty much the speed that all the space missions reached. Since Sputnik until New Horizons, the speed didn't change much. And it's basically a limitation of the exhaust speed, the sound speed of the material that leaves the rocket. And the only way to overcome that, and by the way, 30 kilometers per second is a percent of the speed of light. So if you want to reach at least 10% of the speed of light, you need to increase the speed of the spacecraft by a factor of 1,000, 3 orders of magnitude. That's more or less the factor by which technology evolved since Ford's T-car until Sputnik. So that's the factor of 1,000, and it took of order 50 years, and it's about time for us to enhance the speed that we reach by another factor of 1,000. So what is the trick? The trick is to leave the fuel behind and use a sail that is pushed by light. And since it's pushed by light, it can in principle reach the speed of light. This technology is called a light sail, and it has been explored in the past. But in order to reach a fifth of the speed of light, you really need to use a very powerful laser of the order of 100 gigawatt in power over a few minutes. And by the way, this is roughly what was needed for the liftoff of the space shuttle. So it's the same amount of energy, the same amount of time that it took for liftoff of the space shuttle, except it's delivered to a single gram of material. So the idea is to have a very lightweight sail that weighs of the order of a gram or a few grams, have some electronics attached to it that includes navigation, communication devices, and a camera. And all of this can be packaged in a gram nowadays already. And then the spacecraft itself will not be very expensive. It will be roughly the cost of a cell phone. Most of the expense is at the infrastructure needed for the launch, the very powerful laser beam. And you can see an illustration of how, an artist's illustration of how this should work. The idea is that there is a mother spacecraft up there releasing a sail, and then a lot of low-power lasers produce their beams that combine together into a coherent beam that is focused on a scale of a human height, roughly a few meters, and pushes the sail over a few minutes to a distance that is 5 times the distance to the moon, until it reaches a fifth of the speed of light in the direction of the target. And the target could be Proxima b, but it could also be targets within the solar system. It would take such a spacecraft only 3.5 days to reach Pluto, a task that took 9.5 years for New Horizons. So the NASA administrator changed between the launch and the time that New Horizons arrived. Here it will be in the same week. And if there are targets of interest, like a passing interesting object, we could chase it quite easily with this technology. The idea is that once the camera arrives to the, let's say, Proxima b, to that target, it transmits a photograph back towards the Earth, and then a very large set of detectors or a telescope obtains the image. That's a very challenging proposition, and we listed of the order of 25 technological challenges that include many aspects of the project, such as producing a coherent laser beam, making the sail out of material that is strong enough, yet lightweight, designing the shape of the sail such that it will ride in a stable fashion on the laser beam, and of course the electronics and the communication back to Earth. So we are currently in the process of research and development, trying to figure out whether these challenges can be met. And it's an exciting experience to be involved in this project. The main challenge could be policy, because obviously the same laser system could have other capabilities. And one may worry, for example, about the impact of atoms or dust particles along the journey. Turns out that with a relatively thin coating, one can protect the spacecraft from those. So it's not a significant risk. And so the plan right now is to dedicate the next decade to a proof of concept addressing the main challenges of the project, and then get to the second phase where perhaps if everything looks promising, one can construct a prototype of the system and eventually construct the actual system. Now, why aspire to go places very far away? Because in principle, it gives us a better perspective about life in the universe. And I often say to my students in class that looking at the sky teaches you modesty, if you are not already modest enough, because you realize that there are 10 to the power 22 habitable planets in the observable volume of the universe. That's more than the numbers of grains of sand on all beaches on Earth. So if you think about human history, there were kings and emperors that boasted after conquering a small piece of land on Earth. And that's similar to an ant hugging a single grain of sand on the landscape of a huge beach. It's ridiculous. You cannot be proud of that. Now, there is also the practical context, which is there might be a smarter kid on our block. And if we ever establish contact or find evidence, it could be a civilization that is not alive anymore. And I call that space archaeology, basically looking for evidence in the form of burned up surfaces of planets that were covered by photovoltaic cells, looking for the products of a nuclear war that may have taken place on a planet, looking for equipment, technological equipment that may be defunct, that is not communicating anymore. Sort of debris that was left out, just like Voyager 1 and Voyager 2 will become in a while. We will not really benefit from communicating with them. And so there are many ways to find artifacts out there, and one can even look for megastructures. And the idea is that we may learn something in the process. We may learn to better behave with each other, not to initiate a nuclear war, or to monitor our planet and make sure that it's habitable for as long as we can make it habitable. But also learn about technologies. It may well be that biological life is just a phase that eventually, as we witness, robots with artificial intelligence and 3D printers will basically rule the future. And one way to find out is to see these technological entities flying in space that were created by other civilizations that are much more mature than we are. And there happened to be the very first object that came near the Earth that we identified as originating from outside the solar system. We discovered it just a year and a half ago. It's called Oumuamua because it was discovered in Hawaii. At first, everyone thought that it's just a rock, but then we figured out that it's very weird. It's nothing like the comets or asteroids that we have seen before, that were born in the solar system. It's much more extreme in its shape, at least 10 times longer than it is wide. And so in a paper, we suggested that maybe it is a solar sail from another civilization. It turns out that we can search for such things from outside the solar system as meteors. Just a month ago, we wrote a paper with an undergraduate student at Harvard where we analyzed the data on meteors and found one that could have originated from outside the solar system. So we can find things that come from outside the solar system that visit us. And most of the time, it might be just like walking on the beach and looking at seashells that were swept ashore. But every now and then, we might find a plastic bottle, sort of a message in a bottle that we haven't anticipated. And so we should keep an open mind and not pretend that we know the answer in advance. As I often tell my students, science is an opportunity to maintain your childhood curiosity. You don't need to pretend that you know something. You're given a position, you're given a tenure position at a university to be able to explore and make mistakes and check what is out there without worrying about your job. And the mainstream of astronomy is searching for microbial life. Evidence of molecules in the atmospheres of planets that might be indicative of primitive life. But if you look at life on Earth, and in fact we are finishing a textbook on this subject, on the subject of life in the universe right now, if you look at life on Earth, making the first cell out of the soup of chemicals was much more challenging than making a complex form of life out of the first cell on Earth. And so, to me, it's obvious that one should check for both primitive life and intelligent life at the same time without prejudice. We can search for all kinds of artifacts from other civilizations. For example, the city of Tokyo is visible at the edge of the solar system. So if there is anything producing artificial light, we could detect it out there. We could search for oxygen in the atmospheres of planets, but we can also search for industrial pollution. And it could be a signature of a terraforming civilization. But there is a fundamental question. Where is everybody? We haven't seen evidence so far. That's called Fermi's paradox. And one possibility is that these civilizations, based on the way we behave, are short-lived. They think short-term, and they produce self-inflicted wounds that eventually kill them. But even in that case, we can still do space archaeology and find artifacts of these dead civilizations. And my hope is that finding dead civilizations will inspire us to behave better and get our act together. And another hope that I have is that once we exit from the solar system, we will receive a message back, welcome to the Interstellar Club. And we will figure out that there is a lot of traffic out there that we were not aware of. Thank you. I'll be glad to answer a few questions. We still have 2 minutes.
Exactly. I'm a strict taskmaster, so 2 minutes. Grab your chance now.
Hi, how you doing? My biggest question for you, I've been a big fan of Project Starshot for a while now. Of the recent breakthroughs that you were just discussing that you foresee that need to happen over the next decade or two during the R&D phase, which ones do you think would be the most problematic to achieve and circumvent, and why would that be?
The biggest challenge, I mean, one can think of designs of sails and materials that can make a very strong sail that is lightweight. One can also think about the technology needed to build the laser beam. To me, the main challenge would be communication. Because of the vast distance of 4 light years, the thing is that the transmission cannot be very powerful because there is limited amount of power on the spacecraft. And so the signal that will arrive at Earth will be very weak. And we're still in the process of figuring out how to deal with that. You will need a large detector, but we haven't figured out the solution as of yet.
Thank you.
One more question.
Going back to where you ended, looking at distant locations, do you see any potential of using telescopes or detectors at Mars pointed at Earth to look at a place where we know we have life as a way to teach or gain clues about how to look for life in other solar systems?
Yes, definitely. Our imagination is limited by what we know. And so, of course, first thing you want to know, I mean, if you want to go out to the street and try to anticipate what you might find out there, you look at the mirror. So you look at yourself, and then it's not a bad approximation. When you walk out the street, down to the street, you find things that look just like you. However, very often you find things that don't look like you and are quite different. And there is a risk that if you search only for things that look like you, you might be missing things. And so how can you expand your imagination? One way to do that is by creating synthetic life in the laboratory. And there are several groups trying to do that. That could have major benefits to medicine if we understand how to create life in the laboratory. And we are just starting in this process, but one of my colleagues at Harvard, Jack Szostak, is on his way. I mean, he's already a Nobel laureate, but he's working now on producing a synthetic cell in his lab. And he says that working on this problem for several years convinced him that here on Earth, it arose spontaneously. He thinks that understanding how to make life in the laboratory enables him to figure out or be much more positive about the prospects that life emerged spontaneously. And if you think about making cakes, for example, you can start from the same ingredients and mix them in a different order over a different period of time, and you get a completely different cake out of the same ingredients. Earth produced life in one way, right? It's quite possible that there are many paths to making living organisms, and we could explore those. There is no reason why we should assume that there is only one, and that's the only one that can be realized. And so one way to find out is by going out to space and finding life elsewhere and seeing if it's the same as ours. But another is doing it in the lab and then improving your ability to forecast where in the sky you should look, under which circumstances you might get life that is different than the one that Earth produced.
Thank you.
Thank you. Those are deep thoughts. You're now all encouraged to listen to Bob Krohn about his space future education, and he's going to walk us through it. Bob, the floor is yours. Did you get your ticket?
I've got it, yeah. Yeah, I'm Bob Krohn, president of Kepler Space Institute, and I have to thank the leadership, Artemis and Janet, for slipping me in here because you won't find me on your agenda. They said, okay, yeah, we'd love to have you tell us a little bit about what's going to happen on the future of education, but I want to point out that this institute, this Mars Institute, has made the maximum tribute to Artemis by naming a major program after her. I would like to have a special tribute to Janet Ivey, our new president. She's, for 2 decades, she has been educating youth of the world and doing it in such an excellent manner that she has a room full of special awards and trophies for her Janet's plan. And she's been working with us at Kepler Space Institute throughout this whole time too. I'm going to be very short. I promised them I would be, because we in Kepler Space Institute have just begun. As a matter of fact, this week we've opened up a graduate education program. So I'll spend no more than maybe 30 seconds on the entire history of space education, but because humans 200,000 years ago probably looked up at the all the stars and wondered what in the world, what meaning do all those lights have for me? Well, then later on in the 15th, 16th, 17th century, we began to have some scientists who were actually doing research on it, and we picked Johannes Kepler's name for our institute because he's the one who determined the planetary motions. Then we can jump up to Yuri Gagarin and being the first human running around in low Earth orbit in 1961. And we have astronauts living in space since 1998. There has been education for space throughout this whole history. And conferences like this one are dedicated to continuing to do it. Most of you are here because you're either educators yourself, you're technicians, you're scientists, or you are students excited about the experience that's going to be ahead of us all, and you're going to be a part of it. So that's, by the way, Buzz Aldrin and I were born the same year. I'm 89 years old, so is he, and I'm in my 4th career. I retired 3 times, but it's such an exciting future that my wife and partner, Selena Gregory Crone, is here, and we're going to hang in here because we love what we're doing. So how about space future education? Well, yes, awful lot of people are doing it and have been doing it. I'm just going to very briefly point out what we are offering right now for Kepler Space Institute. Why do we really want to go to space? Our position, and most of the space community's position, is it's not because we so much want to. We do want to, but we have to. Because if we don't, the negative impacts for Earth and for people on Earth and the entire humanity are going to be severe. So this book, Space Abundance for Humankind's Needs, kind of summarize. It's one of our first textbooks for anybody signing up, and it covers the fundamental reason of why we're doing it. We're going to space because everything we need for the future of humanity is there, and we're going to capture it. So here's a little overview of our graduate programs. The exciting thing for all of us is that we are literally on the verge of a major space epic. And there's no history for this in the future. The prosperity, even Earth's entire humanity, will depend on how well we do it. Probably the most challenging event humanity has ever undertaken itself. So that's why we're happy to do it. Now, what we have designed into our catalog, and it's now open for application or enrollment. Our major programs will start in September. We have some experimental ones going on right now. But these 8 titles that you see here are all certificate programs, each one with 3 courses in it. We have tried to take a systems approach to being able to include in our programs all the hard and soft sciences. And I think that list that you see there, as far as we can tell right now, pretty well does that. We're into some very interesting new stuff. There is cosmic intelligence, not programmed by computers. Maybe they're started at the Big Bang. We're not sure when it did, but it was identified in 1964 by Dr. Joel Isaacson. I worked with him starting in 1980. We've just had 4 annual conferences on his discovery and the recursive distinctioning fundamental phenomenon, which accounts for why everybody in this room has cognition and can learn. Fascinating subject. It's relevant to the future of computers, biology, singularity, all the things that you've been interested in. We don't have time to leak into it. These are the 4 courses that we have right now beginning. So sign up for it. Go to the website is KeplerSpaceInstitute.com. We're happy to have you sign. We're already talking to people here. There's so many people here that are qualified to be faculty that we're looking forward to working with you. Now, here's kind of the ultimate reason why space is so important. Yehezkel Dror is the co-founder of the Policy Sciences. He's starting back in the 1960s. And we have we published the Journal of Space Philosophy. We founded it in 2012, and this is our latest issue. His entire career is covered, and he is going to be fundamental to our academics because there are 2 or 3 reasons. 1, we want to have a reverence for life. 2, we want to have it in ethical civilizations. And 3, we're going to implement it with the policy sciences. That's kind of the fundamental philosophy we have. Okay. We just published a book on Yehezkel Dror and his entire career. I've worked with him since my own doctoral work back in the 1970s. But here's something that's also basically important. Leadership is the key to success. Not only leadership, but ethical and moral leadership. Every day we see failures there. We're dedicated not only to maintaining it ourselves, but to ensure that the future leadership of space follows it. And we have Hawking with this comment about aggression. Now, I'm going to end right in about 30 seconds, but I want to point out to you just one of our special programs. About 2 years ago, Selena, here, let me show you what Selena's done. Her career is in the congressional record, one of America's civil rights pioneers. She, at age 17, stand up, Selena. At age 17, she started working in the United States Civil Service, and in the 1970s, she was with the United States Air Force. She created the first equal employment opportunity plan, which was implementing the civil rights legislation of the 1965. Anyway, very shortly, that's her background. What are the problems, the pathological parts of humanity that are going to be barriers for space? Here they are. We do not want to replicate the problems we've had on Earth throughout history as we have human settlements in space. So here's kind of the fundamental research question: how to prevent in space kinds of discrimination that have existed on Earth and unfortunately seem to be repeating themselves now as we speak. So leadership and governance is what we're all about with KSI for the Future Space Epic. We won't go into Q&A now, but however, here I am. Email me for Any comments or questions that you have, we'll get you aboard as a student or a faculty member. Thank you.
Thank you, Bob. And about space needing to be the better of us, the better society, all of here know that that's what I believe. Now a little treat, a video of cities in space. Without further ado, fire her up.
Very good, sir. You act like you've done this once or twice.
I've been a professor for 45 years.
Just getting to space is in fact the easiest part, because once you're in space, you actually have to live in it, right? And space wants you dead.
I have learned that through STEAM we can solve many different problems. Altitude convergence, the radar has locked on the ground. Touchdown. Yes. Let's say we are attacked by asteroids. After our probe locates the asteroid.
You guys are here at a really exciting time. We're all talking about space. STEAM is going to help our generation.
We're going to be the new generation in Mars.
It's the closest chance to Earth we have in outside of Earth.
We'll have a colony that can grow and that can move mankind to another place.
Try the new. Correct. Learn.
So we're going to use algae to clean the water if it ever gets dirty.
That is more our thorium reactor.
We had to use like actual research journals and like published papers.
At first, we didn't know about sulfur concrete at all.
We'll get it from other planets and then we'll purify it and then we'll divvy it out to everybody.
To have a truly thriving community, everyone is needed.
One of the first times we ever realized that there are no real wars was when we were in space. If you try hard enough, you can accomplish anything.
Wonderful job, you guys. Everyone is and I'll see you next year.
Now you, go out there in that world. Go build something amazing.
Break here at the Humans to Mars Summit. Hope all of you out there around the world watching us online and those of you here in the auditorium will stick around for a couple more great events that are yet to happen as we really go into the home stretch here at the summit. We're going to hear from John Morris about an organization called Boldly Go, and in a moment he's going to step in and join me to talk about a little more of what Boldly Go does. Yeah, come on over, John, thank you. And then we have that really great lightning round panel that will involve a lot of the major players who have been with us all 3 days here at the Humans to Mars Summit. Stick around for that. We're going to talk about lessons learned over the course of the summit and how we maintain the momentum that all of us care so much about. But John Morris, CEO and I think chairman of the board as well, right?
Sure. Co-founder, along with several other space scientists, and Boldly Go is a nonprofit. It grew out of our experience at NASA and at research universities, and our goal is to bring private funding into the space sciences in order to accelerate the pace of discovery. And we work with universities, industry, and with NASA through public-private partnerships.
Very worthy goal. And you come to this with great credentials. You were the director of astrophysics, right, within the Science Mission Directorate at NASA. And you were project scientist for which instrument on Hubble?
Oh, yes, I got to give a shout out to all the Hubble folks out there. 10 years ago, this week, was the last servicing mission to the Hubble Space Telescope. I've got my, oops, it's on this arm with the, I've got my lucky Cosmic Origins spectrograph shirt, which was installed 10 years ago today on there, and of course our STS 125 pin.
What a great legacy. Now, you're going to talk on stage in a couple of minutes, a few more than a couple, about a mission that I told you yesterday I've been excited about for years and years. But you do have other stuff going on, and I wonder if you could tell us a little bit about what you guys call Project Blue.
Right, and good. It's a great segue from the talk that Avi Loeb just gave, where they want to send a ChipSat out to the Alpha Centauri system. And it would be great to know whether there are planets there. We know about one around Proxima Centauri, and we would like to fly a imaging chronograph mission that's no bigger than something that could fit on your coffee table in order to investigate the habitable zones around Alpha Cen A and B, which are the two sun-like stars in Alpha Centauri. Alpha Centauri has a special proximity to the Earth that the next sun-like star is 2.5 times further away, and you need a telescope that's 2.5 times bigger in order to get the same resolution. And so Project Blue is about trying to see whether there's a blue planet, a pale blue dot, like the Earth, around one or both of the Alpha Centauri stars.
So it may be our closest interstellar neighbor, the various stars of the Centauri system, what, 4.5 light years? That's still an awfully long ways. How can you do this with such a tiny instrument?
It's called wavelength over diameter, and that sets your basic resolution. And you want to go to space to do the experiment because that's where you get the stability in order to do it at visible wavelengths that our eyes can see. And of course, you can have the optics work at their theoretical limit, just like Hubble does. So using a Hubble-like instrument, but much smaller, in a Hubble-like orbit, we can just stare at this one system, and we stare for 2 years. That's one of the keys, is that you take image and image and image after image, and what you're looking for are small variations in the succession of images in order to show a very faint planet moving in its orbit. And you use AI-based software to look for those small variations in an otherwise static, bright scene.
So it's comparable, sounds like, to the Kepler spacecraft, which has been able to discover those thousands of exoplanets because it stared and stared and stared.
That's right. That long time monitoring that's possible in space is a key aspect of this. And Kepler, of course, looked at that same group of stars and saw all those light curves and built up a tremendous number of statistics on the types of planets we may see. And so that's what's also new about trying to do direct imaging of planets around other stars, is we now know that the planetary zoo of possibilities is much broader than we thought before.
Very exciting goal, John. Best of luck with that, and also with the mission that we're going to let you go so you can go get wired up backstage, that you're going to talk to us. So we'll just tease people and say it's called SCIM, and you'll explain in moments, I guess, right?
Yes, thank you very much.
Okay, it's called Boldly Go. I'd give you a Vulcan salute. I'll just have to leave it as live long and prosper.
Yes, thank you very much. And look, we're not subtle about where the reference comes from, but we're inspired by this story you just heard about how space exploration is for the benefit of humanity, and we want to be part of it.
Thank you, John. We'll see you on stage. Okay, we are going to go just for a few more minutes in this little break that we've got, the very last one, with only those 2 segments left that I mentioned, here at the Humans to Mars Summit. Sonia, you want to step on in? Hey.
Hello. We just want to make sure that everybody gets on the stage. John's pre-talk here is a great way to set him up for what he's going to be talking about on stage, and then you and I are going to be closing it out with all those chairs that people are seeing behind us. We're going to do a lightning round to close us out and talk about what the future is and how we're going to get there.
Yeah, be quite a crowd and a great end. If anybody was watching or was here for the summit last year, you may remember that we basically tried to answer the question, why Mars, in this same kind of format, and it worked really well. So we're hoping for the same this time.
Can I pitch something for you too? Aren't you turning a lot of this into your radio show, and where can people find out more? Because I think we all want to know what happens here, taking it a little bit further.
You're very kind.
I am a PR person after all.
And I should be more of one. It's, basically, Planetary Radio, the show that I do, which we think is the most popular independent podcast about space exploration, and is on about 120 public radio stations. Easiest place to find it is the Planetary Society website, planetary.org. And I'm always a little uncomfortable saying that because it's, of course, because of Explore Mars, our sister organization, that we're all here. This is this wonderful event that it happens on an annual basis because of Explore Mars, and we're going to have a part of that big panel that we've got is going to be Chris Carberry, one of the co-founders of Explore Mars and its CEO.
Well, what's great about all these different levels of conversation is that they build on each other and they grow from each other. So this is just 3 days. Your program is easy to find. And, I'm thinking about to 9 a.m. when I did that panel, when we were talking about isolation, and somebody from the audience said, have you thought about letting them use the internet? Having conversations like this available for us at the click of a button allows us to learn, continue learning, and go forward and take us to the next level. We have the Afghan girls robotics team who inspires us every day. There are men and women who, of all generations here, talking about past, present, and future. So it's going to be an exciting conference to finish up this year, but plan for next.
We all still have a lot to learn if we're going to put those boots on Mars and maybe first the moon. And maybe as soon as 2024.
It's like that skip they do on the moon, right? You got to kind of get it going and then push off and go on to the next.
I loved hearing that Buzz kind of pioneered that. They just gave us, yeah. They just gave us the 2-minute warning. The 2 questions that we're going to answer, we'll be saying this again in a few more minutes, are what are the takeaways? And we're only going to ask for 2 from each one of our participants in the first of those lightning rounds, and then ask them how we keep this going, this momentum. I know it's your first H2M, but you surely have felt this over the couple of days you've been here.
Absolutely. I actually learned about this by watching the live stream last year. That's how I got involved. And I reached out to Chris and said I'd love to be part of the conversation. And I think it's really interesting to hear a lot of people say, I want to inspire the next generation. But what's funny and what's interesting to me is that those people were the next generation. So they're the young people who were inspired by 50 years ago, by the Buzzes, by those who built out the fledgling NASA program to what it is now. So not only are they inspiring the people of the future, they're actually kind of honoring our forefathers and mothers as well.
Standing on the shoulders of giants.
That's right.
A word about what you do as your day job as well. It's only fair to turn this around because you have a big job for one of my favorite museums here in town.
I do. I like to tell the museum story outside the museum, and the Freedom Forum Institute is a convener of the First Amendment, the 5 freedoms of the First Amendment, which allow us to come together, have these conversations in an open forum, and really take it forward. So, while we talk about politics and policy a lot of times, allowing us to come together is what the First Amendment allows. And I'm excited to tell that story that we do here at the museum, and of course looking into historical things of how news covered the first draft of history, like the moon landing.
Hopefully we'll extend those freedoms right out to Alpha Centauri.
That's right.
Certainly Mars. I'm told that John Morris is ready to begin the very last of our couple of segments here at the 2019 Humans to Mars Summit, so we'll throw it back to the stage.
Yes, we need to know more about Mars. To get more answers, Mars samples, either rocks or even Mars dust will help us speed forward. John Morris will take us through this daring mission concept to uncover answers about life in our universe, which will propel humanity forward, not just en route to Mars, but which will advance science, technology, and society itself. John, you have the floor.
Thank you very much. Happy to be here. I have to go with my glasses whenever I do anything technical. So this is a mission which was conceived actually in the early 2000s, but it's still relevant today because we really, really want to bring samples back from Mars for a variety of reasons that you've heard of during the course of the conference here. But in particular, in the last couple of years, it has become more and more relevant to the design of long-term Mars habitation and keeping humans in a sustainable habitat there, that we want to understand dust. The scientific results from rovers and remote sensing show that the dust is complicated, and we want to understand potential hazards and other things like that. So this is a concept for returning dust from the atmosphere of Mars without landing, and that's how this particular limited sample return is much cheaper. So here's an iconic Hubble image from 2001 showing Mars on a clear day and then on a global dusty storm taking over the planet. And as we know, last year, one of these buried the Opportunity rover. And so no matter where you go on Mars, you cannot avoid the dust. And so the idea is to bring some home. And so we'd like to get timely dust samples. We want to address science from National Academy reports. There's also a NASA Engineering and Safety Council report recently about the potential hazards of dust. We want to understand Mars geology, et cetera, and also address planetary protection protocols sooner than later, because we know that those will increase in complexity as we do landed sample return and deliberately target search for life and returning those samples to the Earth. And then, of course, we've all been talking about humans going to Mars and the potential consequences if there is a Martian biosphere. So let me go to a video, and the video is a few years old, and so some of the titles for the people have changed, but you will recognize the participants in the video, and they talk a little bit about Mars in general, which I think is good at the end of the conference here.
SCIM, sample collection to investigate Mars.
Mars has been an incredibly fascinating planet for me from a long time. As an undergraduate studying geology in the foothills of the Himalayas, I often wondered about what some of the other planets like Mars and Venus were really like and what rocks from those places were really like.
I have a vivid memory of being a 10-year-old girl standing in my mother's kitchen in Phoenix, Arizona, and looking at the pages of Time magazine and seeing the images from the Viking landers when they set down on the surface of Mars the first time any human-made object had ever landed on Mars. And I saw those pictures and I was drawn in. I wanted to reach out and touch those rocks. I wanted to run my fingers through that soil. And ever since then, I've been pretty obsessed with Mars.
To me, the thing that has always set Mars apart among all planets is that it is the one planet that is most like Earth that we can imagine life as we know it possibly having taken hold there. And so by studying Mars, we can learn about our place in the solar system, our place in the cosmos, and perhaps learn about how life first evolves in ways that are very difficult to do anywhere else.
Well, I was very, very fortunate to be the son of a rocket scientist. My dad worked on the Apollo program when I was very young, and so I grew up with ambition to set the very first boot print down on Mars. I became an astronaut. I flew 5 space shuttle missions, incredible missions up into space. Didn't quite get a chance to land on Mars, but I know that one day SCIM will fly and future astronauts will land on Mars on the shoulders of all the work that's come before. So I think this is a very exciting time to be alive and a very exciting mission to pursue.
Beginning its journey to return dust samples from Mars, SCIM first configures itself for its cruise to the Red Planet.
So that's the key reason I've chosen to be involved with the SCIM mission, and that I see it as a high reward compared to the risk. The system development is amenable to streamlined management because it's fundamentally based on technical factors that can be controlled rather than risk factors that need to be managed. We have control of the mission because we have control not only the requirements but also the method of implementation. Technology is also proven, so we are in an evolutionary rather than revolutionary mode of development. And finally, with Lockheed Martin, we have a proven partner.
After its initial cruise to Mars, SCIM prepares to collect its dust samples during its Mars Aeropass by ejecting the covers from its aerogel collectors and stowing its antenna and solar arrays. The cone-shaped SCIM spacecraft soars 14,000 miles per hour at a shallow angle through the Martian atmosphere, collecting its dust samples about 25 miles above the surface. A slow roll keeps the spacecraft stable, while the aerogel collectors capture impacting dust towards the aft end of the spacecraft, where temperatures are much lower than at the nose. SCIM emerges from the Martian atmosphere without going into orbit, reconfigures itself for interplanetary travel, and is directed back to Earth through a deep space thruster burn. As SCIM approaches the Earth after its interplanetary flight, the sample return capsule containing its precious cargo from Mars is ejected from the aft end of the spacecraft and plunges into the Earth's atmosphere. A heat shield protects the capsule during descent, then parachutes deploy to bring the capsule to a gentle desert landing.
And this is when the great science of SCIM begins. Our team of leading scientists will extract the dust grains from the collectors, and we will send them to the best laboratories in the world. We will study the chemistry and the structure of the dust grains and decipher the history of Mars.
So what's going to be amazing is after the capsule lands on Earth, our recovery team will go get it and bring it back, and then we're ready for our preliminary examination. Imagine the first time that we're opening that capsule and really seeing this microscopic rock collection that we brought back from Mars. So the dust on Mars is really special because it forms this global layer. So a scoop of this dust, which is essentially what we'll have, is like a miniature rock collection from Mars that represents all the different rock types in the Martian surface. So just by studying what different kinds of minerals are there in great detail, we'll learn about the diversity of rock types on Mars. By studying how altered and chemically weathered they are, we'll learn about water on Mars. And by understanding specifics of their chemical makeup, we'll learn great details about the Martian environment and whether it might have been hospitable for life.
There are two ways to get a global understanding of Mars. Either you can go to an enormous number of places and bring back samples from all of those places, or you can bring back a sample of something that is from everywhere and distributed everywhere. And that's the ubiquitous Martian dust, the soil. And what that does is it tells you about average Mars, what the bulk composition of the crust is like, and that contains lots of information about how crustal formation processes operate on Mars. Mars is one of 4 terrestrial planets. There's also Mercury and Venus and Earth, and it fits somehow into that overall picture. But to understand how it fits in, you need to understand how the planet works, how it turns itself inside out and creates its crust. And the only way to do that is to understand the composition of the crust globally. And so getting a sample of this dust that's everywhere is going to be an incredibly valuable thing.
So SCIM is an incredibly exciting, groundbreaking mission for a couple of reasons. First of all, it's going to be the first round trip ever to Mars. And secondly, it'll be the first ever sample return from Mars. So in a couple of ways, we'll be completely doing something new.
I'm very, very excited about the SCIM mission as a precursor to human exploration of the red planet. We're going to be taking an aeropass through the upper reaches of the atmosphere, basically characterizing the aerodynamics to help prepare for a human lander at some point in the future, and then also collecting ground truth, actual samples from the red planet, and bringing them home to really ground our observations from satellites as well as robotic probes that have been there. Having samples brought back to Earth, analyzed in our laboratories, and then applying that knowledge to the future designs of spacecraft systems will be key.
So this is the most important thing I'm going to say. SCIM has a mission to achieve out-of-the-box science by deploying in-the-box technology. So the bottom line is that every system element proposed has been done before, and it's already qualified for its application on SCIM.
Bringing samples back from Mars to Earth is so critical because we have the very best equipment in labs here. Most of these pieces of equipment take up a whole laboratory. You couldn't put them on a spacecraft and send them to Mars. We want to tear these dust grains apart, atom by atom, and really understand what they're made of. And to do that, you need to do it in labs on Earth. There's no way around it.
Getting humanity's first glimpse at something no one's ever seen before, whether it's the surface of Pluto or holding in your hand a grain of dust that was captured from Mars. It is compelling stuff. And anytime you do something, you only get to do something for the first time once. And that's what excites me about skin. It's going to be the first Mars sample.
And then the Boldly Go. I did this on my piano. So the key to the mission then is not landing and going during the dusty season, which can be essentially forecast. We have a number of those mapped out now by not just terrestrial observations, but in situ spacecraft in orbit, mapping and on the surface, of course, mapping the opacity and the dust content. So there's upcoming opportunities to execute a mission like this, and this is a tentative profile that's been worked out where you can launch in 2024 timeframe, do your Aeropass in 2025, and be back on Earth with samples by 2027. And the neat thing about this particular opportunity, which is worked out when they do these trajectory forecasts, is this particular one has a free return trajectory where your delta V from Mars is 0 nominally. Now, of course, you have to take some fuel because you probably won't be 0.000. You'll probably have a small deviation that you'll need to correct. But in the original incarnation of the SCIM mission, at least a third of the volume was just the fuel to get home. And so now if that is an order of magnitude less, you can start to make a smaller space vehicle with less mass. And in fact, what we hope to do is make it such that we might be able to fit co-manifested with other spacecraft that are going to Mars. So this is a synopsis of the fact that we can target the dusty seasons when these occur on Mars with our launch date and our Aeropass. We have mission design, which is predicated on previous missions like the Stardust mission that went and captured dust particles from a comet's tail in aerogel. That's the technique we use. There have been wind tunnel tests of the shape, and this shape goes back all the way to the 50s. It's a Langley shape. And this is a lot more like a vehicle that might take humans to the surface at Mars. And so there's interest in outfitting the aeroshell out here with the type of sensors that you would put on Mars Science Laboratory or the Mars 2020 rover, but this would have a different shape and take those initial readings. And then, as I mentioned, there's wind tunnel tests and temperature simulations, so we understand the mission well. And so these are the key features that we can bring home. Hundreds of roughly 10 micron particles and a couple thousand smaller particles. The kind of samples we need to understand the makeup of the dust. We would push the planetary protection protocols, which, as you heard Lisa Pratt here say, there's a lot of work to do, and doing things from the landed Mars sample return is a high level of complexity in both forward and backward contamination. This is much easier in forward contamination. It's more like an orbiter mission, and then we only worry about the backward contamination. And there's probably no more benign situation of returning samples to the Earth than from the upper atmosphere of Mars. And so it moves the process along. We look at doing this with public-private partnership, and you could even implement this as a service, like they're doing with CLIPS. It's not that there's a commercial market for doing these missions over and over. However, industry knows how to do this. And we could do this with a lot less overhead than a typical mission funded by NASA. And finally, as I mentioned, we might be able to co-manifest by shrinking the vehicle. And everybody knows we want to have a comm relay at Mars. We all know that, and we're looking out into the mid and late 20s time frame. And we would love to have something there so we're not relying on spacecraft that are literally 2 decades old in order to provide those relay services. So thank you very much, and let's go bring Mars home. Thank you. Go. Sure.
Okay.
You want to run up to the microphone?
I love this. You got it down to the simplest common denominators. It can be done on a low budget. My last job in corporate world was international sales manager of a telecom company. My engineer would come in when I'd made a mistake and say, "Jack, what's wrong with this picture?" What's wrong with this picture is possibly at the point of reentry, one of those vessels holding that dust breaks loose and falls into the Earth's atmosphere. Okay? I'm just saying, a contingency, okay? I'll repeat it. Your own reentry, one of those vessels holding the dust breaks open and spills all that dust into the Earth's atmosphere. Just a possibility.
Right. This is the planetary protection protocols, in that we would have a design that doesn't do that. You would have to make sure that you don't have a catastrophic failure on Earth return. Again, this, if people are familiar with the Earth return, there was Genesis and then there was Stardust. One of them, the first, failed to have its parachutes deploy. The second one went fine. And we'll have OSIRIS-REx and other samples returned, and it's that heritage that we build on. And then we would have a return system that avoids the catastrophic situation you're talking about by design. But thanks for the reminder. One other question?
Yes, given that scenario, wouldn't it be a consideration, even without that scenario, to have a place in orbit around Earth where you first bring the materials back so you can do an initial assessment of how dangerous or not dangerous they are. Then you bring it down to the Earth for further assessment.
There are people in the audience and on the next panel and who have spoken previously who could address that issue very directly, because they live this issue of planetary protection and how to mitigate the risks. This is a huge issue because it's partially psychological and not just technical. And the idea is, some people think that we're going to do our Mars sample return with astronauts' boots on the ground on Mars and returning to the habitat for analysis in order to keep the Earth's biosphere isolated. There are other ideas for capturing in cislunar space or low Earth orbit in order to look at the samples before returning them to Earth. This concept doesn't have propulsion to do that, but we do follow the protocols, as you see when you have a little return spacecraft which is disconnected from anything that touched Mars, and the mothership goes off into infinity. And so this idea that we would examine returned samples off-world before putting them on the ground is something that people are thinking about, and that was part of the discussion of the Lunar Gateway. So we'll see how that evolves and how these protocols go along, and it will definitely be an international effort to work all these out. And I think Lisa Pratt is right on top of this kind of consideration.
Thank you.
But thanks again, everyone.
Thank you. Last panel. For a number of years now, this conference has benefited from Matt Kaplan's know-how and enthusiasm in how to engage us, and this last panel, I believe, will be no exception. Matt will lead us on a quest of what our next step must be to keep Mars on everyone's mind, whether it be the folks on the Hill, the scientists and engineers in NASA, at space companies, universities, as well as about every other person in the USA and actually on the planet. Matt, lead the way.
Thank you, Artemis. I mentioned it during the break. How many of you were here last year and were stuck around for the Why Mars segment? We're going to attempt to do the exact same thing. So really, it is in the format of maybe this time 2 rather than 1 lightning rounds. And before we get that underway and throw that first question at our distinguished panel, and by the way, Chris Carberry, who, yes, is still up there, there's just too much going on to try and close out the conference, so he sends his regards and apologies, but you'll find him at the reception if you stick around for that right after the close of the summit, but he won't be joining us on the panel. So Artemis over there is going to have the last word as Emerita President of Explore Mars. Let me go down the line here. You know Sonia Gavankar because she's been up there co-hosting the webcast with me for the last 2 days.
It's been loads of fun, and I've been so excited to be learning from you all and to wrap it all up into this conversation right now.
Director of Public Relations, at the Newseum right here in town. Next, Jim Garvin, a participant in this little shindig last year, Chief Scientist of the Goddard Space Flight Center, former chief scientist of all of NASA, and it would probably be quicker to mention give you the list of missions he has not been involved in than to tell you all the ones he's had a part of. You're part of the InSight team right now, right?
Oh, InSight.
Back on Mars, our newest Martian. Next to him is Kelly Girardi, aerospace professional, popular science communicator. You saw her on the Social Media panel. She has flown...
Social Media Planet, let's do that
next.
Sounds
good. Yeah. Social Media Planet. Everybody has their smartphones out all the time.
All the time.
Who has flown multiple microgravity research campaigns as a payload specialist and as a human test subject, which I wish we had time to talk about that. She's a scientist, astronaut candidate with Project Possum, the first crewed suborbital research program. So hoping to get up there pretty soon, I bet.
Hoping, waiting for my ride.
All right. Next in line, you've heard from Joe Cassidy several times of Aerojet Rocketdyne, the gold sponsor of the Humans to Mars Summit, by the way. He is that company's executive director of space. He is also the executive VP of this organization, Explore Mars. He has published nearly 50 papers on advanced space propulsion, because you're going to need that if we're going to make it to Mars again. Allison Renault, next to him, was with NASA HQ, is now an independent consultant and motivational speaker working with nations around the world. You mentioned Croatia to us during one of the breaks out there, countries that want space programs because they know how they're going to benefit their citizens. I also learned from her website, which is AllisonRenault.com, that her 2016 Harvard master's thesis was titled Moon or Mars? What is the next logical step for NASA? I don't know what you concluded, but if it was the moon, somebody was listening. And I also learned that you've got 11 wonderful science-literate children.
That's right.
Wow. Which may be the greatest accomplishment we've heard today.
That's a football team.
And last but far from least, Artemis Westenberg is President Emerita of Explore Mars. Moving on now to create Explore Mars Europe.
Correct.
Hooray. All right, everybody, let's get into it. And we're going to start, Jim, because you are right next door there. We're going to start with you. The first of the questions that we want to ask is for each of you to tell us in as brief a period as possible the 2 most important lessons that you're going to take home from this year's summit? Jim?
Well, I think the first lesson is really a global one that transcends just this summit. And it's simply this: Mars is so much more than a destination. To me, it's a state of mind. And so as we look at the real Mars, as we get close to it for these Ansel Adams-esque images from Curiosity, look at what you see. You see the beauty of the place, but it's more than the place. Hidden in the rockscapes, in the stories, is a magical mystery tour of what really Mars is like. And that's one of the reasons why this conference, this meeting, the meetings we've had for the last 8 or 9 are so important. They make Mars a state of our minds. We're going. And the last, and my final one, is that the moon is not a digression from Mars. It's an essential element of our experience to make Mars that state of mind. And so as we go anywhere, we learn how to go somewhere, that somewhere being Mars. And so for me, I think the moon is really a very special element in the path to Mars. And it's part of the Earth-Moon system, so we got to go somewhere before we go there. And I just remind you one thing: 500 years ago, a bunch of ships sailed around this planet and made the first orbit, and they stopped somewhere before they went. And so I think the moon is a key element in our path to Mars, and I can't wait till these women get to go there.
Bravo, Jim. All right, he set the standard. Kelly, it's your turn.
Okay, I'm going to do one major takeaway, and for me, it's perception right now. I think what we're seeing while this conference is going out, if you look at the partisan politics that are affecting space right now, and if we have to be really clear about what we're up against. You know, we have a program, a roadmap that can get us to Mars. We have, Artemis, we're going to go to the moon, we're going to send a woman, we're going to have, a pathway to Mars. This is the stuff that should unite a nation. And already we're in a political storm that makes it, we'll hope it's likely that it happens, but, it may not. And the thing that we have to understand is that part of this is a failure of our political system. Part of this is a failure of our industry. I think we've been riding the wave of space is cool for a little bit too long and letting all of this excitement speak for itself. And if we're not equipping folks with the mental frameworks and the mental models to understand why it's not only exciting, but also essential, then we're creating fair weather fans, where the subtext is, it's cool, but it's frivolous, or worse, it's the pet project of an old boys club, right? We need to make sure that we're not only lobbying Congress, but we're lobbying the public. And then my final thought is, I think we need to do a better job of equipping our politicians with good, satisfying answers to their constituents who are going to be asking, why are you prioritizing this when funding for my programs are being cut, when Flint still doesn't have clean water, when 20% of the children in the United States have food insecurity? We know that space is an investment in our future. We need to do better about communicating that to everyone.
Brava. All right, we've set a good tone. Joe, you're up.
All right, my lesson learned is the word "and." Heard it a couple of times already. It's not the moon or Mars. It's not commercial or NASA. We're going to all be part of this. So the word is "and." And for a lot of folks, I think they're surprised by this, but we've been looking at the moon as a part of this path to Mars for quite a while. And one of the things I've been most impressed with since the almost 10 years now that I've been involved with the folks at Explore Mars is how they bring communities together. We started off at a point where some of the Mars advocates were saying we need to deorbit the ISS, bring it down, and use all that money to go to Mars. The first conference we held was called ISS and Mars. We put those communities together, and today, those two communities are working very effectively with each other to achieve that goal of going to Mars. And that's exactly what we're doing now with the lunar advocates and the Mars advocates. And I wasn't kidding the other day when I said we got together at AM6 and we like each other. We go drink beer together. So we're going to go to Mars. We're going to go there through the moon, and we'll all do it. We'll all be part of it. International, commercial, academia, NASA, big companies like mine, small companies like some of yours. It's all inclusive. Remember that.
Excellent. I got one more "and." Robots and humans.
And humans, absolutely.
Yeah.
Absolutely, Matt. Very good.
And microbes. they go everywhere.
They do.
With the robots
With
and the
us,
humans.
yeah,
I want to make sure
Allison. Well, it is true. I have 11 children. I'm trying to do my best to put people in the workforce, space workforce. My oldest is a nuclear engineer, My 5th actually is the HR director for Elon Musk. My 7th is pre-med, pediatric space medicine. And number 11 just won the engineering award at her school. So I think it's important that we invest in our own families as well. And I've really enjoyed the conference a lot, and I've taken a lot of notes. One thing that I was thinking is Dr. John Logsdon always brings up, will we ever have another Kennedy moment? And I don't know if we'll have a Kennedy moment, but we have what I would call, there's a Greek word that I love that's called a kairos moment. And a kairos moment is, Webster says, is a time when conditions are right for the accomplishment of a crucial action. And this is what I see listening to all of our panels and all of our speakers, is we have kind of a hyper-convergence suddenly in time where we have political will. I wrote down here we have a great technological foundation, a lot of research. We have billionaires. We have entrepreneurs who are very committed. We have international partnerships. I worked in international at headquarters, and I saw the expansion of partnerships from the UAE to a lot of smaller nations, emerging space nations, coming on board, bringing their expertise. I see, as he was saying, large corporations, as well as the smaller ones that we need in the supply chain. And mostly what I see as I travel the world and speak around the world is I see NASA t-shirts everywhere.
Yeah.
And even in Africa, I see children dressing up like astronauts, hoping one day that their continent will produce the first African astronaut. And we see movies, we see Netflix, we see television shows and documentaries. So the public is very ripe as well. So all this coming together in one big picture, I think as a space force together, we have a choice to make. We can either do strike 3 or we can hit it out of the ballpark.
As my boss, the science guy, says, the best brand the United States has is NASA, which means the best brand is space, really. Artemis, you get to wrap up this one.
Well, for me, what I take from this conference, 7th, and having had conferences since 2011, I think what I learned is that what I feared that Mars would be an all-American party is not going to come to pass. It is indeed going to be an international party, and it might be Europe, and it might be many more, and that's fine, because humanity should go back to the moon and onto Mars, and not just, a group on this continent. So that's what I take from here, and it is heartening, really, really helping me also to transition to my next job. So thank you.
Okay. I'm going to throw one in that I think is worth mentioning because it's my takeaway, and that is the progress that is being made on all the various fronts, all of which are huge challenges and must be met if we're going to first put humans back on the moon very soon and then reach Mars. There was so much evidence across the conference today that this is happening, folks. I mean, from what we're going to eat to what we're going to live in and how we're going to get there. It really is happening. And it's very encouraging. All right, our second question is right up there. Oh, no, it's not actually up there, but I thought it would be on the slide. It is really just how do we take the momentum that we have all felt, that brought all of us here today because we feel it, how do we take that out into the world from the summit and communicate it to others?
Can I start?
Of course, please.
So I hear a lot of we should remember, and I feel like we're shoulding on ourselves a little bit. We are there. We have been talking about this for decades. We have achieved a lot. We're looking back now 50 years and being re-inspired, but a lot of this progress has happened. We're on the cusp of making the big leap. So instead of saying we should, I think we should change the conversation to we will, and when we do. I think that's where we are now.
Hear, hear. I'm glad you jumped in. That's perfect. Jim.
So I think the momentum is everywhere, every second. Come on, we have a rover driving in day 2400 and something. We've done 60,000 orbits of a planet called Mars. It's a state of mind that seriously is like we do for Earth. So it's not a question of momentum. It's a question of applying the momentum in a positive way, like a lot of the colleagues here said, to actually making it happen. And I would just say one thing. We need to keep that momentum going so we can do a robotic round trip and show everyone we're ready. And that robotic round trip will make all the women and men happy. I hope it makes all the commercial interests happy. And it'll make we scientists happy because we want Mars stuff here. It's going to tell us what we need to be ready for when we get to this world, because Mars is not the moon. And so we better be ready for her.
Yeah. Kelly.
Yeah, and just as an addition to my last point, I think we really need to walk the walk of space for all. Because if we're communicating that, we better make sure that folks are seeing themselves represented in our industry. That means no more all-male panels, ever, period. Don't speak on one. Don't have one. You know, this is great representation. It is, but we can do better. Look, we have a long way to go, but it's critical, because if we're going to convince the public that this is worthy and that we need to go, like colleagues have said, the technology is there. We can do this. Now we need to convince everyone else that it's worth it, and it's not just a small elite group of us who are going to benefit from that it really is an investment in the species and not just an all-white male conversation.
Joe.
So I've got a challenge for all of you. It's on you. I agreed with Sonia. We should, or NASA should do this, NASA should do that better, those big companies should do that better. Nope. Look in the mirror, go home tonight. You are the space evangelists. You are the ones who tell the story. Every one of us, every day, get out there, tell that story, tell people about what you do, be proud of it, talk about the progress that's being made. Get online, get on Twitter. Every day, I get the weather from Mars on Twitter every day. I can tell you what the temperature was at Curiosity today. I can tell you what the wind speed was. Just get a couple of those facts and blow people away. My Lyft driver on the way over told me he wanted to be an astronaut when he was growing up, when I told him what I did. And don't be ashamed. Don't think that people will think you're weird. We can do this. And the more we do that, the more that story gets out there and the more support we're going to get. And people will believe that we're still doing a space program. That was the one thing when we stopped flying the shuttle. I had a lot of people come up to me and say, "Oh, you work with NASA? I didn't think we had a space program anymore." Don't let that happen.
To paraphrase the guy who put us on course for the moon the first time, ask not what space can do for you, ask what you can do for space.
Well said.
Allison.
One of the things on Kelly's panel that I really enjoyed was how important it is to share your story or share stories with those people that you interact with every single day. There's a lot of us, a lot of the public, like I used to be, is all I cared about was, am I going to put food on the table tonight? Am I going to get my kids to soccer practice on time? Am I going to get them up and get them to school on time? And so you don't think space is important, and you have to break it down and explain to them. I coach Olympic hopefuls in the sport of gymnastics for the last 20 years. I have about 500 students. And one of the things I pass on to my kids, it's not about medals, it's not about just training and working hard, but what you're doing is physics. Gymnastics is physics. Mass times velocity equals force. That's how the vault works. And they're fighting gravity. And we like to help them relate. Everything they're doing relates to space, it relates to science, relates to physics. So I would just encourage each and every one of you to tell your story, to share it with your friends, your family, because they really don't understand. We're a small fringe community, and it's very, very important that we get the story out and keep the public momentum extremely strong.
Thank you. Artemis, I'm going to surprise you and ask you to hold off, because I want you to have the very last word.
I actually had an assignment for everyone here.
I know, but you're going to get the chance. I just want you to do it as part of your close as we go into the end of the summit, because you're going to wrap it all up for us. Okay?
No.
No. Go for it.
Because this is not part of my wrap-up. If I look into this room, and I know there were more of you over the last 3 days, I have a simple assignment for you. For yes, I agree with Joe, and I agree with all the others. We are the space ambassadors. But that's kind of scary, because yes, people will think you're geeky or weird or whatever. Make it simple. Summer is coming. Organize a street barbecue in your neighborhood. And I'm not propagating that you all need to eat meat Could be only vegetables. What I'm saying is gather your neighbors and talk to them about this. Talk about what you do. I'm sure that all of you are just as enthusiastic about space as I am, so you probably can talk easily about whatever, brings you into this passion of space. Use that. That's what I want you to do. Simple step, because it's like carrying forward. If each and every one of you can inspire one more, then we've grown the numbers. And I bet if you do a street barbecue or some sort of gathering like that, you will probably inspire 2. So yes, do it. Make it simple for yourself. Do this step, and there will be more next year on this conference, but much more important, you will probably have made friends in the neighborhood that you will meet wherever you go, going shopping. It makes for great conversation, and you will grow the base of getting humans truly to Mars.
Thank you, Artemis. And you will still get the last word because you'll be closing out the summit for us in just a few minutes. They have met their assignment. I think they all deserve A's, maybe A+, don't you? Could we give them a hand right now? And we'll now continue the conversation, and we will save a few minutes for questions, or maybe you want to share what you're taking away from the conference and how we continue the momentum. My suggestion for how we continue it is not mine, it's my boss's, the science guy, who says, share the passion, beauty, and joy, the PB&J of science and space. That's what's going to grab people, especially young people who are already scientists. Sonia, you want to get us into a little bit more discussion?
Sure. I would love to wrap this up a little bit in that terms of storytelling and talking about your story and the idea that somehow we lose a fascination of space after we outgrow our elementary years. I went to Space Academy. I had terrible eyes, and my family was like, you are not good at math. You may want to be interested in journalism. And that's what I'm really good at. So I'm really good at storytelling, but so are you. Your level of experience and from where you stand gives you a platform from where you speak. It will re-inspire people for that love of space that they had. So the idea that we lose it can't really be true if Uber drivers are like, if this was just a rocket ship, I would drive it too. People want to know how they fit into this larger picture. They're excited when they hear that ballpoint pens were invented, for the space program, that we got Velcro and Tang from the space program. What are you doing that you're working on that we are going to be using ourselves in our pocket that applies directly to the space program? What can people be doing in their everyday lives that can help you in your job? That brings us all together. So the idea that it's the we against them, or they're not going to understand. Sure, we're not going to understand the intricacies of rocket surgery, as I like to say sometimes. We're not going to understand that, maybe, but we're into it, and we want to know how it works, and we want to know the way that you do your job, because it will help us do our jobs better as well.
Rocket surgery, I love
Rocket
that.
surgery,
Yeah,
That's a good one.
You've never heard that before?
I've never heard that.
You can have it. That is yours.
I do rock surgery.
That's right. Anything that any of the others of you would like to add? And it doesn't have to be on the questions that we've already covered. Jim?
Well, as a follow-on to what Sonia said, we talk about citizen science and all these other engagements. How about, a citizen cause toward getting women and men to Mars? Beyond just the science, because it really is an inclusive activity. The art of doing it will last forever. We have the art from the moon and from being in the shuttle. And the art of the engineering of doing it comes at all levels. It's organic. And so that crowdsourced engineering solution to that small problem that will make those women and men who go better, faster, not necessarily cheaper, I would hope it is, but is part of the equation. So that kind of engagement, I think, is real important, because what I find is most people don't realize, hint, we live in space now.
Right.
Spaceship
Yeah,
Earth.
we're flying through it right now.
We really are.
Yeah.
And bring,
there goes a neutrino.
and
Yeah.
bring somebody along with you. I think
Right.
what we were saying about, when somebody is inspired and somebody shows interest, or you see a young person in your job who may be a minority or different than your upbringing, bring them along with you. Be a conscious advocate for that. I think that Humans to Mars and this conference really has made an effort to make sure, and I'm sure this is Artemis is doing, to make sure that there is representations of different types of people and different ways of thinking of what we all do. I think you have to be conscious of it.
Well said. Yeah.
Picking up on Jim's theme there and Sonia too, one of the things I've said to people before is the reason we go into space is because, as you said, we live in space and we kind of live in a rough neighborhood because there's rocks out there that come in and there's the sun which throws stuff out at us. And so we do things like Parker Solar Probe because we need to learn about that thing. We run the risk of, if we just sit here on Earth and say, all the problems are right down here at the terrestrial level on the surface, that one of those things out there is going to end us.
And pretty soon,
Yeah.
we're going to send the DART mission out there to smack a little rock and see if we can knock it off course a little bit.
That's right.
Yeah.
And Jim was talking this morning about that metallization on that braze joint, which happens to be in the thruster that's going to send that thing to hit DART. So we're working that right now, and it's a real problem.
You all know the old joke, right? Why did the dinosaurs all die?
Didn't have a
They didn't have a space program.
Yep.
A collective one.
Yeah, we better have one.
We better have one.
So following on that,
Kelly.
just one, closing thoughts from me is like something everyone in this room can do, like fight like hell to keep space bipartisan. Yes. People are going to be attacking it now through the next election, through the next 4 years after that election, regardless of the outcome, regardless of all of our individual political beliefs. Hold politicians accountable. Don't let space become the red herring for partisan politics. We have to keep everyone accountable, and that's all of us in this room can remind folks when we see it on Twitter. Call it out. Say, hey, this is valid. Yeah, maybe we don't need to raid Pell Grants. However, it's worth doing. Let's find another solution. So really just keeping that momentum coming, because that's what will tear us apart.
Yeah, and there's one thing I would like to add. There's this slogan of NASA of the 60s. Failure is not an option. I get so angry when I hear that. Is that the way you raised your kids? Probably not. The thing is, failure is always an option. Not trying is not. And that's what we need to tell the audience all around the world and in America. That it's not an option not to try. Yeah, we might fail, but we will have tried.
Yeah, WD-40 is pretty great. WD-39 wasn't.
Duct tape has worked
Duct
many
tape.
times.
Yep.
I've seen it on that great shuttle.
Yeah, including in The Martian.
Right?
Yeah.
Yes.
That's what you
Notwithstanding.
need on Mars is duct tape, potatoes, and air.
There.
Yeah. Let's go ahead and open it up to the audience. We still have a couple of microphones out there in the aisles if anybody wants to get in on this. And then we will let Artemis close this 2019 H2M Summit out. Hi, sir. You're up.
I'm Edmund Mashi. I have a very simple question, the most stupid question.
Go right in close there on the microphone. My hearing's terrible. I don't know if anybody else is having trouble.
Yes, I'm Dr. Edmund Mashi. I'm going to ask a very stupid question. I'm sorry. What's the difference between science, religion, and politics?
Oh,
yeah. Who wants
yes.
Deep one.
Close us out with the big thinking.
Yeah.
Wow.
Jim?
Well, science is just innate curiosity with explanation as part of the end game. So it's just, why did the Nationals lose in baseball? Well, that's a curious question. They didn't today, but if they had.
Luckily.
And so it's fulfilling that curiosity using rules that we develop as we go. And those rules help us predict things that we care about, like, will that bridge stand up as I drive? Can we make enough food for the people? Whatever. So that's science. Politics is how people work together or not. And that's I'll let others comment on. And religion is a state of faith in mind that comes from the individual and how they choose to embody it. One could say going into space is religion. I don't think so. I think it's an inevitable consequence of human destiny. Since we live there, we might as well see the neighborhood. So I hope that's a little piece of...
But it could be a spiritual experience.
It could be.
Oh,
That was
absolutely.
incredible.
And it has been.
It could be spiritual. It should be.
That was very well done.
Did anybody else want to get in on that one?
Yeah, please.
I think Jim
thanks.
covered it.
Yeah,
Maybe I should
Third rail is
that
what that
is a
was.
TED Talk that
Let's
you
go
should-
over
Right,
here.
listen to
Hi.
the TED Talk.
Hi, my name is Bailey. I was not personally part of the Apollo era, but I'm very excited to be part of the Artemis era. What do you guys think is the most important thing for us as the public to get the Apollo era energy into this new era?
Anybody want to tackle that? Recapture that thrill.
If I just maybe say one thing, Apollo was a very unique experience because we went from 0 to 100 in breakneck speed. And now that energy's already there. We're at 100, just not with women and men at Mars
Backed off the
necessarily.
gas a little.
So it's for you guys to capture that energy is just mining it and using it to, as one colleague said, we will do it because it is in our DNA. We're all DNA-bearing organisms. I think we are. But anyway, so I think that's for you. We have the inertia. We have the stuff. Let's go do it.
I also think if you look historically at news coverage, there were 3 major networks. There were 3 channels that were telling the story of space. They were very excited about it, and they were given access to this incredible race that they could cover that had a beginning, a middle, and an end. It is a very noisy environment now. There's a lot of noise when you look at Facebook and social media and Twitter, and there's a lot of things to look at. So it's just noisier, but people are still just as excited. So if you can hone down a little bit into what you're looking at, what you're following, I think you'll find that same enthusiasm is out there.
And I'll tie it to something that Jim Mazur said earlier this morning, and that's back to the constancy of purpose. You know, that with the noisy environment, like Sonia was saying, it's easy to go off in 10 different directions. And if we keep focused down that middle path, you know, there's slight variations. You can tack here and there if you're sailing a sailboat, but you want to keep going in one firm direction. So that's another thing I think for all of us. You know, again, my charge to you is you're the ambassadors. Go do this. But make sure people stay, you know, understand that we're moving. We are making progress, and you can access that information. That's the other nice thing about this new world. The information's all out there. Jim's stuff's out there. You can go find it about his Mars rocks and stuff. He'll show you on his phone at the reception.
You want to see? We have.
And a personal bugaboo. Don't let anybody tell you that NASA and the space program ended with the last space shuttle flight.
Absolutely.
We have been doing marvelous things right on through from that to today, and the best is still ahead.
Yeah.
Okay, we have maybe time for, we'll do 2 more because there are 2 of you in line there, and then we'll let Artemis wrap things up. Hi.
I hope NASA hasn't ended. I'm Lynn Rothschild at NASA Ames, and I hope I still get a paycheck.
I think you're going to deliver some of that synthetic biology that we need.
Absolutely.
need the money.
So, two observations. First of all, I've decided that we are the Apollo generation, not the baby boomers. And I was shocked to discover this morning that hashtag hadn't even been taken. So come on, we're the Apollo generation. But the other observation is, after sitting at this meeting and back to back with a Women in Technology Summit in Copenhagen, the message that comes through over and over, including with this panel, is the critical thing in many of our lives, we're having parents who are supportive. And if you don't have parents who see science and engineering and space as a viable career path, it doesn't matter probably how much you scream and cry, you're going to be put on a trajectory towards finance or medicine or law or whatever. And so we need to have more supportive parents who say, yeah, that's cool, and the kids have got to see that this is a viable career opportunity.
Well said.
Thank you, Lynn.
Well said. Comes down to the parents.
All right, we will go right on to the last audience question of the 2019 HTM.
That's apocryphal.
Okay. I love the excitement that we've got for 2044 and 2033. I want to ask you all about 2045. Where do you see us on Mars in 2045? Where are we on the moon? Where are we in Leo? Are we anywhere else in the solar system, and why?
Great question. I mean, we can go right down the line.
I'm just going to turn my head. I mean, 2045, I have a 6-year-old who absolutely wants to be an astronaut. He had this great moment over spring break where he was in the cockpit of the commuter jet flying us to spring break, and the pilot said, "So you're going to grow up to be an astronaut?" And he goes, "No, I'm going to be," or he said, "Are you going to grow up to be a pilot?" And he said, "No, I'm going to be an astronaut." And so he had made that leap. He's already there. So I think, he's going to be FaceTiming me from Mars, and I'm going to be standing at the airport, waiting to board my commuter jet to one of the planets.
Just be prepared for a long conversation with a lot of pauses if you're talking to him on Mars, but more power to him.
So I think, great comment. First, I think how we are there doesn't even matter. It's that we feel we're there. And if it's a virtual presence, where we're there every second, not just with the weather, but walking down the holodeck on Mars and feeling as if it's part of our lives, entertainment, edutainment, or science-tainment, whatever, I think that's a real possibility. Secondly, I think Mars will have delivered the goods. We will realize from Mars we're not alone. And that microbial universe, which is everywhere, is manifested there in some way that I can't predict. Next, the next few years are going to be unbelievable. We will open our eyes to the universe with James Webb that will inspire us to go far beyond Mars. We won't be talking a few light years. We will be seeing this universe through the lens of Mars, and that's going to make things great. So I hope there's tons of women and men on Mars, and some dogs, making music, so we're all having fun, because that's part of our culture, and that we all feel we're part of it.
When I think of the future, similar to Sonia, I also think of my child. I have a little girl, her name is Delta V, because, runs deep. Right. But when she was 3 months old, I brought her to the Falcon Heavy launch, the first one, and just seeing and hearing the sound barrier break over her head, similar to, I think, what Bailey mentioned about being part of this next generation. I look at the things that she's going to see in these coming decades. It's the democratization of access to space. It's the expansion of Earth's economic sphere. It's the promise and the hope of our entire globe being lifted into a more civilized way of life, and I want that for her, and that drives me in the industry.
What a great start in life. Joe, 2045?
Okay, Robert. So we've been at the moon for 20 years in 2045. So by now we're up and running. We're producing propellant. We're shipping it up to evolved gateway-like propellant depots that are in different NRHO orbits around the moon, and we're using that as our jumping off point to go out to Mars. And based on what Hoppy's laid out, I think we could have about 6 or 7 missions by that point to get to Mars. So we've built our little Antarctic-like research station out at Mars, and we're shipping crews out every 2 years, every synodic period. Somebody else is going out to Mars. That's where I think we're going to be.
Love it. It's like a whole benchmark.
There's no robotic colony.
Well, the robots can do their thing too. I'm sorry, I'm a human guy.
All right.
I want to live in that. I want to live in that world. Allison?
2045. I don't know if I'll be here then. So that's why I keep looking backwards to the next the generation below us. I want to thank, I'm part of the board, and we made a decision to bring the girls from Afghanistan. And, and Elon Musk came through for us to do that. And it's these people that are going to be making the difference. Those girls really made this conference worthwhile, and I think they touched our hearts in a very special way. All the challenges they faced to do what they've done, and we want to thank you all for being here. But I was thinking to myself, how can I tie all my gymnasts back in Oklahoma City to these girls in Afghanistan? How can I inspire all of them? And I found out that these girls want to go to Six Flags. These girls from here at Six Flags of America. And so what I did was I got on the phone last night, and I talked to kind of my Olympic head coach, and I said, find our very best gymnasts between the ages of 10 and 15 and tell them, these girls from Afghanistan who are trying to change the world through space and science, they can either go train or they can find a way to get these girls there. And they chose to take action. They left their practice, and 10 minutes later, these kids between the ages of 10 and 15, and there only were about 12 of them at this point, raised $1,000 that quick. And it's the kids that are going to inspire the kids. And we need to remember that we have to continue, as she said, to invest in our own kids and in those kids before us, and put the time and the money and the effort to inspire them to go to Mars and beyond.
What do you have for that date?
Yeah.
You didn't
You'll
answer.
be there,
Okay.
man. You'll
All
be
right,
around.
all right. I don't just want boots on Mars. I want a shoe store on Mars.
Nice.
And like Jim, maybe even beyond, I want to know that we are not alone in this universe, because that just seems, as somebody said, like an awful lot of wasted space. I want to know that life is as much a part of what the universe is about as any other physical property. Artemis, you get the last word on that question, and you get to take us out of this grand gathering.
Well, 2045, we've been on Mars for 12 years. We've learned to do it the hard way. It will be hard, it will not be easy, but we've learned to persevere, and we will have learned to really trust each other and depend on each other. So in 2045, I believe we will have a better society here on Earth, because we will learn from what we see there. Our vanguard that's on Mars will teach us that it is possible to live with each other, that it is possible to respect each other, that borders are actually something you put on a paper map on your desk, but then in reality, they're not really there, because we're all human beings. That's what I believe.
Nice. Well done, Artemis. For our entire panel, thank you for staying with us to the end. I hope you agree that it was worth it. Artemis?
About this conference and about what we're going to do next. I've said in this conference and in the Why Mars panel of last year's conference, I'm in this to create a better, more equal, more humane society. Now that I'm setting up Explore Mars Europe, I realize that part of creating the more equal society is squarely sitting in my own hands. Janet Ivey, a woman as the new president, is not a happenstance. Henriette van Norel, as my compatriot, is not just luck. Maria Antonietta Perino, as president of Explore Mars Europe, is not coincidence. Men are, of course, part of the European organization, but young women will be just as numerous or more numerous, making up this new branch of our brand of putting humans on Mars. What next starts right here, now. Artemis will lead humanity out of Earth's gravity well. Women will lead the way. We are, all of us, the Artemis generation. That's my word for you. Now for the good news, talking about Artemis, you start thinking about moonshine, right? Or something better than that won't rot your gut. That would be nice. Well, we've thought about that. And the nice thing is, on the other side of this planet, there's this big hunk of Earth. It's called Australia. And they all now invite you, the government of Victoria in Australia, invite you for drinks to celebrate our being able to get onto the moon on Mars soon. How about it?
And it's in the same place we had.
And it's in the same place where we had, or those of us who had lunch. So it's nice, and it's in an open type of space. Yes.
Oh, there's
no idea where
familiar voice.
It will help.
We don't know where we're going.
Yeah.
Except to Mars.
And thank you all. And Chris Carberry, thank you. See you at the reception.
All right.
Great.
Good work.